Yes, ladies and gentlemen, I think we would like to start in a few minutes. I have seen there are still a few people arriving. Therefore, I would like to use the time to say a few words about this session. Let me introduce first the chairman and co-chairman. The original chairman, Mr. N.L. Sharma, was not able to come here, so I will be chairing this session. My name is Martin Wieland, and I'm from Switzerland, and I've been working on seismic aspects of dam design, let me say, since for 50 years. Shall I introduce? Okay. So sorry, I was just told the lady will introduce. Okay, sorry.
Okay, thank you so much, sir. A very good morning, everyone. Welcome back again. And so we are going to start with the session today. Next session, which is technical session, and which is on safety reviews and risk assessment. We have our chairman, Dr. Wieland Martin, chairman ICOL, Committee on Seismic Aspects, and also we have our co-chairman, Ms. Neeta Arora, and she is from Greater SWAC. I welcome you both. And also now I request the chairman of this session to kindly conduct the session, and the floor is handed over to you, sir. Thank you.
Okay, thank you very much for this kind introduction, and sorry for that I was pushing ahead. I'm from Switzerland, so we think we should be on time. Because it's also, let me say, we should go ahead because we have a full program and we do not really want it to start with some delays. We have 7 presentations in 1.5 hours, which is quite a lot. So I would like to ask all presenters here to be strict and to limit their presentation to 12 minutes. Okay, now let me start with the first presentation. It is on seismic analysis of 3D model of Morro Point Arch Dam in the US. So if the presenter comes here, and if you could introduce you briefly, your name. Okay.
Good morning to all of you. I am Deepak Khandelwal. I am research scholar in MNIT Jaipur. And today I am going to present seismic analysis of 3D model of Morro Point Arch Dam. First of all, let's start with the contents. My contents will be as introduction, theory, numerical study, results, then conclusions, then references. First of all, introduction. Morro Point Arch Dam is a typical arch dam representing many realistic arch dams constructed in different regions. A dynamic analysis of the 3D model of the Morro Point Arch Dam with and without water is presented here for the Kern County 1952 earthquake. The analysis is performed in Abacus finite element software. The responses of the dam with and without hydrodynamic effect are compared to highlight the effect of hydrodynamic pressure on the response due to the earthquake. Further, the features of the dams for different mode shapes participating in the responses are investigated. The early work on the seismic analysis of dam was done by the United States Department of the Interior Bureau of Reclamation 1977, Clough, Porter, Chopra, Hall, Folk, Tan, Kamara and other researchers. Morro Point Arch Dam is located on Gunnison River, Colorado, USA. The total height of the dam is 465 feet. The dam is double curvature thin arch dam. Here you can see the arch dam section at the crown cantilever taken from the reference number 8 and the arch dam section taken from my 3D model. Now come to the theory. I did this dynamic analysis using the CAS approach, coupled acoustic structural approach. I use this approach to model in Abacus finite element software. Acoustic deals with the generation, absorption, propagation, reflection and sound pressures wave in the fluid medium. You can see the acoustic wave equation here. The interaction between the dam's upstream surface water foundation rock and the dam base foundation rock is defined by the surface based tie constraints in the abacus. This type of interaction allows both interacting surfaces to remain in contact throughout the simulation process. The constraint applies the same pressure and motion at each node of the acoustic element's fluid surface. The water was modeled as AC3D 8R elements, 3D acoustic continuum elements, and dam and foundation part was modeled using C3D 8R elements with using reduced integration scheme. The analysis is performed in abacus software. The dynamic explicit time integration scheme is adopted. The analysis are performed using the central difference integration method. Reflection pressure wave is characterized by the material of the foundation and this is defined by the wave reflection factor alpha. You can see the value of alpha here is defined as shown on the screen, and different parameters associated with alpha you can also see. In numerical study, I modeled dam, water and the foundation part, and I used properties of dam, foundation and water as used in reference number 8, and I used surface to surface tie type interactions are applied between the dam upstream, surface water, dam bottom foundation rock, reservoir water bottom foundation rock, and zero acoustic pressure is applied at the top surface of the reservoir water. The properties of the foundation are assumed to be same as the properties of the dam, except assuming it as massless. Here you can see the 3D model of the dam. Brown colored is the dam and the green colored is the reservoir water and the blue color is the foundation rock. You can see foundation properties of the dam. You can see different element types, number of elements and number of nodes here. I used Kern County 1952 earthquake. You can see the time history here. Here in this table you can see the results of frequency analysis. The frequency analysis was done for the dam for empty reservoir and for the dam with full reservoir. You can see the various frequencies here. Frequencies are almost matching with the frequencies obtained from Tennant Chopra in 1996. Here you can see arch and cantilever stresses for empty reservoir and full reservoir conditions for 6 strategic points A, B, C, D, E and F. A, B, C points are at the top of the dam. D, E, F points are at the bottom of the dam. Here we can see the arch and cantilever stresses at time t equal to 10.5 second. Stress contours are here. And a comparison of deflections at top central and at 1/3 point of the perimeter, top perimeter of the dam. Now results and discussions. It is seen that the natural frequencies of empty dam are greater than the corresponding dam with a full reservoir. It is expected because in a full reservoir condition, added mass contributes to the free vibration of the dam, resulting in the lowering of the natural frequencies. Further, it is observed that the mode shapes are quite different for the two cases. A significant difference in the mode shapes is observed in the upper half of the dam. Frequency shown within the bracket, as we have already seen by Tennant Chopra in 1996. It is seen that the natural frequencies obtained by the present analysis fairly matches those obtained by Tennant Chopra. The difference in the natural frequencies between the present analysis and that performed by Tennant Chopra is largely attributed to the size of the foundation considered for modeling the dam and foundation. The difference in the maximum value of deflection between an empty reservoir and full reservoir is of the order of 17% with respect to the empty dam condition. The full reservoir case gives a higher value. Deflection in the upstream downstream direction at the 1/3 point at the perimeter of the top arch is also observed. Similar differences are observed. It is seen that arch and cantilever stresses have lower values at top points A, B and C compared to the values at the bottom D, E and F. Arch and cantilever stresses are higher at the bottom points D and F compared to the point E for for the full reservoir condition, while the opposite trend is observed for the empty reservoir condition. It is observed that the cantilever tensile stress are significantly high at the points D and F, that is at the bottom two corner points, whereas for the empty reservoir condition, the cantilever tensile stress is very high at point E, that is the center of the bottom arch. These observations indicate that the dam might undergo cracking at the bottom level, both under the empty and full reservoir condition. It may be noted that arch stresses are competitively less compared to the cantilever stresses at top and bottom points. Thus, the cracking of the dam at bottom would appear as horizontal cracks. Now, conclusions. There exists a considerable difference between first few mode shapes of empty and full reservoir dam condition. The significant difference between mode shape pattern is observed in the upper half of the dam. The fundamental empty reservoir dam frequency fairly matches with those obtained by other authors. The natural frequencies of the full reservoir condition are lower than the empty reservoir condition, as they will be expected. Time histories of deflections at the selected 2 points at the crown of the dam do not significantly vary between the two cases. The absolute maximum deflection for the case of a full reservoir dam is approximately 14 to 17% more than the empty reservoir dam. The pattern of the stress contours at the upstream face of the dam significantly varies for the two cases captured at time t equal to 10.5 second. It is expected that such differences could show up at other time stations also. The comparison of the absolute maximum stresses developed at 6 strategic points show that the maximum stress for both the arch and cantilever stress is at the bottom of the dam. For the present study, it is observed that horizontal tensile cracks are likely to develop at bottom of the arch dam. Here you can see the various references used for the present study. Thank you.
Okay, thank you very much for this presentation. Okay, I've seen you were dealing with the Morro Point Dam already in the 1970s. Okay, this is one of the most studied arch dam probably in the world. Even when I started my career in earthquake engineering, we were referring to this Morro Point Dam model. For a 3D analysis, I understand that it is, let me say, a linear elastic analysis. I would say as a next step, if we have a very high seismicity, we should go into nonlinear analysis by modeling contraction joint opening as a first degree of complexity, and also to model with joint along the dam foundation contact and probably some lift joints. So once more, okay, these were just a few comments. Also for 3D analysis, today we would expect that all three components, earthquake components, would be considered to act at the same time. I don't know if you want to say something.
I think it was a good presentation. The only thing that I found was that you mentioned that the foundation parameters were used same as the dam parameters, although it was used as massless. So this was one point that I thought was interesting in your presentation, because generally we'll have different elastic parameters for the concrete and for the foundation parameters. Thank you.
Okay, once more, thank you very much for this presentation. We would like to proceed to the next one. It is discordant seismicity in the Himalayas. I don't know if the authors are here. I understand that the presentation was not yet uploaded. If somebody is there from a second presentation, please indicate. It seems this is not the case, so therefore we would like to go to the third presentation, which is entitled Evaluation of Seismic Design of Concrete Gravity Dams. I think it is a comparison of various guidelines, and it is the author is Anil Jain. So if you could give your presentation.
इसको फुल स्क्रीन कर दो. Okay. Good morning to all of you. Today I'll be discussing evolution of seismic design of concrete dams with various guidelines like USSE, I-Code and Indian practices. Subsequently, I will present a case of concrete dam in which it will be analyzed as per Indian practice, and then it will be checked with the stipulation as available in I-Code and US Army Corps of Engineers. Dams are, subjected to various hazards, like flood hazards, construction hazards due to poor quality of construction, seismic hazards. If you see this diagram on left side, we have a Tamghar dam in Maharashtra, which is, and it's a downstream phase, you can see a lot of seepage is coming. It's an example of poor construction from where lift joints and through construction joints, water is getting at the downstream phase. On the right side, we have a recently failed dam, Karam Dam, which was failed during partial construction itself. A portion of the embankment dam yielded with partially filled reservoir. Again, an example of poor methodology of construction. On the bottom, we have this section of Koyna Dam, Maharashtra, which I think is the only example in India which got cracked under seismic activity. And you can see the cracks pattern. It's available at mostly on the upstream faces and at kinks. So during earthquake loading, dams are subjected to various damaging circumstances, like liquefaction, where an embankment or foundation loses shear strength when undergoing shaking. And this liquefaction may cause block or rotational sliding, block or rotational failures, which leading to excessive settlement and thereby losing your freeboard. And losing freeboard, which may result in overtopping also. Overtopping failure may also occur due to slope failures or excessive rock mass fall in the reservoirs. Like in Vayan Dam in Italy, an excessive sliding took place within the reservoir, and a large chunk of amount of water which just overtopped passed through other side of the dam. And also during earthquake, induced may also overtop the damage of the structure and damage the structure. Fault rupture may lead to differential settlements and cracking of a dam, leading to internal erosion and enlargement of cracks until failure ultimately results. During earthquake shaking, abutments and foundation may shift and move, allowing the dam to tilt, rotate or slide and lose structural integrity. Slope failures on or near the dam may also allow the reservoir to overtop the dam or failure material to block spillways and outlets. And that recently failed in Colombia. I think it was discussed in one of the presentations, Intuwa Dam in Colombia, where a lot of landslide occurred and it blocked the diversion tunnels, which ultimately results in flooding the underground powerhouse. And dam was saved by very rapid construction through RCC or a rock-filled dam. Often the failure of the dam under seismic loading is attributed to a combination of sequence of the above circumstances. For an example, this on left side we have an embankment dam located in Kutch, Gujarat, which undergone a lot of excessive crash settlement during Bhuj 2001 earthquake, where 7.7 magnitude earthquake occurred. On right side we have this Shikang Dam of Taiwan, in which two bays damaged quite heavily during Chichi earthquake 7.7 of magnitude on Richter scale. On bottom of the slide, this is a Fujinama Dam, which 19 meter high, which failed under Tokuhu Dam of 2011, in which 9 magnitude earthquake occurred. I think this is the 4th largest earthquake in the world history. And this dam completely failed. Though a small dam, the peak acceleration was observed of the order of 0.45 G. And the important thing was the earthquake duration, which was about 100 seconds. And during this earthquake duration, large waves generate within the reservoir, which overtopped the embankment dam, and ultimately embankment dam failed. This is another dam of Jikpingpu Dam in China. It's a 156 meter high rockfill dam, and in 2008 earthquake, which is 7.9 magnitude, it undergone large major quaking and settlement and slides. The peak value of settlement of the dam, of the dam crest was of the order of 744 mm, and the peak value of horizontal displacements towards the right and left abutment was of the order of 226 mm and 106 mm. The peak earthquake acceleration at the top was 20 meter per second square, almost 2 G. And the bedrock acceleration was of the order of 5 meter per second square, of the order of 0.5 G. The originally dam was designed for 0.26 G. But the good thing was there was no catastrophic failure occurred in the dam. After the earthquake event, reservoir was lowered through lower outlets, and a major repair was done, and dam was saved. So we have seen that earthquake hazard has gained recently very importance in the dam industry on account of widespread human and economic losses. And this slide presents the various earthquake parameters, peak ground acceleration earthquake parameters, which was identified for various projects in India, and at different location and seismic zones. And you can see that earthquake magnitude of the order of usually in largest is about 7 to 8 magnitude, and PGA recommended is, this is for the MCA condition, about 0.5 G. So in initial days, evolution of earthquake for the dams was done by just taking orbit value of about 0.1 G. But subsequently, I think in 1970s, various guidelines came up, and a well-designed protocol for the earthquake or seismic design was evolved. It basically comprises of the 4 steps. The first is the selection of the design earthquake and associated ground motions. Second important thing is the establishment of performance level and performance goals. Then analysis methodology for computation of seismic responses. And lastly, interpretation and evaluation of results to assess the dam safety. If you see the design earthquakes as per US Army guidelines for unusual loading, it is operating basis earthquake, and for the extreme loading, it is maximum design earthquake. For ICOLD, recently published a document says, again it is operating basis earthquake for the unusual loading, and then it defines as safety evaluation earthquake, or C, or maximum credible earthquake. And Indian practice is we go for unusual loading for the design basis earthquake and maximum credible earthquake for the extreme loadings. If you see the definition, operating basis earthquake is used to limit the earthquake damages to a dam project, and thereby is mainly a concern of the dam owner. An average return period considered is about 145 years, that is 50% probability of accidents in 100 years. The dam shall remain operable, this is the important thing, the dam shall remain operable after DB, OBE, and only minor easily repairable damages accepted. And the same thing for Indian practices, we go for the design basis earthquake, which is corresponding to 475-year return period flood. It's quite high with the, as per the ICOL and USSC guidelines. And maximum credible earthquake, the MC is largely characteristically a deterministic event, and it is the largest reasonably conceivable earthquake that appears possible along a recognized fault or within a geographical defined tectonic province under the presently known or presumed tectonic framework. The MC is defined as the largest earthquake that can reasonably expected to occur on a specific source based on seismology and geological evidences. And recently ICOL has come out with the safety evaluation earthquake and its 148 bulletin. It is the worst possible ground motion at the dam site under which stability of dam must be ensured and no uncontrolled release of water from the reservoir shall take place, although significant structural damage is accepted. Further, the usage of C has been characteristically different than MC on account of application of a probabilistic approach wherein the choice of return period of event is linked with hazard potential categorization of a dam. As per ENCODE, return period are considered as 1,000, 3,000, 10,000 years for the C depending on the hazard potential. The NCSDB guidelines, which is the Indian practice, consider the C as a probabilistic event of 2475 years return period, considering the high seismicity in India as compared to other parts of the world. C is considered as equivalent to deterministic MC. Now next thing is the performance goals. The first goal is the serviceability. The criteria is the damage.
2 minutes.
Only 2 minutes?
Yes.
Okay, sir. Dam is expected to be serviceable and operable. Damage control, under which we allow certain portions to get damaged and certain portion they go for non-linear conditions, deflections, and the collapse control in which dam should not collapse, uncontrolled release from the dam should not happen. These are the performance goal. And if you see this diagram, which is corresponding to plane strain and plane stresses level, for the elastic limit, it is the serviceability condition, and then we go up to the top. This is defined as a damage control, in which limited non-linearity is allowed, and then later on it comes with the collapse condition. And what are the acceptance criteria? As response spectrum method, it is again DCR ratio is the acceptance criteria where we compare demand and capacity ratios. I am not, now since time is less, I am just skipping this slide. For serviceability, the selection of earthquake for the USSC guidelines, OB, for ICOL it is again OB, 1 in 45 years, Indian condition 1 in 450 years return period. Damage control, MD, return period could be around 1,000, 3,000, 10,000, and ICOL says it's C, and as per ENCODE guideline it's 1,000, 3,000, 10,000 year return period. Indian condition is a return period of 2475, which is largely a deterministic event, restricted to 2475 return period in view of the large PGA envelope of higher return periods of earthquakes available in India. And if you see the method of analysis, for the USSC serviceability condition, it is largely linear elastic analysis. ICOL also recommends linear elastic response spectrum by FEM analysis. And the NCSTP guidelines, we largely go for the pseudostatic analysis based on the site-specific seismic study with triangular distribution of seismic coefficients. Damage control, again it's a linear in which DCR ratio is defined as accepted criteria. And Indian practice also, we go for the linear elastic time history analysis based on the DCR. If DCR criteria are not met, review the dam cross section. And for the Indian condition, as on that, collapse criteria is not fairly defined. An example in which we have considered 100-meter high non-overflow gravity dam with the crest width is about 8 meter, thickness at the base is 91.25 meter. I am not just skipping it. It is a 100-meter high gravity dam, and it is designed as per pseudostatic method compliant to 6512 IS 6512, wherein restricted tensile strength is about of the compressive strength. The design section is then analyzed by response spectrum and linear time history method to check the section is compliant to the acceptance criteria. Pseudo-static analysis, I said, Indian practice, we consider triangular distribution, which at the top is 1.5 of the seismic parameters.
But can you come to a conclusion?
Okay. If you see the results in the pseudo-static are quite acceptable as per the codal provisions. Then FEM analysis using the MIDAS GTX NX was performed, in which the foundation modulus is considered 21230 and the concrete modulus is 2500 MPa. And if we see the results in response spectrum analysis, we found that the maximum tensile strength occurred is 5.6 MPa. And the DCR ratio for the M25 concrete is less than 1.5, which satisfies the stability criteria as discussed earlier. Hence, the gravity dam section as per IS 1893 and 6512 guidelines is safe as per the response spectrum analysis under MCE conditions. Then the time history analysis was performed, and it can be seen that from the legend that the area stress above 5.1 MPa, the tensile stress is approximately 1.1% only. It's the only small area is exceeding. The apparent tensile strength capacity of N25 concrete is estimated as 5.46 MPa after Rafael, and DCR is within the limit. And if then at the critical points at the heel and the upstream kick, the stress execution time was estimated, and it was observed that the stress execution duration for the DCR greater than 1 at the heel and kink is about 2.77 seconds, which is more than the acceptable limit of 0.3 seconds. The stress execution at the toe is not exceeded the acceptable value of 0.3 seconds. The conclusion, 100-meter high gravity dam have been analyzed following NCSDP guidelines. The sole example demonstrates that the pseudo-static model in which seismic parameters considered very triangularly could estimate the 100-meter high dam cross section, which fulfilled the acceptance criteria for MCE condition, barring the high tensile stresses which might have occurred due to singularity effect of FEM analysis. In this example, foundation modulus is equivalent to concrete modulus. However, for the foundation with low modulus, a usual scenario in Himalayan regions, the pseudo-static method may not be estimated the dam cross sections which could withstand the damage control performance criteria. Recommendation, the pseudo-static method is suitable for preliminary estimation and works well with the foundation having elastic modulus as close to the dam material. The time history analysis is required to assess the performance for damage control level where limited cracking is allowed and have well-defined performance criteria in. The NCSTB 2014 guideline does not discuss the safety evaluation earthquake as in ICOL guidelines. NCSDP guidelines only discuss MC by deterministic approach of 1 in 2475 year return period for damage control performance levels. NCSDP guidelines also do not discuss non-linear analysis to assess the extent of cracking in case of acceptance level do not match the damage control performance level. There is need to classify the hazard levels in order to define the CE for different hazard levels. Thank you.
Okay, thank you very much. Unfortunately, we do not have time to comment here, and we would like to proceed just to the next presentation. Okay, this was excellent overview on the state of, let me say, seismic design in India. Now, the presentation number 4 is entitled a comparative study on seismic stability analysis of 2D and 3D concrete gravity dams. I would like to ask the presenter to present this presentation, and could you please introduce yourself and stick to the time, 10 minutes, unfortunately.
Hello. Thank you very much for introducing. So, myself, Dr. Arnab Banerjee, Assistant Professor in IIT Delhi. So, today my talk is a comparative study on the seismic stability analysis of the 2D and 3D concrete gravity dam. So, as all of our previous presenters also mentioned that importance of the seismic analysis of the dam. So, and as you have seen that the Koina is one of the case where we can see in Indian context that a gravity dam has some sort of damage during the earthquake. So obviously that actually tells us that what is the importance of that, and also there are several studies, primarily in IIT Kharagpur also they have carried out the model testing of the concrete cavity dam. You can see that in the right hand side as well. And so if we see the dam system, so it is basically a three-phase system. So we have reservoir, we have soil domain, and we have the gravity dam. And we can model the full thing in either in the 2D or in the 3D. If you see in case of the industry, primarily the 2D analysis is much more popular because it is quickly we can able to do it. It need the less computational effort, and also the less expertise is required for that, and it will give a much better property. So once we are modeling it, so we have to understand that how we are modeling the reservoir domain, as our previous presenter also shows that the acoustic modeling and all those things, and then we can also model the soil domain, and then we can model the gravity dam domain. So this is a three-phase system, and obviously we have to also model the interfaces between all those things. So if we see the loadings what are acting on the dam, so these are primarily like the self weight, hydrostatic pressure, uplift pressure, silt pressure, hydrodynamic forces, and inertial forces are acting on that. And these are the several cases given in 6512, and we can actually able to analyze that. So we have our inbuilt in-house coding which is known as the OptiDam, and we have published that in 2014. So by that way we can actually able to find out what will be an optimized section of the concrete cavity dam, and so by this way we can able to do that, and we use that similar type of section, and then we studied it for the two different cases. One case we are making it as like a complete finite element modeling, where we are modeling the valley also as like a soil domain or the rock domain, whatever you want to call, and then the complete 3D model of the dam. So it consists of the overflow section as well as the non-overflow section. Both the things are there. So you can see the right hand side, so the left hand side shows that the finite element model of the 3D dam, and you can see the right hand side shows the 2D model. So in the 2D model you can see both the picture. So first the top one shows the typical non-overflow section, and bottom one shows the typical overflow section. So now once we have done that, so we have to perform the time history analysis and response spectrum analysis. So for that time history analysis, once we are performing it, we generally have the earthquake data for the rock outcrop. So if you are familiar with that, so rock outcrop means it is given at in that point, and then we have to deconvolute the rock outcrop motion with some transfer function. So first basically we can do the finite Fourier transfer of that excitation motion, then we can multiply with the transfer function to get the Fourier transfer at the base level, and then if we again do the IFFT inverse Fourier transfer, we can able to get what will be the exact ground motion at the base level. So you can see here we have also done that process, the deconvolution process, and we can able to get it. And then the next thing comes into the boundary conditions. So here once we are having the boundary conditions, we have to put here the non-reflecting boundary, because once we are exciting it with some earthquake, then that soil domain should act like a means it should not reflect back the waves, so that if it start reflecting back, then excitation amount of energy will be increased. So we have to ensure that. So for this thing we can use the Kelvin element, and where we can calculate the impedance and we can model it. And for modeling the reservoir, we can adopt the two different approaches. One is like acoustic modeling, acoustic coupling, and another is the Westergaard approach, which is also given in the code. So we have performed the response spectrum analysis, and you can see that the stress contours in that complete dam body. So here obviously we all know that we are always getting the more stress near the hill region, and that is evident very clearly. You can see at the hill part it is quite strong, and then the toe part also we can able to see a stress concentration. And in case of the 3D also we can able to see that completely heel part we can able to get the higher stress concentration. And in case of the overflow section, you can also see that the part from where the sluice are there, so there also the stress concentration can be possible, because there the section is actually small. Now, if you see that time history analysis we are comparing, so in that case, obviously, as we know that once we are performing the time history analysis, generally the less stress can be seen. So here you can see that the contours which are in the same color, and that is quite less and less restricted portion, and here also you can see, but you can notice one very interesting point, that where actually the monolith, the junction between the monolith, there we can see quite a good amount of stress concentration, because if you see there the section has some edge, and that edge portion the stress concentration is increased. And I would also like to mention one point, once we are modeling that 3D thing, in case of the time history, we are using the friction between the two monoliths, because monoliths are not constructed together, they are constructed in a separate manner. So both the monoliths, the simultaneous monoliths are acting as a separate structure. So that portion we have also modeled using the Coulomb friction, and we implement all those things into the abacus, and we run implicit scheme using the Hilbert-Hooke's Taylor integration technique. Then if you compare the results in the display in that case, so we can see that once we are doing the 3D time history analysis, we can see the horizontal displacement is something like 31 and vertical is 51, and same overflow section we can see 34 and 53. So primarily the basic point is that response spectrum gives the more result which is expected, and we can see that in case of the 3D model, our displacement responses are less because it has that friction, internal friction part is also included there. So that's why that portion is giving less, but it has some stress concentration problem in case of the 3D. So finally, if we come into the conclusion that the time period of the 2D and 3D models are quite comparable, we found then the result of the response spectrum analysis, 2D and 3D DAMs are also very analogous. The response spectrum is matched more than the time history method. Effect of the radiation damping, which is given in the Chobra's method in 1971, there you can find the complete procedure of calculating the effective effect of the radiation damping, and then also the dissipation energy due to the contraction joint and all those things we added, and that thing was also elaborated in the paper what we have submitted here. In case of the response spectrum analysis, the effective damping is also developed. Yes, so after that, so 2D idealization of the 3D DAM are always conservative and provided that is if there is no tapered or unsymmetrical base in the dam monolith. But if there is a steep slope, then it is better to investigate go for the 3D. Finally, the 2D elevation is valid if the slope of the canyon is flat and all the monoliths has the flat base. However, in case of the narrow steeped river bed profile, the 3D analysis of the concrete cavity dam is highly recommended. So I would also like to acknowledge my previous professor, late Professor Dikapol, for the several suggestions and some simulations also. So thank you very much to.
Okay, thank you very much for this comparison. It is always interesting because for gravity dam, let me say, the state of a practice is that you would basically do a 2D analysis. Okay, and to see here what is the effect of a 3D analysis. We would think, let me say, also based on our experience, the response spectrum method doesn't have any advantage today in the computational effort because we have software which is doing the time history analysis very efficiently, and the response spectrum analysis of dams, actually you have to consider too many load combinations to get the maximum stresses. For example, so basically our recommendation is not to use a response spectrum method for dam structure, but it would be more appropriate if you would do it for, let me say, gates, spillway gates, and so on. So I would say the response spectrum method is more suitable. And of course, we know the limitation is based on linear elastic behavior with proportional damping, so you cannot include radiation damping effects, and the reservoir only includes incompressible water.
Exactly.
Okay, so this where we commence. So thank you very much. And of course, finally, in the comparison, if we go into a very strong earthquake, we also have to look into the contraction joints, because if you have a low level of earthquake, we would basically, the behavior would be a monolithic behavior, but once you exceed the strength of the joints, you would get into joint movements, this kind of non-linearity. So once more, thank you very much. Yes. Okay,
thank you, sir,
interesting
for the comments.
study, yes. Okay,
Thank you, sir.
good.
All right, we'll now go on to the next topic, which is probabilistic dam breach modeling of Mahi Bajaj Sagar Dam using Monte Carlo simulation technique. This is to be presented by Mr. Jagdish Prasad Patra, Anil Kumar Lohani, Sunil Gurahu, Pankaj Mani, and Rakesh Kumar. So who's presenting, please?
Respected Chairman, Co-Chairman, and esteemed delegates. This paper I am going to present, I am Pankaj Mani, scientist from National Institute of Hydrology. And this I am going to present probabilistic dam breach modeling of Mahi Bajaj Sagar Dam. As we know that dam break analysis generally consists of two components. First is evaluation of the breach outflow hydrograph, and then routing of this breach outflow hydrograph in the downstream reach. For breach outflow hydrograph, the parameter generation or the estimation of the parameter is one of the basic requirement. So generally, there are several regression equations has been developed based on the historical dam failure, and generally we adopt the breach parameter based on those regression equations. And that is some deterministic approach for breach parameter estimations. So we are not able to translate the risk associated with the estimation of the breach parameter in the dam break analysis. So the idea of this paper is to generate or estimate the breach parameter based on probabilistic estimation. So that I am going to discuss here in this presentation. This is the study area. This is catchment of this Mahi Bajaj Sagar Dam. Catchment, it is a earthen masonry dam, and total length of the dam is 3,109, out of which 2,674 meter is the earthen embankment. And this is the section of the dam. We can see the general layout of the dam, and these are the dams. The lowest river bed level is at 220 meter. Deepest foundation level is 210 meter. Height of the dam is 60 meter, and top width of the dam is 8 meter. Now, the breach parameter are estimated based on the several regression equations developed by MacDonald, Froelich 1995, Froelich 2008, Von Thum and Gillett, Su and Zhang 2009. These are the different researchers. They have developed the regression equation based on the historical dam failure. And when we consider these equations, they have used some set of dam failure cases, and based on those cases, they have developed some regression equation. and using our dam characteristic, we compute the breach parameter for our dam sections. And then, of course, depending upon the this cross section means the breach parameter, what we are computing using these regression equations, the limitation will be the cross section of the dam. So that section should not exceed the existing cross section of the dam. And then we use this breach parameter and we compute the breach outflow hydrograph. So this curve on the right hand side, the curve shows the breach outflow hydrograph from various methods. Now, whatever method we are using, we are not able to find out what will be the risk or what will be the uncertainty in the estimation of any of this method. This is the equation, regression equation developed by the Frolic, and we can see there is a best fit line, particularly for breach width, average breach width. And what we have used in our methodology, we have taken the envelope for this best fit line. And this envelope is shown by the red lines. And we are trying to find out what could be the maximum and minimum, means what could be the range of the average breach outflow. And then similarly for other breach parameter also, time of failure, then side slope, and all 4 breach parameter. And then we try to find out what could be the possible range within these ranges, this envelope curve. And say if we take, using those envelope curve, if we take the mode values of minimum or maximum and mean, and then again we compute the breach outflow. So we will be computing some breach outflow, but again what is missing is we are not able to know the uncertainty for this estimated breach parameter. Now what we did, we generated a Monte Carlo based random breach parameter, and that breach parameter will be bounded by the envelope curve. Which envelope curve? That using this envelope curve, we have generated number of breach parameter within this range, and then not only for a single parameter, but all 4 parameters: average breach width, time of failure, side slope, and also the final breach bottom level. So all these 4 parameters are generated using Monte Carlo simulation, and also we assume that, okay, this parameter follows some distribution function. We have used the normal distribution function, and we have generated about 50,000 combination of the breach parameter. Now, how much realization will be developed? That will again depend upon the number of realization when we find that the statistics remains the stabilized. For example, and what statistics means is standard deviation, skewness, and kurtosis. So if we can see that up to 10,000 realization mean and standard deviation remains stabilized, but skewness and this kurtosis does not remain stabilized. So if we found that with 50,000 realization, all 4 statistical statistics remains stabilized. So we used 50,000 realization, and then using those 50,000 realization means it is a combination of the breach parameter, 50,000 breach parameters. We have computed we have not used the entire, we have used the Hegras model for computing the breach outflow, not the entire setup, only for partial area just to compute the breach outflow. And we have computed the breach outflow hydrograph for all 50,000 realization, and then we have identified the peak value for each of the realization, and then we computed the accidents probability for each of the peak value. And we found that up to, means accidents probability for different realization, say up to 10%, there is hardly any difference. But when we go for smaller accidents probability, say 1% or 0.1%, then with the number of realization, the differences is more significant. So considering the 50,000 realization, we have found the accidents probability for peak discharge, 0.1%, 1%, 5%, means different range of accidents probability, we have computed the peak discharge. And then using this peak discharge, corresponding to those accidents probability, whatever the breach parameter is estimated, that breach parameter we have used to simulate the entire HECRAS program, and then we have computed the inundation map for the area. So this way we are able to compute or generate the accidents probability inundation map for different breach parameter. So in this way, when we carry out this type of exercise, whatever breach parameter we are estimating, we are able to say that how much risk is associated with the selection or the estimation of the breach parameter, and also in the generation of the inundation map. So this way we have tried to include the probability or include the risk in the estimation of the breach parameter. And then we have tried to compute also how much area is being inundated and how much population is being affected because of the accidents, different accidents probability. So the conclusion is the skewness and kurtosis of percentage deviation in peak breach outflow has not converged up to 10,000 realization, and convergence of statistical moments are found to be adequate for 50,000 realization. The estimated peak discharge at 1%, 5%, 10%, and 50% accident probability are estimated as 74 100 meter cube per second, 61 183 meter cube per second, 55 221 meter cube per second, and 37 612 meter cube per second respectively. Even at 1% accidents probability, no significant difference in the peak discharge between 10,000 and 5,000 realization is observed. The inundation area at 1%, 10%, and 50% accidents probability are estimated as 967 square kilometer, 874 square kilometer, and 706 square kilometer. So the EPI maps will be more useful in risk-informed decision-making process by further analysis of the flood hazard and population at risk. So this way we can include the risk associated with the estimation of the breach parameter. That's all. Thank you.
Okay, just a few comments. Yes, we know with the dam breach flood wave analysis, there are an infinite number of scenarios, and the people could spend a lot of, or consultants could spend a lot of time doing this kind of analysis. But we should not forget, and because, let me say, in Switzerland, we were probably the first who have done that systematically to all dams already starting in the 1950s, and we're doing first physical models. But our threat, which we consider up to now, was actually only one scenario, and the scenario was a complete breach, instantaneous breach, because the objective of the dam breach flood wave analysis is to provide information for warning the people who are living in the affected area. So we want to make sure that all will be warned in the case of an incident, and it will be not that much important to know what is the exact scenario of the infinite number of scenarios depending on the breach parameters which you have mentioned. I think there are even many more parameters which could be considered. Okay, that is just a comment from our experience. We have about 60 full operating alarm system, and our objective, of course, is that in a case of dam breach, 100% of the people could be saved. Okay, that is our Swiss ideal objective. Okay, so
now, out of several combination of breach parameter. One parameter is also that the entire dam section will fail. So that is one of the combination of the breach parameter. But once we compute the breach peak flood hydrograph for each of the combination, then we also carried out the accidents probability. We arrange all the peak flood hydrograph in sequence, and then we computed the accidents probability. And based on the accidents probability, we try to find out what is the accidents probability of different flood, and corresponding to those floods, the corresponding breach parameter is used to compute the inundation in the entire downstream area. So that part is also included in this. That is one of the combination of this breach parameter.
Yeah.
Okay, thank you, sir.
So our next paper is on attributes of local seismicity around Deri Dam. So do we have the presenters here? Because the presentation was not uploaded. If there is no one to present this, we'll go on to the next one. A breach modeling of a debris dammed lake formed aftermath of the flash flood and debris flow on 7th February 2021 in the Rishiganga Valley by Yogesh Kumar Gupta, Ankit Kumar, Sameer Kumar Shukla.
A very good morning to all of you. My name is Yogesh Kumar Gupta. I am Assistant Director in Foundation Engineering and Special Analysis Directorate under Dam Safety Organization of Central Water Commission. Here I will be discussing about the unfortunate event that occurred on 7th February 2021 in the Chamoli district of Uttarakhand. The event not only caused huge destruction in the downstream areas of Rishiganga and Dholiganga river valleys, but also formed a new debris dammed lake, which was a threat for any repeat tragedy. So we modeled this lake in Central Water Commission to know the breach outflow hydrograph. So as we move forward, I will be discussing about the background, that is what happened, the affected region due to the disaster, brief introduction about the disaster, breach modeling, its parameters, its model results, and after that conclusion. So to the background, that what actually happened or what was the cause of the disaster that happened on 7th February 2021. Was it a glove? No, it was not a glove. Actually, on the 7th of February 2021, a huge rock mass combined with glacier avalanche detached from Ronti Peak. A scar can be seen in the upper picture at the location of the detachment of the rock mass. As per the NDMA report published in April 2021 on the event, the rock mass detached from Ronti Peak from an altitude of about 5,500 meter to 3,700 meter, that is about 1,800 meter, and the volume of the rock mass was about 29 million meter cube. The energy generated due to the impact probably resulted in the melting of snow and ice along with crushing of rock that led to the debris flash flooding, which caused catastrophe in the downstream areas. This is the pictorial representation of the affected region. Here the catchment area up to the Rudraprayag district has been shown. I will not be wasting much. Now disaster. So the disaster happened due to the event was huge. One operational Rishiganga hydropower station of 13.2 megawatt was completely swept away due to the disaster, and one under construction Tapovan HEP of 520 megawatt was also damaged due to the disaster. Apart from the infrastructural damage, the disaster also led to the significant loss of life. More than 200 people lost their lives and also many animals. This is the pre and post disaster images of Rishiganga HEP. Pre and post disaster images of Tapovan HEP, under construction Tapovan HEP, which was damaged. This is the damaged barrage of under construction Tapovan HEP of 520 megawatt. So apart from the infrastructural damage and human life, debris dam lake was also formed due to the blocking of the stream at the confluence of Rishi Ganga and one of its tributary Ronthi river. The lake was growing in size and capacity due to continuous inflow of snow melt, and it might have breached in near future. IMD also forecasted precipitation in the region on 14th and 15th February 2021. In the upper picture, the location of the rock detachment and the lake formation can be seen. And here the below picture, it is the bird eye view of the debris dam lake that was formed after matter of the disaster. So now to the input data and breach parameters. The present study was carried out in HACRAS 1D software, and the volume of the lake was estimated to be 0.7 mcm using cross section extracted from SRTM DM of 30 meter. Based on the photographs and information received from the Wadia Institute of Himalayan Geology and the satellite imagery from ISRO, the length of the obstruction and width of the lake was estimated to be around 500 meter and 120 meter. As the debris dam was loosely deposited material of having boulders and ice fragments, so the breach parameters was assumed in line with the Moran dam, and as per the Froelich equation, the breach formation time was estimated as 60 minutes, average breach width 75 meter, and the height of breach was considered 12 meter. This is the longitudinal river profile developed using SRTM DM of 30 meter from the lake site up to the 53 kilometer downstream from the lake of the location that was formed. Now up to the model results. Model calculated maximum discharge as 891 QMAC, which was got attenuated to the 608 QMAC downstream of lake, 23 kilometer downstream of lake, that is at Josimet, and took just 53 minutes to be reached. And also I have mentioned that we have considered the forecasted precipitation predicted by IMD in the region for the worst possible case scenario. It is the breach of outflow hydrograph just downstream of lake site. Breach outflow hydrograph at 53 kilometer downstream of lake site. Now, the risk was averted when a team of ITBP and NDRF widened the mouth of the lake to prevent any repeat tragedy. The conclusion now. When a dam or lake located close to the population is at risk, it is important to predict the breach outflow hydrograph. In the present case, the damming material was loosely deposited debris, and the debris dammed lake could have breached probably during any precipitation events. And also the event took place on February, and the summer months were coming, so temperature was obviously going to rise. So due to the temperature going up, the snow melt was also going to increase, and there was possibility that lake might get breached. So the outcome of the modeling study and model simulation of the lake was shared with the Ministry of Jal Shakti, Ministry of Home Affairs, and National Disaster Management Agencies. The appropriate precaution measures like widening the mouth of the lake, close monitoring of any precipitation event in the catchment of the lake was suggested to minimize the risk of the disaster. And the suggestions were well taken care of by the disaster management agencies working in the field to prevent any repeat mishap. Since the Chamoli district of Uttarakhand lies in seismic zone 5, the most seismically active zone as per IS 1893, and climate change has also increased the vulnerability of this hilly region. Hence, the Chamoli district has seen many natural disasters in the past as well, like landslide, rock slide, glacier avalanche, and stream blocking resulting into the flash flooding. The lesson learned from the previous disasters as well as this model study may be used as a case study to prepare for any such futuristic unfortunate events. Thank you.
Oh, okay, thank you very much. Of course, we know this event from Chamoli, which was very, let me say, unexpected, and we gained also some new experience based on these observations. You have mentioned let me say the slip volume was about 29 million cubic meter, but you have calculated some maximum discharge. I think it was about 800-900 cubic meters per second based on your model. It was not clear to me actually if what was actually measured. I think it was not measured, but based on the observations, which were the maximum discharge. I must say, I was also shortly after this event related to India, because Mr. Vishnoi is also in my seismic committee. So we were very much interested in that, because it, as a lesson learned from the seismic safety, was that even slope stability problem in a catchment, and not only in a reservoir area, may cause, let me say, failure of dams, run-of-river power plants with very small reservoirs, and I'm not sure what is being done here against such kinds of threats. Probably the only way is that people cannot build run-of-river power plants in that region. Okay, so I found this presentation, it is very important, and I think it is also very important from the seismic point of view. So once more, thanks a lot for this presentation. Maybe you want to say on the
yeah.
Or in the proceedings.
Yeah, so now we go on to the poster session papers. The first one here is Understanding Risks Associated with Dams and Context to Dams in Damodar Valley, to be presented by Mr. Abhishek Shukla and N.K. Goel. Do we have the presenters?
No, we are not presented.
Okay.
I think you just mentioned that they can be found in the proceedings.
Yeah, right. All right, so there are 6 papers, poster session papers, which can be referred to in the proceedings. I can read out the names. The second one is Evaluation Flood Risk at an Industrial Site using 1D and 2D coupled hydrodynamic flow model under cascading effect of dam failure. The third one is Assessment of in situ quality of concrete of Ringari powerhouse structure by non-destructive testing methods. And the next one is a review study on Indian dam failures. The fifth one is analysis of seepage flow through earth dams using numerical modeling. And the last one is risk-informed dam safety management. Thank you.
Okay. If I may say finally a few words, we are almost on time. Mr. Sunil will not be unhappy. Our session, we had 7 papers. The first 4 papers were related to seismic topics, and the next 3 papers were related to extreme flows in rivers caused by overtopping or dam breach analysis, and I think they belong into the same class of extreme events affecting, number one, seismic safety of dams, and also affecting the flood safety of hydropower plants. So with that, we have time for 2 questions from the audience. If there are any questions related to some of the papers, please raise your hand and somebody can hand over the microphone. Yeah, there is one. Where?
Hello. In the case of failure of dams.
You say your name and yeah.
Yes, I am Krishna Rao, Dam Safety Organization, Karnataka. Executive Engineer, Dam Safety Organization from Karnataka, Bengaluru. In most of the cases, the dam fails due to flooding other than seismic activity. So, all the papers presented here, I understood the breaching of the dam in case of failure. Why don't we think of a designed breach portion like what we have in pressure cookers, safety valves? Is it not possible to design a designed breach portion in a reservoir?
Question is addressed to what is a general comment or is addressed to one of the presentations?
No, I wanted to know because I am not a designer, I am just a user of a reservoir. So just I wanted to know whether is there any concept like that.
You want to answer?
I didn't quite understand.
Okay. So I think your question is very relevant. There are some cases wherein we do design breach section in a dam, but that is very few. And by design, we have a fuse plug or a section that is designed to fail. This is what you're referring to, I think, in case of an extreme event.
Yeah.
Generally, what we are doing is we are having spillways, that are designed to cater to the PMF and the other extreme flood events, and that's what we are doing at the moment to design the spillways. But in earthen dam sections, I think this is something that I think we can definitely look into. Going forward, but there are some projects wherein we do at least, if not in the main dams, we have done it at least in the coffer dams to have it designed as a breaching section. Yeah.
I am seeing many papers on the estimation of flood, but I didn't see any paper on this type of concept. That's why.
Please,
Thank you.
I request the hostess to please pass on the mic to Mr. Michel, sir.
Yes, I'm Michel. I would want to make a comment on fuse plugs used in some projects. Recently, there are very bad experiences with that. In the case of the Xemnamnoi in Laos, the fuse plug, the foundation was eroded very deeply. And another case in Malawi, it was a flux plug. Sepian is not a flux plug, sorry. But in Malawi, the flux plug was designed. It was supposed to fuse up to, let's say, 5 meters. In reality, all the foundation was washed away also, and a major breach, quite larger and deeper than what was expected occurred. So I think when we design a fuse plug, we have to be very careful of the condition and the foundation conditions especially. Thank you very much.
Yeah, thank you for your comment. Yeah, we have to be indeed very careful on that. Yeah.
Okay, we came to the end of this session, number 1 in the third day, and yeah, okay, maybe we will do it after in a break. So I would like to hand over to the...
Thank you so much, sir. Okay, so again I would welcome you all. Namaskar and a very good morning to all the distinguished guests and our esteemed participants and all our speakers. And as we can see, you all have joined us in this between the session. And I am your host, Priyal, of this conference. And ladies and gentlemen, I would like to extend a very warm welcome. And thank you so much, our co-chairman sir, Mr. Martin, and our co-chairman ma'am, Mrs. Neeta, for conducting this session so nicely. And now I would like to request our Mr. Martin sir to kindly come forward. And now I would like to request Mr. Michel Lino sir to kindly come on the dais and to please honor the memento to our chairman sir. Also, I would like to request to do the honor to please present the memento to our co-chairman, ma'am, Mrs. Neeta. Thank you so much, sir. Now, I would like to request our chairman, sir, to kindly present the memento to Mr. Anil Jain. Mr. Deepak Khandelwal. Mr. Arnab Banerjee. Mr. Pankaj Mani. All right, thank you so much, sir. And now I would like to request our co-chairman, ma'am, Mrs. Neeta, to kindly do the honor and present the memento to Mr. Yogesh Kumar Gupta. We have Mr. Ketan Patel from Research Scholar, IIT Roorkee. Mr. Vishal Singh, again Research Scholar from IIT Roorkee. Syed Khatib Ahmed, Research Associate, IIT Roorkee. Mr. Rahul P.R., Research Scholar from IIT Roorkee. Ms. Shruti Jain, Research Scholar, IIT Roorkee. All right. So thank you so much. Thank you so much, the chairman sir and co-chairman ma'am. Now I would like to request you all to kindly proceed for the tea break, and we are going to meet at 11:20 sharp. I would like to request all of you to kindly reassemble here. Thank you so much. Check. Mic off. ऑफ कर दो अभी माइक माइक ऑफ Sound check. All right, ladies and gentlemen, now we are going to start the session in 2-3 minutes. I request you all the guests to kindly settle down and take your seats. We're going to start the next session in quick 2 minutes. Thank you. I request all the guests to kindly take your seats. Would request everyone to kindly take their seats quickly so that we can proceed for the next session. All right, welcome back everyone. So ladies and gentlemen, I would like to call our chairman, Dr. R. Chitra, the Director, Central Soil and Material Research Station, and our co-chairman, Mr. Vivek Tripathi, the Chief Engineer, Central Water Commission, to kindly come on the dais. Now I would like to request the chairman of this session to kindly proceed for to conduct the proceedings, and the floor is handed over to you, sir. Thank you. Mic on, mic on.
Yeah. Good morning, everyone. Welcome to this session on dam health monitoring, data acquisition and processing. And there were 6 papers, and the first paper, Dam Health Check and Monitoring Using Advanced Tools of Geophysics, Indian Express. The presentation is not loaded now. Are we ready? Dr. Sanjay Rana is ready? Acha, sorry. We are... Acha, technical session 7. No, this one. Major rehabilitation and risk reduction. This is what they are giving. No? There is a confusion. Sorry. Yeah. There is a confusion from the organizing team. And we are here for the session of major rehabilitations and other risk reduction investments. I hope all the presentations are loaded here, and there are 6 papers are to be presented. I would request every speaker to take 10 minutes, and we can have 5 minutes for question answer session also. And may request the first author, material selection and quality requirements for repair and rehabilitation of hydraulic structures. The author from this paper, for presenting this paper. P.N. Oja, Brijesh Singh, Abhishek Singh and Suresh Kumar. Anybody? Okay, let's move on to the second paper. Instrumentation for safety of dams, issues, challenges and lessons learned in Indian context. Presenter will be Shri R.S. Sera, CSMRS. लेकिन इन्होंने ऐसे क्यों बोला? हाँ.
Good morning to Chairman, Co-Chairman and all delegates. My great thankful to Director CSMRS, Dr. R. Chitra Madam, and my authors, Sri Haridev, Scientist E, and Sri Mahavir Dikshit, Scientist E, who have permit me the presentation of this paper. My paper's title is Instrumentation for Safety of Dams, Issues, Challenges and Lesson Learned in Indian Context. content is instrumentation of dam safety, issue challenge and lesson learned. Instrumentation are our eyes and ears inside the media wherever placed. Instrumentation is used as a tool to ensure safety of dams through continuous monitoring and analysis. We know that there is no simple rule which can determine the number of instruments, their exact type and location, their determination only having experience judgment. The number of devices installed in a dam is less important than the selection of instrument, their location. The quality of instrument should be of paramount importance, since these are expected to work for very long period, say 20 to 25 years. We also know that embedded instrument cannot be retrieved and repaired if these becomes defective, so service requirement must be carefully weighted. The objectives of instrumentation: baseline ground characteristics, find out construction control, verification of design parameters and assumptions, monitor the long-term effect of environmental changes, carry out research to enhance future design, monitor mitigation measures and quantification and management of risk to third parties. Requirement of good instrumentation program: having instrumentation adequacy. The adequacy of any instrumentation program is directly related to the size of dam and its hazard classification. The observation of monitoring device. Instrumentation data should be collected by trained personnel who can recognize signs of problem and report to them quickly to higher technical level for further action. Frequency of monitoring is governed by risk classifications like dam height, impoundment size, occupancy of downstream and land use, seismic risk at the site, age and condition of dam, frequency and amount of water level, fluctuations in reservoir, and abnormal behavior of dam. Minimum instrumentation in concrete gravity dam. Instrumentation should be provided in at least one deepest overflow block and 2 abutment blocks. It should also be indicated that the number of instrumented blocks may be increased with the increase in length and height of dam. Typical cross section of instrumentation in concrete dam. Uplift pressure. The pressure meters are installed in the foundation and grouting gallery to monitor the variation in uplift pressure. It should be done at least at 3 cross sections in case of small dams and at least 5 cross section in the case of large dams. Pore pressure. In concrete and masonry dams, they may be installed normally at 10 to 15 meter spacing along the width of dam. The bottom row of pore pressure meter may be located either at the contact plane of foundation or concrete or just above the foundation or in the foundation by drilling holes as may be required by the design. A second row may be installed at 1/3 or half the height of dam. Joint meters. In case of large dam, joint meters should be provided in at least 3 blocks, one in deepest central block and a block each in the abutment. at a given elevation, the joint meters in each of these blocks should be installed at the center of the transverse direction of the monolith in the blocks and should be spaced about 15 meters vertically in the height of the longitudinal and transverse contraction joints. This spacing may be modified in the top portion of joint if joint height does not permit the 15 meter spacing for the entire height. Stress 10 meters. Stress and strain meters are installed in the dam body to monitor the variation in stresses and strain during construction. Stress meters are installed along the strain meter so that the data can be correlated. Strain meters are installed in row sets like 3 number and 5 numbers. One no stress strain meter is required to be installed by the side of conjunction with the strain meter group to determine the correction to be applied on account of creep, autogeneous growth of, and thermal expansion of mass. Horizontal and vertical movement. Normal and inverted plumb lines are installed in concrete gravity dam to monitor the structural deformation and the movement in the foundation. In addition to normal plumb line, optical target and tilt meters at the dam top can also be fixed before start of reservoir filling so as to record the dam deformation. Seepage discharge measurement. V-notch are the simplest device used for measurement of seepage discharge through dam body. These can be installed in drain in inspections galleries. Minimum instrumentation in the embankment dam. Where dam length are more and foundation strata varies along the length, location of instrument at 2 or 3 sections should be considered. Point of view of safety and collecting data for feature and similar designs. Instrument for measuring pore pressure, moment, stress strain, and dynamic effect of earthquake may be made for a few selected cases. This is typical cross section of instrumentation in earth and rockfill dam. Earth pressure cells. The pressure cell may be designed to measure effect and total earth pressure or both. When it measures total earth pressure only, piezometer should be placed by their side to measure pore pressure, which when deducted from total earth pressure to give effective earth pressure. Horizontal and vertical movement. Inclinometer is superior to give along complete length its position of sliding surface. Cross arm installation also measure vertical movement. Issues and challenges in dam instrumentation. Selection of instrument. Instrument should be as simple as possible. It is handy, durable, accurate and precise. Organizational issues. In any project, civil work and QA/QC section are two important tasks, requiring experienced manpower in related areas, while the work division focuses on achieving the target as per construction schedule. And QA/QC division is assigned the specialized role for assuring quality without hindrance in the work progress. Instrumentation is another specialized work requiring trained professionals. So instrumentation work is assigned with QA/QC section, not work division. Engineer in charge QA/QC and engineer in charge instrumentation are directly reported to top management, not the director to works. Contractual issues, coordination between EIC instrumentation, EIC works, contractor civil work, contracting agency instrumentation, the responsibility of contractor. The contractor civil work should be responsible for making necessary civil arrangement for instrumentation, installation, providing shaft work, cable routing and protection measures. Instrumentation agency should be wholly accountable for proper installation and monitoring. The drawing should be studied both the works and instrumentation division for making pre-installation arrangement and readings of instrument in advance. This will help in installation of instrument as per the construction schedule and ensure proper monitoring. Monitoring and submission of monthly reports should be built in part of the contract document to get uninterrupted data. Payment to the contractor can be linked to successful installation and functioning the instrument in stages. Problem faced in the field, sliding problem, cracks in different part of structures, improper installation in instruments, damaged, chalked instruments. Conclusion. Instrumentation is used as a tool to ensure safety of dams through continuous monitoring and analysis. Proper instrumentation not only helps in safety of the structure, but can also lead to economy in the term of cost, time and materials. Proper installation of instrument is as important as quality of instrument itself, since once embedded cannot be taken out. The calibration of each and every instrument is very important to ensure measurement of true values of desired parameter intended for. Thanks.
So, thank you, Mr. Sera, for nice presentation. So, these instruments are a direct indicator of health of the dam. So, the planning of placing the instruments should be robust, and instrumentation should be robust also. Because if instruments are placed during the construction, some instruments cannot be placed after the construction, or if it is not working, then it is not possible to replace it. So, this programming or schedule and instrument itself should be robust. Second thing, because softwares are available right now, so we can do the 3D analysis very well for the concrete dam particularly. So, strain meter, regarding the strain meter, we have to place strain meters to capture the 3D strains. So, we should put the strain meter in a group in such a way that 3D behavior of the strains should be captured in the instrumentation. So, this is from my side. If any supplement you want to say.
Yeah, it's a nice presentation. Mr. Chhera has given us the overall view of what the instrumentations are, and he has listed, and the issues and challenges he has placed before us. And I take the opportunity to say Central Soil and Materials Station, we are fabricating some of the equipment, instruments, and we are installing in the structure, existing structure, as well as the initial, during the construction of the structures also, we give a plan. And then the analysis of it, post-construction behavior also we are analyzing, and instrumentation data are coming to us, especially for Sardar Sarovar, Rihan Dam, and many of the other structure also. So it is fabricated using our in-house facilities itself. We are proud in that. And yes, of course, the importance of installing instrumentation, should not be for namesake, how it is installed, how initially it is being calibrated, and after that also, because while analysis we face a lot of problem in getting the initial reading and continuity of that. So we have to take care of those things. The contractual issues or constructional issues and all that can be well taken care of. So we have to be careful. So this is about the first presentation. The second presentation, let's move on to which will be presented on underwater rehabilitation of dams using geomembrane waterproofing system, which is going to be presented by Mr. G. Washiti. It will be, I hope it is going to be a very interesting presentation, and we are very much looking forward to it. Thank you. So you are having 10 to 15 minutes. If you want everybody to question you, you can just leave, finish the presentation in 12 minutes, and we'll have questions for 3 minutes. Thank you.
Thank you, Lady Chairman, and thank you, Sir Co-Chairman. I'm François Tronel from Carpitec. I'm going to present you references and technology for underwater repair of dam using a geomembrane waterproofing system. So first off, I will just remind you or present you the general concept of waterproofing structures with a membrane. So a geomembrane is a very flexible material which is very impervious, is durable, and applicated. Our membrane, the Cibelon, which is based on PVC, is an application for dams and various hydraulic structures. It is produced in factory by rolls of 2 meters wide that are welded together to form a full watertight surface. The idea, you can see on the picture in red, the idea is to keep a watertight barrier upstream of the structure that can be drained just behind the membrane to keep the water outside of the structure body and keep the structure as dry as possible. It is not glued to the surface, it is mechanically fixed punctually or longitudinally. And Carpitec is provided turnkey solutions. So assessment of the problem, design, supply, and installation of the material. So we have always been, let's say, leader and opening paths in repair of structure with geomembrane. We work in the dry since the 1950s, and the first project to be done underwater was in 1997. Just a few pictures of what we do, and we chose rather old dam to show the durability of the project, of the solution. This is a dam in Italy, executed in 1988, and another one in UK, which was the repair of an asphalt face rockfill dam in 2001. A few projects underwater that I will be presenting, starting with Lost Creek in USA, which was the first project. So, underwater installation, obviously the advantages are many. First of all, of course, you don't have to dewater. So in case some structures that just simply cannot be dewatered because they have not conceived for, or it's too costly, or it's much too long, it will last too long, and it will be too complicated. So you can also lose a lot of money in terms, if you speak about a hydropower plant, you can use millions every week. So in that case, you might consider underwater repair as the most feasible and attractive solution. We have started with a long study with the US Army Corps of Engineers in 95-96 with tests in swimming pool, chambers, etc. That led to the first project in 97, the Lost Creek Arch Dam in the US. I will go rather quickly in the different phases. So first, obviously, removing the debris from the upstream face. The idea is to go put the membrane as low as possible to cover as much as possible of the surface of the dam. So we will remove the debris, we will remove the sediments if possible. Then there is a light but necessary surface preparation on some points and installation of the drainage geonet previously, you remember, I spoke about the drainage system. It's very important to keep the water, if it's going around the waterproofing system, to keep it upstream, so to keep a dam body as dry as possible. We are going to drill holes in the dam body. It could be done underwater, could be done in the dry. On another project, we did it underwater. Drill holes to discharge the water of the geonet downstream. And then we start with the installation of the CAPI system itself. So we can work with a barge, we can work without it. And we start, of course, with a fixation system. In that case, you can see on the left picture, on the right picture, the tensioning profiles. We are preparing big panels of membrane. So membrane comes in width of 2 meters. We cannot weld it underwater. It's impossible technically, physically. So we are pre-welding panels as large as possible. They are fit for purpose. They are the right dimension for the dam. Pre-welding them in the dry or on the barge. And with a big crane, we are loading it from top to bottom on the dam. It can be continuous from the dry section to the wet, so the underwater one, or it can be different panels. In the dry, they are fixed classically for CARPI. We have a presentation about that this afternoon that will be getting more in details on the dry works. Underwater, we are using divers, and they will go fix the membrane, so no electricity, all mechanical work to connect the membrane to the structure underwater. And you can see here, on the left picture, a worker connecting the membrane with a tensioning profile. And on the right, they are working on the dam face with a platform. Later, on newer projects, we have pictures of the divers working underwater. And here you can see the dam completed in 1997 with really an exceptional result according to the client. They are saying that after CAPI's intervention, the dam has never been as dry as it was before. So it's the best result they ever had, with a leakage of less than 0.02 liters per second. Now, a few other references. This is Venezuela, Turimiquire Dam, a very important dam in Venezuela, providing water to hundreds of thousands of people. We have been working on it before the big crisis in Venezuela. We have watertight 20% of the dam face. You can see at the bottom left the surface that have been watertight by Carpitec. Now we are out of the country, but we might be back. You can see on the right the difference on downstream of the seepage, on the top before, on the bottom after CAP intervention. Other references in the USA, so those are more punctual interventions. We work a lot on joints. We will detect by an underwater inspection with ROV or divers where are the cracks, where are the paths of the water, and we will go work in that position. So here, this is a dam in Greece, and you can see downstream. So on the central picture, it's the downstream phase before CAP intervention. On the right, after intervention. On the bottom left, you can see a detail of the CARPI system. So we have created a shape of exactly what we have to waterproof underwater, and then put it down, and with a diver, fix it to the face. Same with Olai Gravity Dam in Italy in 2013. Lompanga in Cameroon. You see the same. I try to go a little quick because I have something more detailed after. So waterproofing of joint here, or again, a joint in Laos in 2016. Now, our most recent massive intervention is in Bulgaria. It's a Studena Dam, which is providing drinkable water. So this water is going to be drunk by people of the Pernik city, just close to the capital city of Bulgaria. And we have worked 77% on the water, 23% in the dry. The dam has a very, very complex geometry. So we had to prefabricate elements of the right geometry in the dry. Okay, there is, as for a Lost Creek Dam, some surface preparation. Here it was mostly removal of loose shotcrete layer. You can see our workers, our divers working. A few pictures of the underwater work, so surface preparation, some patching with a resin fit for underwater works. Dredging was necessary, again, to go as low as possible and to reach as low as possible to waterproof a very big surface of the dam face. And then we start working. So you can see what we are capable to do underwater, very, very complex geometry. The rolls are arriving from the surface and they are unrolled down underwater and fixed with a mechanic profile. And here you can see divers working on the tensioning profiles. A detail here, in order to achieve exact geometry for this complex dam face, we have worked on mock-up in the dry, taking measurement on the water, working in the dry, finding the best way to work, and then installing it underwater. And here you can see the dam under work, so the barge, and here at the bottom, in white, it's a membrane. Oops, sorry. And this is before and after. One very recent reference, just before we go to something else, is the Okertalsperre Dam in Germany. It's interesting because it's a very deep joint, and it's a very complex access. You can see at the top of the joint, on the central picture, you have a slab, so you cannot access. It's very complicated. But it was a very good project, and we had no leakage whatsoever after the intervention of Carpi. Just a short explanation. Our intervention, obviously, they might sound expensive because you have workers, a lot of upstream work preparation. It's a very high-end technology, but of course, you will not have to dry your structure. You can keep exploiting it, so selling energy, irrigating your land, and you have a product that doesn't need maintenance. We have dams that have been repaired 40 years ago in Italy, in the Alps, so in high mountains with high UV, ice and snow, and we still had no maintenance. So on the lifetime of the structure, obviously our solutions are very interesting financially. 1 minute, okay. So very quickly, I will present you a 1-minute movie of the last innovation by Carpi, which is allowing us to waterproof structures with a flow of water. So not only still water like for the dams, but for canals, we are now able to work with flowing water. We will unroll a membrane, big rolls of 10 meters wide of membrane that will be connected together with a zipper. We have it here in Jaipur, so you can come to our stand to see. This zipper is watertight down to 9 bars, so 90 meters of water head. And we create this way a continuous impervious layer for a canal. This is a reference in France 1 year ago. And you can see here, this is a concept, width of 10 meters, connected with a zip, that has been done in Italy, here in Egypt, and now in France with EDF as a client. It's finishing with grouting of the mattress in some cases, of the Sibylline mat. So we have a system that is durable and standing, well ballasted and well protected with contact with the flowing water. Thank you very much.
Please. So, Mr. Vachetti, thank you for a nice presentation. Can you give any example where you have used this geomembrane on CFRD?
Oh, yes. So, we have been repairing CFRDs. We have been repairing the movement between the joints of the CFRDs, but we have also been proposing alternatives to CFRDs, and we call it GFRDs, so geomembrane face rockfill dams, which means you are not having anymore the concrete slabs, you are replacing the slabs by the flexible membrane. It's a big advantage because instead of having rigid, so rock-fill dams, obviously, when you will fill it, they will move, you will have differential settlements, and so the concrete slabs, they will move, they will have differential settlement, you will have maybe your joints cracking, and it's not very adapted to a very flexible structure. We are proposing alternative, putting a geomembrane instead of the concrete face. Right now, we are doing it in Peru, on the Las Bambas Dam, in Ivory Coast, on the Singrobo Dam. We did it in Papua New Guinea, on the Edevu Dam. We finished the site a few weeks ago. We finished also 1 week ago a project in Uzbekistan called PSCEM. So we have many references.
Thank you.
We can invite 1 or 2 questions from the audience also. Anybody is interested to ask question? Yeah, please.
No, it's not on the downstream phase. It's always upstream phase. We are in contact with the water always. I don't think I show downstream. I can go down if you want.
No, it's okay.
No, always upstream phase.
Yeah. Any more question? If it is not there, we can conclude. Okay. Very interesting presentation. Thank you very much, Mr. Veshati. And if anybody is interested, you can contact him in his stall or by email. And let's move on to the third presentation, which will be on effective measure to control seepage. Yeah. Sorry. Effective measure to control seepage in masonry gravity dams, a case study. Who is going to present this? Yeah, I invite Mr. Vigneshwaran to present this paper. Yeah, 10 minutes plus 3 minutes, okay?
Good afternoon to the chairman, co-chairman, and the distinguished people sitting in the auditorium. So today I am going to present a paper on effective measure to control seepage in masonry gravity dams. So I am Vigneshwaran, working as scientist in Central Water and Power Station, CWPRS, Pune. So before going to the presentation, I will let me a glance about CWPRS. So it's a 106 years old organization, foremost in the field of hydraulics and allied research. We have major 7 divisions which caters to the river engineering, river reservoir modeling, coastal offshore engineering, foundation structures, instrumentation calibration, reservoir operation structure, air science, etc. We carry out all kinds of studies related to hydraulic structures. And coming to the presentation, so far we are talking about the dam safety. We have about 5,000 dams, how to take care of it. And the major part of dam is that most of the dams are more than 30 or 40 years old. So these dams requires a lot of repair work or rehabilitation of strengthening due to the change in BIS code or earthquake parameters, etc. So repair is to provide protection and making up deficiencies, like we can call this cosmetic, like small cracks or small seepage work, etc. And rehabilitation is what we are going to concentrate in this presentation. This is to restore the discharge structure to the normal serviceability level. And strengthening is to increase the dam level or to increase the earthquake parameters, we can go for strengthening. So the objective of the rehabilitation of our presentation, that is the masonry dam, is it has to improve the structural integrity, improve durability, and prevent leaching of materials, because leaching is one of the major causes in all the gravity and masonry dams. And it should restore water tightness, because whatever the dam we have seen so far, it's so much of seepage or leakage will be there. And it should improve the appearance of the structure, because due to the leaching, there may be so much of leaching areas will be there in the downstream portion also. So coming to the causes of seepage, masonry dam exhibit leakage seepage due to a lot of reasons. Some of the reasons are listed here. And the leakage and seepage affect structural stability of the dam due to development of high pore pressure, reduction in mass density, and strength parameters. So we have to take care of this mainly, that is the mass density, reduction in mass density. This leads to the unsafe of the dam. and to restore structural integrity of the dam and to make the distressed structure serviceable again, various methods in either one of or other combinations are used. So coming to the repair and rehabilitation, for gravity dam distress is not always one reason, it is a combination of reasons. So it is the foremost to find out what is the probable cause for the distress and what are the various repair material or repair techniques available and how to use it. And coming to the major part, the repair and rehabilitation to be economically sustainable. So that if the dam is constructed of about 100 crores, we cannot go for repair for about 100 crores again. So it should be economical and it should be durable and safety. So some of the methods where the seepage can be reduced is through the foundation. If it is the leakage or seepage through foundation, we can go for grout curtain from the drainage callagy or from the heel. And if from the upstream phase, you can go for raking and pointing, gunting, short-circuiting, providing skin wall, or otherwise you can go for geomembrane also. And if it is the body wall treatment, then you should go for the dam body grouting. So in this presentation, I am going to concentrate on one case study, that is the Domini Dam. It's of Surya Major project in Palghar district in Maharashtra. It is a masonry gravity dam about 58 meters in height and 623 meters in length. So the dam was constructed in the year 1990, and due to aging, distress in the form of heavy seepage and leaching of water has been observed in the dam. So these are some of the photographs. You can see that. So this is from the downstream portion. You can see a lot of seepage and leaching is there, and this is a photograph of one part of the gallery. You can see that a lot of seepage is there, and due to the leaching, exorbitant leaching, the material has turned into black in color. And this is the spillway portion, and the EDA portion is also has been affected due to this. So this problem has been referred to CWPRS, and we have recommended some of the options. Let's look into it. First option is the grouting of the dam body. So grouting of dam body is one of the most effective cures for most of the dams and has been successfully implemented in all over the world. So presently there is no BIS code for dam body grouting. There is a grouting for foundation grouting is there, but there is no BIS code for dam body grouting. So the grout mix design should take care of the parameters like what is the pattern, size and continuity of cavities and fixtures in the masonry dam, what is the quantity of seepage going through it, what is the water condition, and how the density has been changed, because the dam has been designed for around 2,400 kg per meter cube. Due to the prolonged leaching, it may have reduced to around 2,000 kg per meter cube, which poses a safety parameter also. So these parameters has to be taken into the account, and these are some of the dams that has been recently grouted by our team. Majorly is the Varasgaon and Temgar Dam. Temgar Dam, Unsara already noted there is a seepage problem is there. In the Temgar Dam, we have already grouted and the seepage has reduced by more than 90% in that. So coming to the suitable grout mix design, it is essential to achieve desired result through controlling seepage. So to check the performance of grout by conducting various tests in laboratory before trial application, because the design mix is a continuous process. We have to, it varies from one dam to another. So these are some of the tests that we carry out in our laboratory, like flowability test by Marsh-Cone apparatus, settlement and segregation test, jellification test, pH value and compressive strength. These are some of the photographs of laboratory photographs. This is to check the pH, and this is to check the flowability, whether the grout material will flow to the inside of the dam. This is to set the settlement, whether the grout will settle or it will be segregated, to set the jellification and segregation, and at last the compressive strength, because the material what we have used should have enough compressive strength to retain it. So coming to the efficacy of the test. So now the grout design has been designed, but now we have to check it whether it is be suitable or whether it will be there. In this, in our CWPRS, we have developed a methodology that we have constructed about a 1 cubic meter of masonry block, and we have grouted the same mix design and we have checked the parameters. And we have conducted non-destructive test on these masonry blocks, we have conducted water loss test, and we have conducted the compressive strength on the extractor course. And this is the model of our grout mixer used in our lab. So this is the picture of this, our model. This is 1 cubic meter masonry cubes has been costed. So in this we have considered that whatever the density of the dam is considered, like about 2100 kg per meter cube, the same has been considered. We have measured and we have weighed and we have constructed in the same parameters. After this, the design grout mix has been grouted using grout pump and the water loss test, and you can see this that using the high capacity core extraction machine, we have extracted 30 centimeter dia cores in that. And we have stressed the compressive strength also with this. So after this, so we have conducted NDT test also. So non-destructive test on masonry blocks by ultrasonic pulse velocity method has been conducted in this. And this is the ultrasonic pulse velocity method using Pandit equipment. In that you can see that a grid has been formed and using the Pandit equipment in all the phases this test has been conducted. So this is the picture of the test result before grouting, and this is after grouting and after curing. So you can see that before grouting it is around 2000 meter per second, and post grouting it has increased to 3000 meter per second. So in this we can assume that the grout has worked efficiently. So based on this we have suggested the grout methodology. First we should grout the primary grouting from the top of the dam to the top of the gallery, and secondary light of grouting from about 1.5 meters from the top face of the dam, and tertiary grouting to after, if it is primary and secondary is not satisfied, we can go for tertiary grouting also. In this case, the Surya dam, the density is also very low. So we have advised to go for vertical grouting from the downstream face of the dam, so that the mass density of the dam can be also be increased. So this is the picture of the grout diagram, and this is the side photographs of that. So, on the second options we have advised to the shotcreting or graniting we can say. So, shotcrete is one of the most effective process of repairing concrete work. So, it stops the ingress of water from the upstream face of the dam. So, it is also providing a impervious layer. So, shotcrete is a mixture of Portland cement, sand, additives, water, shot and replaced by compressed air. So there is a IS code for that, that is IS 13645. It talks about the surface preparation, fixing of wire mesh, shotcrete operation, etc. So coming to the dam body shotcreting, properly appraised shotcrete is structurally sound and durable. So it is very durable, because in Maharashtra most of the dams they have granited or shotcreted for more than 30 years and it still serves its purpose. So it exhibits excellent bonding characteristics to the existing concrete, rock, steel and many other materials. So it can have high strength, low absorption, good resistance to weathering and resistant to some forms of chemical attack. So physical properties of short concrete compared to superior to the conventional concrete. So these are some of the dams we have shotcreted, that is Varasgaon and Temgar Dam, Batsa, Bandardharam dams, they have shotcreted about more than 20-30 years back. So coming to the test for design of shotcrete mix. So in this also we have received the materials from the dam site. Yes, ma'am. We have conducted slump test to check the uncued shotcrete consistency, compression test, and this yearly strength partial beam compression test is used to find out the measure of cued shotcrete complex. That is, after 6 hours, what will be the compressive strength, so that the material whether will stick to the upstream face of the dam or not. And permeability method using DIN parameters to check what is the permeability of these methods. So apart from this laboratory method, we also conduct field test on this shotcrete. So in this you can see this sample panel has been casted in the upstream portion of the dam. In this a core has been extracted, and this core we find out the direct tension pull out strength and the permeability strength of that. And this is the shotcrete methodology suggested. This you can see the IS code, and this is the photograph of how the shotcrete has been done in the upstream face of the dam. So coming to the efficacy, so we have now grouted and we have partially grouted and partially shotcreted of the dam. Before that there is a leakage of about 197 liters per second. So you can see that after partial grouting and partial shotcreting, that seepage has reduced by more than 77%. That is, it is reduced to around 45 LPS. Still the second stage of grouting and about more than 50% shotcreting, as you know. So we hope that the leakage will be reduced more than 95% in coming time. So coming to the conclusion, dam body grouting and shotcrete using proper mix design is well proven and economical. That is what important, because we have to repair most of the dams, so it is a very economical and effective tool to control seepage. So cementitious grout mix is important and necessarily done by conducting laboratory tests on different materials by including fly ash, silica, etc. After conducting the suitable test in laboratory by using many proportion, a suitable design mix has been arrived, and that design mix has been used for our masonry cubes also. So coming to shotcrete design, nearly 6 shotcrete mix design have been evaluated in laboratory, and the final design mix has been used in the site. So due to the dam body growing and shortcutting in upstream face of Domini Dam in Maharashtra, the seepage leakage through dam portion has been observed to reduce considerably. At present, it has reduced from 197 to around 45 liters per second. Thank you.
Thank you for nice presentation. So one thing I want to ask,
yes,
if you remove the pointing treatment from your presentation, can we rename your title or it can be generalized for the gravity dam?
Yes, sir. Concrete, masonry gravity dam, sir. We can consider.
No. If we remove the pointing word,
okay, sir,
from your presentation,
yes, sir,
then can we rename your title as a treatment for the gravity dam?
Yes, sir, definitely, sir.
It is applicable to the concrete dam also?
Yes, sir, yes, sir. If it is the voids are more, we can go for that also.
Thank you.
Thank you, sir.
Now the time constraint has come. We have to finish before 1 o'clock. Let's move on to the next presentation, which will be on dealing with large lateral forces due to creeping slopes, a case study of Shantong Karcham HEP hydroelectric project, Himachal Pradesh. Who is going to present this? Yeah. Mr. N.S. Shekhawat will be presenting this. You have got 10 minutes, sir. I thought of saying 8 minutes, but looking at you, I said 10 minutes. Okay.
Thanks, ma'am. So thanks to chair and co-chair. Good afternoon to all. Myself, Narendra Singh Shekhawat. I'm Director, Central Water Commission. So I'm going to share a very interesting case study of Shantong Karcham HEP, Himachal Pradesh. So here we have dealt with a very large lateral forces due to creeping on the barrage. So the barrage design on the structural parts due to a very large creeping forces of the tune of the 1900 to 2000 tons per meter was estimated based on the certain observations, 2 years long observations, and based on those observations, it was decided, because all other aspects have been ruled out of shifting the dam upstream and other aspects, to deal with these huge force through barrage itself. Though the design of the barrage have a lot of hydraulic and other aspects also, those aspects have been taken care of, but I am going to deal here structural aspects only due to these large forces, how the structure has been modified. This complete case study, the problem has been referred to Central Water Commission through Department of Economic Affairs, when the financier of both Asian Development and the KFW was the financier of the civil work and the hydromechanical, and they have decided to withdraw based on keeping the site conditions and all those aspects, and ultimately Department of Economic Affairs wants refer the case to Central Water Commission for seeing the concept design if it can be dealt with these forces at the barrage itself. So on the request of the HPPCL, Central Water Commission took the problem and analyzed. So though it is very big, but in short time I will try to cover the basic aspects. If it found interesting, we can take 5 more minutes with the approval of the chair, if allows. Yes, so the content of the presentation will be introduction, then the problem statement. So let me know what the background and in quickly and what the creeping force and how it had been arrived at. Then concept to dealing with this large concept. So initially we have started to transfer this huge force from the right slope to the left competent bank. In the left side the competent rock was there, but the main issue was the right bank. So it was decided to transfer the force from right bank to the left bank. But later on, doing the lot of iteration, we found it that it may not be possible of all the forces to transfer to the left bank itself. So some part of force will have to transfer foundation also. So let me see how the shape was arrived at. Then the observational approach was also considered because of the very unconventional nature of the creep forces and the estimation we have done and the future scope, and so it was decided to observe it throughout the life, and secondary measures were also considered. Then devising suitable structural arrangements, it will be part of it, and the adopted structural and non-structural interventions like monitoring and all those things, and later on the in last conclusions. So this is the layout. So we can say the right bank, a creeping force in the green patch. So this is a vast slope which estimated to be having a large creeping, and the volume of the slope itself is estimated to a very extensive. So the project, some brief description of the project is a run-off the river project, and the diversion structure is barrage, and having 7.7 kilometer HRT with 10.5 meter finished dia on the left bank, and underground structures, desilting basin and the powerhouse and all those structures. So most of the work has been done since the work started in 2012, and the issue of the creeping was later on found after DPR clearance, and when the funding of the foreign banks has been come into picture, they have hired Lamer International, and Lamer International have been given the exercise of the estimating the creeping forces. So this is the L section we can see. So the stage of the works, so almost all the underground works has been completed except the barrage. The barrage structure also coffer dam and the diversion work were already carried out. So come to the problem statement. As per detailed project report, it was on the right bank, a huge slope was deposits were there, and the slumped rock mass up to the, this is a National Highway 5 are there, and the fluvial deposits and the slope was the main which was causing the creeping forces. A few isolated rock exposures were also observed on right bank upstream of the barrage axis, and no concerns at the measures regarding stabilization of right bank slope have been addressed at DPR stage, because at that time creeping was not assessed. So in the upper image it can be seen that this is a very large chunk of the slope which is estimated to having the creeping nature. So it is almost 1 kilometer wide at the top and 3 kilometers at the river edge. So depth, its depth is also varying. It maybe goes as high as 80 meter deep near toe, 80 meter near toe, and as high as 200 meters later on. So this is very deep slope, so it was not possible to treat the slope from the conventional methods. So these are the instrument monitoring data, mostly data which are estimated by the almost 2 years in 2018 and 19, and the subsurface, in the surface movements, there was not a much creeping forces have been estimated, but on the subsurface measurements of the inclinometer, it can be seen as high as 180 or 190 mm. So this was a very mixed type of the response of the different investigations. So photo documentation of slope by remote sensing was also done through LIDAR methods. And surface movement monitoring through Airbus was also, because Airbus was also hired by HPPCL. In the surface data, it was very less, but in the underground or subsurface, the movement was quite considerable. But it was also varying across the different inclinometers. So based on these, various alternates have been explored by HPPCL to deal with these aspects. So definitely shifting of barrage complex upstream, but it has been ruled out due to already in place of the most of the underground structures and the extra head losses and the storage limitations for the peaking and other aspects. Then one L-shaped right bank stabilization was also given by SMEC. That was also with 55 meter deep diaphragm wall and the struts from the bottom. So that was also been ruled out due to structural issues. Then heavy set of soil anchors and Campbell anchors for the slope stagel was also proposed, but that could not be give confidence. So again, it was ruled out. So lastly, HPPCL was of the view to redesign the barrage complex to sustain these huge forces. And accordingly, the matter was referred to the AF consultant, and the CWC was involved to review these all aspects and devise the concept design. So how the concept is coming? So what the observational approach or the conventional one? So here the only difference we kept that we have estimated a particular force based on these observation and other aspects and the set theories, and that estimation we cannot assume that it will be the true case. So though we will design the barrage structure with these lateral forces, but later on we need to monitor the structure. So that is the observational approach all about. So this we can see the approach how they adopted. So it involved during the time 2018 to 2020, involved panel of experts also give their diversified fields. They have given some thoughts. Then major questions to be answered through this method was the necessity and the cost effectiveness of a foolproof remedy. So what should be the force? This was the first questions to decide for the structures. Then the next question was the extent to which the uncertainty can be addressed and the future scope, how it can be mentioned. So the three steps, first is the prediction of the creeping force, next is the devising the structural measures before completion of the project, and the third is mitigation is the long-term plans for the future. So these are the forces estimated. We can say the four main methods have been used: the earth pressure at rest, then the Brendel approach, and tow resistance, and the rheological approach. All these, the maximum forces we can see has been adopted with a suitable factor of safety. The structures has been divided into three distinct portions: the barrage structure at the barrage axis itself, then the downstream stilling basin due to their inherited characteristics we will discuss in later on, and then the intake portion. So factor of safety is also kept different. So ultimately these are the 17.5 and 19.4 are the designing creeping force for the barrage and the stilling basin. These forces are in mega Newton per meter. So these are very huge forces which have been adopted for the, so ultimately we have decided to analyze this project from the MIDAS software, MIDAS NX. So in right picture we can see the structure had been divided into three portions, the portion 1, 2 and 3. First, one is the intake area. Here we have no structural component except the base slab. In second we have the bridge also which can be utilized for transferring the huge lateral forces to reflect it as a box structure like that. And the third one is the stilling basin. That is the down, some depth, it is below the main barrage axis, as we all know. So here also we have introduced some studs at the top portion so that the box type structure we can use. So here we can see the axis structure portion 2 and 3. We get some advantage due to their shape and the less limitations on the hydraulic criteria. But in the intake portion, in the left side, there is an intake structure that is not part of this particular analysis, but the right side we can see we have provided a deep wall and then some box type structure we have envisaged, keeping in view the flow restriction in mind. So this is the plan what we have arrived at based on different years. So here we can see the dam axis central portion is the dam barrage axis and the box type structures on the barrage, here top bridge and all those, and the divide walls have been used, and the studs, some more studs, the trunnion beam and etc. have been continued. So here we can see right below, right bank, that is the bottom one. So from right bank to the left bank, the continuity has been maintained to transfer the forces. In the downstream, the portion is the stilling basin area. Here we have introduced the divide wall, extended the divide wall up to the top studs. And accordingly, the force has been, we were able to transfer most of the forces to the left bank in both these components. But when it comes to the intake structure, since flow has to divert towards the left side, here we can see the intakes. So it was not possible to keep continue the studs at the top. So it gives that most of the trouble during the analysis and devising the suitable portion. Here at the right bank, the bottom one, we provide a huge wall. So semi-gravity wall we can say, and then we have provided, extended the two base divide wall and provided the studs in the two portion. And anyhow we have to able to transfer most of the bank, but here most of the force has been, we have to transfer to the foundation. That is again very less bearing capacity of around 20 ton per meter square. So, but we have to thicken the base slab quite considerably, and we are able to transfer a portion of the port to the left bank. But again, since intake was there, so uplift of the intake and all those things were challenging. During upstream drawdown condition, then we have to provide some anchors we can see in subsequent slides. So these are the three distinct modules of the apron area, intake area. The second one is the barrage structure. We can see from the top how we have arrived at the utilize the breezes and the downstream trunnion beam and all this. So in the right portion you can see a massive wall. It is almost 11 meter wide wall. Yeah. So third one is the stilling basin area. Here we give the clear cut studs to utilize. But the first one is again critical, you can see. So adopted structural and non-structural measures. Structural we have already discussed. So here we can see that during the uplift in the intake area, the central slab was uplifting, or it was causing a huge force to the left bank below the intake. So intake was also lifting the structure. So we can see that we have provided some cable anchors on 2 rows of the cable anchors towards the left bank, and we have thickened the base slab. In the first 2 bays, it is more than 5 meters, 5.5 meters, and the rest it is 4.5 meter continuous slab at the bottom. And the divide wall of the 2 divide wall extended, and the continuous struts has been provided into 2 bays. So this is the barrage structure, left one and the right one, the steeling basin. Here also we can see the top portion. So here again some the movement of the gates and other challenges were foreseen. So estimated, and accordingly we have arrived at a agreeable values of the deflection and the movements. So again some foundation intervention were also required to strengthen the foundations because the SBC was very less, and the sizable portion of the intake, load of the intake area was going to the foundation. So some treatment in the foundation has been suggested. So these are the piles we have to suggested based on the forces. So intensity of pile, we can see how the load is moving, transferring in the intake area below the wall, and later on the intensity of the piles is quite high. In the steeling basin it is manageable, but in the barrage area also a sizable force is going to the foundation. So this is the initially concept, a rough figure. We can compare the initially envisaged barrage, the upper image, and the lower one is the modified shapes in all these 3 structures. So again, we have provided the observational approach, these kind of instruments, the stress and the strain at the critical forces, and we have defined the values also, which we can, HPPCL will refine in the due course. So which we can see the observational approach, these are the critical from the different points. So accordingly suggested to measures. So suggested non-structural measures, the provision of a compressible soft layer is also, provision is kept on the right bank. If some portion of the force can be mitigated through compressible clay layer also. And also placing the pre-stress anchor and strengthening of concrete and implementing of slurry trench walls in due course if the allowable limits of the instruments give us some indication for the secondary treatments or secondary strengthening. So conclusion, we can see most of the we have discussed. So it was a very large force of the 17 to 19 mega Newton per meters. So which we have dealt through the structural components after modifying and the redefining. So it is a unique one of the kind of the barrage structure. The observational approach has been suggested. A stiffer barrage complex with the addition of continuous struts has been arrived at. And structural form for different components of the barrage complex transfer heavy creeping forces from the creeping right bank to the competent left bank, ultimately recommended. And the foundation improvement and all those suggestions have also been suggested. So construction methodology and the monitoring. So construction methodology, how the excavation of the right bank has been done and what will be the sequence, those were also be suggested in the reports. So alternatives are developed. We believe that the HPPCL have already taken up the job and they are devising the contractual and other aspects, and definitely we will see a positive hope that the project will see the light in early March. So thank you.
Thank you, Mr. Shekhawat, for nice presentation. Probably you have modeled a 3D model of your structure and imposed the creep forces after that. Or was it possible to model the slope itself with the structure and to take a constitutive model of such
if we have modeled the creep with the model, it will be very difficult to arrive at the forces because the arriving at the creeping forces was the main issue. It is a different study. Based on all aspects, the creeping force was the first thing which we have to decide, and later on how to mitigate it with the structure. So combining both, though the base portion was the part of the structures, which we have decided kept in the part of the study, but not the right slope.
Okay. Because if you...
Slope was studied separately, and based on the slope and the movements and the instrumentation data, the creeping forces have been arrived at.
Okay. So was it possible or has it been explored that we can choose some constitutive model for the creeping force and model with slope your structure, then you analyze in total? Was it possible?
Creeping slope?
Constitutive model means you model your structure with the slope. You put some material property or a constitutive model of creeping model to your slope and take this analysis can be done in total.
The analysis can be done, but ultimately the forces what we are assuming, that may not be reflecting that truly in that way.
Means estimation of the
Estimation of the force is the because
Okay.
all those things will depend on that only.
Okay.
Okay, thank you very much, Mr. Shekhawat, for a very nice case study and presented very well. And I hope many of us will be having a lot of questions. We give a round of applause to him. I request all the audience and delegates of this conference to contact him if at all they have any questions. Let's go to the last but one presentation on evaluation of IS code specified method of design for gravity dam by response history analysis. So anybody is there to present this? I hope nobody is there. So let's move on to the last paper of this session, which is in addition to what was specified, it is given. Dam rehabilitation case study on Sardar Sarovar Dam by Pushpani Kumar. 10 minutes, sir.
Good afternoon, ma'am. Good afternoon, sir. Good afternoon, everyone. So here we have a case study on dam rehabilitation for Sardar Sarovar Dam, which has been done. My name is Pushpam Kumar. I am target market head for refurbishment at Sika. Sika provide complete solution for the dam structure, for every kind of repair, rehabilitation, waterproofing solution. Sika has got the complete know-how. I would not go in those detail. Let us talk about the project which we executed. There were three different work which was awarded. First was repair at upstream side, above water level. The second work was repair upstream side at underwater level. And the third project was on the downstream side. So we had the opportunity to work on this project, and we delivered the project nicely. So first was the challenge. What were the challenges at Sardar Sarovar Dam for which the work was initiated? One of the major challenges was the joints, the horizontal lift joint and the vertical block joints. This was somehow there since long during the construction itself, and this was creating some challenges at the dam body. Second was the honeycombed area at the upstream side. Third was the leakage in the dam gallery. And somehow all these were connected to each other. So this was very important to treat the complete cause for the deterioration in one go. So when the work was awarded to us, planning is very important aspect for any of the repair work. So assessment of the project was very important, which was done by our team. Then there was technical presentation which we had done to all the stakeholders. The kickoff meeting were organized by our team so that we have communicated properly what was conceptualized at the time of framing the tender specification, what has to be delivered. The checkpoints were clearly identified that where we have to do the checkpoints. On-site training with all Sika material was given to the application team. Site-specific method estimating were prepared, and documentation and record keeping for future references was another important area where we had worked. Some photograph during the execution of work at the planning stage. So Sika team was there to conduct the complete assessment of the dam structure, the kickoff meeting, and the on-site training were provided. Second was upstream side is always challenging. So especially when we have to execute those large work, it is very important that the accessibility should be very rugged, and there should not be any kind of safety concern. So a special arrangement was made to assess the complete upstream side. If you see the Sardar Sarovar Dam, it is a large front, 45,000 square meter area. It's quite a big front, wherein the special arrangement were made to assess the site. Safety training was provided to all the team members because during work it is very important that we maintain the safety. The complete assessment was done. Like you can see this on-site photograph wherein the complete upstream side were assessed. It was framed into a different pattern, and then we had started the surface preparation, because most of the time we have seen in case if the surface preparation is not done properly, whatever repair we do, whatever best material we use, if the surface preparation is not good, it is not going to give you the desired result. So surface preparation is very important key. So usually what happens in the upstream side or any of the older structure, there are a lot of scaling is there. So for removing those scaling, this is very difficult to remove. Manually it is very difficult. And if you do not do the surface preparation nicely, then the repaired material is going to come out over a period of time. So it was made in a different compartments. Every 5 meter left were divided into different compartments, and where the surface preparation and all the monitoring were done. Special equipment were used for maintaining the pressure for high pressure water jet. On the right hand side photograph, you can see this is ICRI, International Concrete Repair Institute, has given the guideline on preparing the surface for different applications. Like in general, when we say surface preparation cannot be common for every kind of application. Like when we are applying a mortar, when we are applying a coating, when we are applying a thin coat. So these surface preparation has to be very specific. So as per ICRI guideline, CSP 6 was the right surface which was required for repair. So it was maintained by high pressure water jet. You can see some small video clip how the surface preparation was done in the compartments. So complete surface was first treated. Then we came to the main work, where the first task was to treat the horizontal left joint and the vertical block joints. So herein what we did, the complete joints we had opened, like 10 mm by 10 mm groove were formed all across the joint. And this was very important, because if we do not open the joint, and if we just put some material, it is going to come out over a period of time. So we have to create a V-notch wherein the contact surface area is maintained between the parent structure and the repaired material. So a V-notch was framed by grinding machines and the concrete cutters. And this was a small, like 10 mm by 10 mm to somewhere between 10 to 25 mm size, it was maintained. And then a special material was used for sealing the joints, which was moisture insensitive. It's a 2-component solvent-free moisture insensitive epoxy putty, Sikagard 694 Fi. This is having very special property. This can be used for underwater application also, because mostly the challenge in case if the surface is damp or if you have the standing water or high moisture level, you cannot use epoxy. But this product is designed to work in underwater application, and it gives 40 MPa compressive strength in 1 day time. So first all the joints were sealed, then the joints was to be made completely impervious, and for that it was very important that we seal the joint, because surface we have treated, but in the dam body where you have the quite a deep joint, it is very important to seal those. So what we did, we had installed NRV packer, non-returnable valve NRV packer at an angle of 45 degree, so that this NRV is intersecting those joint sections. And those joints were later injected with low viscous epoxy resin, Sikagard 52 LPIN, which is again a moisture insensitive epoxy resin. And this complies to ASTM-C 881 type 2, type 4. This is very important for all the specifier. They understand the importance of ASTM-C type 4, which is for the load bearing application. So this product complies to ASTM-C 881 type 2 and type 4 both. This was used for sealing those joints. Some of the side photograph, you can see the first photograph, what you see here is making the V groove at the joint section. Then the drilling was done, then the sealing of the joints were done, and the injection was carried out. Like when you work at such a altitude, like at a height with the hanging platform, it is very challenging. You can see when the person was drilling hole for installing the NRV packer, the entire platform was moving back because of the reaction. So some special arrangements were made to fixing those platform at every interval, so that the drilling can be done properly for installing the NRV packer. So this was the first task which was done for the joint. Second was the repairing of honeycomb surface. So usually for honeycomb repair, what we do, we remove all the loose particle from the concrete surface. And the idea is there should not be any loose particle on the concrete surface, so that it does not debond over a period of time after the repairing work. So first was preparing the surface, cleaning the complete substrate, and then a bonding primer was applied on the prepared surface, epoxy based bonding primer. And then on all across the honeycomb surface, 3-component epoxy mortar was used. Again here we had used the moisture insensitive epoxy mortar, Sikagard 53 EVF mortar. This is for repairing those honeycomb section or the deep pockets. Some of the site photograph you see here. On the top photograph is the application of the bonding primer, and the bottom clip what you see here is the application of 53 UF mortar for repairing those honeycomb sections. Then the third part was the upstream side, and especially at the dam structure we have a lot of scaling happening which is to be removed. So the complete surface, a lot of undulations are there on the dam body. So for treating those defective surfaces, we had gone for a complete mechanical cleaning of the dam body on the upstream side. Then a 2 mm thick epoxy mortar was applied all across so that all the surface defects can be repaired. And on the top of it, UV resistant polyurethane based PU coating was applied, Sikagard PU UR. This is for the complete upstream side. Some of the photograph you see here, the application of epoxy mortar all across the dam body in 2 mm thickness, and then application of the protective coating which was applied. This is UV resistant protective coating. This is completely color stable and this is safe in UV condition also. So during repair, you can see on the left hand side, this section is after the application of repair mortar and then after the protective coating. And on the top you see, this is the unrepaired surface. Some other photograph at the finishing stage. So to summarize, 3 application area, the joints, horizontal and vertical joints, this was treated with epoxy putty, Sikagard 694 Fi. And then the joints were sealed by injecting low viscous epoxy injection, Sikagard 52 LPIN. The second application was patch repair, which was done with Sikagard 53 UF mortar. And the third application was protective coating on the entire upstream side, which was done with Sikagard 31 for surface sealing and Sikagard PUUR for protecting the complete surface with upstream side. So these are some photographs. At this forum, I also would like to highlight the Central Water Commission has given some guideline for dam repair, and there are clear specification for cementitious mortar and the epoxy mortar. So here are some of the guidelines from CWC. On page number 20 on CWC guideline, it is given for performance for cementitious mortar, which is the mortar should be CE certified and it should comply to EN 1504 class R4 grade. And yes, sir, the performance criteria is already defined. Sika has the complete material for this. We had recently started this product in local production so that we can support all the project site. The another one is for epoxy mortar. On the page 22, the performance criteria is given for epoxy mortar. Here also we provide the complete solution for complying with the CWC guidelines. So with this, I conclude my session. Thank you, ma'am.
Thank you, Mr. Pushpam, for a nice presentation. So, what were the geophysical tests conducted before this treatment?
Sir?
What were the geophysical tests conducted before this treatment?
Sir, I would not be able to comment on the geophysical test which was done prior to the preparing the tender specification. The specifications were framed by the department and then we had started working on those specifications.
I want to know whether this decision was taken to treat the vertical and horizontal joints after carrying out some test, or
I'm sure definitely some test would have been conducted, because the leakage which was coming from upstream side, one of the main reason was the joints.
So have you treated the whole face?
Whole the upstream side surface.
Okay. Thank you.
Yeah, very interesting presentation. This has given the pre-execution planning, accessibility to the problem phase, and the surface preparation and the solution provided. It's an interesting presentation, and many questions are cropping up in my mind as well as our delegates' mind also. They will be contacting you in person. Thank you so much, Mr. Panikumar.
Thank you, ma'am. Yeah. Thank you, everyone.
So in this session on major rehabilitation and other risk reduction investments, 5 papers were presented, starting from the overall view about the instrumentation for the safety of the dam, then underwater rehabilitation of dams and related structure, masonry dam effective measures to seepage, and Shantong Karsham hydroelectric project, the creeping of slopes, and the last one with the dam rehabilitation of case study, Sardar Sarovar Dam. It was full of many case histories and well presented, and with this we are closing this session, and I am handing over the session to the organizers.
All right. Thank you so much, the co-chairman and chairman, sir. Now I would like to request our Secretary General, Mr. Michael De Vivo, to kindly come on the dais and please do the honor. Okay, I would request Mr. Michel Lino, sir, to kindly come on the stage and please do the honor to present the memento to our chairmen and co-chairman. Chairman Ma'am Dr. R. Chitra, Director, Central Soil and Material Research Station. Memento to our co-chairman, sir, Mr. Vivek Tripathi, Chief Engineer, Central Water Commission. Thank you so much, Michel, sir. Now I would like to request our chairman, ma'am, Dr. R. Chitra, Director, Central Soil and Material Research Station, to kindly do the honor to present the memento to a participant, Mr. R.S. Serra. Mr. F. Ronald, Mr. R. Vigneshwaram, Thank you so much, ma'am. Now I would request our co-chairman, sir, Mr. Tripathi, to kindly do the honor for presenting the memento to our next speaker, Mr. N.S. Shekhawat, Mr. Pushpam Kumar, and we have some mementos for the poster presentations as well. First of all, I would like to call Mr. Ketan Patel, Research Scholar, IIT Roorkee. Mr. Vishal Singh, again Research Scholar, IIT Roorkee. Mr. Rahul PR, Research Scholar, IIT Roorkee. Ms. Shruti Jain, Research Scholar, IIT Roorkee. All right. Thank you so much, our chairman, ma'am, and co-chairman, sir, for conducting this session so nicely. Thank you so much. So now proceeding to the next session, we have our technical session, which is DRIP, Rehabilitation Case Studies. All right. We are going to proceed after the lunch break, and I would like to request everyone to kindly proceed for the lunch break, and we are going to continue the next session at 1:30 sharp. All right. We have some more time for the lunch. So it's 2 o'clock. And I request you all to kindly reassemble here at the same venue at 2 o'clock. Thank you so much. Please be on time. Also, I would like to request all the participants of the next session, which is DRIP rehabilitation case studies, to kindly come here and please submit their presentations so that we can download them. Thank you. Mic off. Mic on. Mic off. Off. Sound check. Okay, so welcome back everyone. And now we will proceed for the next session. And the next session is the technical session, DRIP, Rehabilitation Case Studies. So I would like to request our Chairman Sir Shri Vijay Saran, the Chief Engineer DSO, CWC Project Director. And we have our Co-Chairman, Mr. Anil Jain, the Chief Engineer, Central Water Commission, to please come on the dais. Before we proceed to the next session, I would like to make a very important announcement that we are going to have the lucky draw over here, and I would request all the dignitaries to kindly keep your, put your business cards in the bowl there. And also, I would like to tell you that we have this lucky draw where we'll present 2 lucky winners. And for this, all delegates are requested to put their business cards. Then we are going to take out the 2 lucky winners. And do you want to know what would be the lucky winners getting? Yes? All right. So we have 2 lucky winners. We'll be having 2 lucky winners, and for them we would be having 2 gifts. The first one is the very expensive cricket bat with the signature of Mumbai Indian team. And second, we have a designer t-shirt. So I request everyone, before we proceed for this session, I would request all of you to kindly put your business cards in the bowl there. Thank you. Okay, we are sending the hostess to all the dignitaries. Kindly take out your business cards so that she can collect your cards and put into the bowl for the lucky draw. All right. So now we shall proceed for the next session. I would like to request our chairman, sir, Mr. Vijay Saran, can kindly proceed for the session. Thank you so much, sir.
Good afternoon, everyone. So it's always very difficult post-lunch and the third day. Still, this being an interesting session, I would expect the audience to remain awake and listen. This session, we have 7 papers, but as I am told by the organizers, we have 6 presentations already loaded on my system. So considering that we have 6 presentations and 1.5 hours at our disposal, so we give 12 minutes to each presenter, and after he presents, and if there are any questions, we will take them. Otherwise, we'll try to finish the presentation. So, Anil, you want to say something? Okay. So without wasting any time, we will take the first presentation. And the first presentation is sinuosity analysis of Barak River from Fulere Tal to Badarpur Ghat and its significance in project planning by Manoj Tiwari, Govardhan Prasad, and A. Gupta, and from Central Water Commission. So here we have Mr. Govardhan Prasad. He will introduce himself and start the presentation.
Chair and co-chair and esteemed delegates in audience. I am going to present a case study regarding this sinuosity analysis of Barak River from Fulertal to Badarpur Ghat and its significance in the project planning. Basically, this study we have done for Barak Basin and how this Barak River is behaving in last 30 years based on this satellite data and other data available. So, the contents of my presentation is like this. First of all, brief about the meandering, then brief about the Barak River, then what are the data used, and what we have considered methodology and analysis, and then conclusion. What the objective of study is? Actually, study aims to analyze the morphological changes of the Barak region to understand its morphological behavior by considering sinuosity index using the satellite data and other remote sensing data. Basically, we have done a study to see what changes are there during the period from 1990 to 2020. over a period of 30 years. This period we have divided into two parts. In first part, we have taken from 1990 to 2005, and then 2005 to 2020. The reference year we have taken is 1990. And sinuosity we have calculated based on the reference years. And for inputs for sinuosity, we have taken the center line at the start and end points of reach. This is the basically brief about what is the meandering. We all of know what is the meandering. It is a flow of rivers in sinuous curves. Actually, this is just like sine curve. And what are the causes of meandering? Basically, cause is the loss of transport capacity of river due to flat slope. Because of that, flow velocity of the rivers get reduced, and resulting in the sedimentation as well as the curve in the flow of the rivers. In this study, we have taken this sinuosity as one of the parameters for defining this meandering, basically. So, this is the definition of sinuosity. Sinuosity is basically defined as the length of center line and the length of valley axis. Basically, center line length divided by the aerial length. In this, the channel is classified based on sinuosity. If sinuosity is less than 1.05, it is called straight channel. When sinuosity is between 1.05 to 1.5, it is sinus channel. And greater than 1.5, it is called meandering channel. Then, what are the uses of sinuosity? I have listed out some uses, like the flood and drought management, land and plain management, management of river and sedimentation, river ecology, and management of some water infrastructures listed in the presentation. This is a brief about the Barak Basin, Barak River. Barak River is one of the major rivers of northeastern India. It originates from Jaipur mountain in Manipur, and this latitude and longitude of this origin and the end point is given, and it is more than 500 kilometer length in India, and after that it goes into Bangladesh, and the total drainage area is around 50,000 square kilometers. And basically, this is whole Barak River is divided into three parts. From origin to Flatal, it is in the hilly areas, and slope is quite significant. But from Flatal to AP Ghat and AP Ghat to BP Ghat, it is in the plain area, and slope is very flat. Because of this meandering problem is there in this area. And this, in this study, we have taken the data of Google Earth Engine and using the GIS and remote sensing and Landsat images, we have done the analysis for this sinuosity calculations. This is the methodology, analysis based on the advanced remote sensing data and ground measurement, etc. And for this, we have determined the river center line and the width of the river and aerial length also. This is a GIS processed image. In this, the whole river is divided into different segments, and we have considered the segments lying in the plain area, because in the mountain area, river is flowing in the valley with the hard rock area, and there is no meandering. This total reach is divided into 30 reaches, the total length of river. Out of that, 21 to 30 we have done this sinuosity. Actually, in reach number 21, you can see in this, in 1990, 2005, and 2020, there is no change in sinuosity. So because of that, reach is stable. In 22 also, same condition is there. In 23, this sinuosity is increased, and because of that, this reach is taken as meandering reach. In 24 also, this is also meandering reach, and in 25 also, sinuosity is reduced. Because of this, the cutoff is there, and the length of the river is reduced. Because of that, there is a decrease in sinuosity. And you can see 26 and 27 also is more or less stable reach. There is no or very less change in the sinuosity. But you can observe in the case of reach number 29, sinuosity is very high. And because of that, this is a meandering reach, and this is also not a stable reach. 30 is also, so out of 10 reaches which we have shown in this table, 6 reaches are meandering reach, and one reach number 29 is having high sinuosity, and lot of bends are also there. Because of that, the river is changing its course in this period. This, in this table, we have shown how in the Fulay Tal to AP Ghat and AP Ghat to BP Ghat, length of river is changing. Basically, in case of Fulay Tal to AP Ghat, from 1990 to 2020, the length of river is reduced. But in case of AP Ghat to BP Ghat, length of river is increased. So this shows that in first reach, there are cutoffs and river get straightened. And in the second reach, the river is, length is increased because of that there are a lot of meandering. And these are the conclusions from this study. And Barak River is actively meandering from Fulay Tal to BP Ghat, where it flows in alluvial plains. And sinuous length total is actually 115, whereas aerial length is 44. Because of that, we can see that sinuosity is around 3. Maximum sinuosity, this is 3, it's already shown in the table. We have 9 oxbow lakes in the floodplain of Barak between Fulay Tal to BP Ghat. And a series of cutoff, translation, all these things are there. And some tributaries are also joining from the left side. A channel shifting actually is in some places arrested by dissecting hills at some places. Top of length is more or less stable in the entire length. There is no, because of that, it shows that there is very less erosion. And in this, the flood embankment and bank erosion protective measures are also influencing the plainform changes. Because whenever we provide the embankment and other protection measures, so the natural behavior of river changes. And as shown in our table, in reach number 29, a lot of bends are there, and it is a most active reach. There is no channel or inbreeding pattern in erosion of sediment observed in the satellite imagery. Because of the active reach as identified in this study, there is need to give due attention in planning. So we have to see which reach is have increasing or decreasing sinuosity, that is most active reach, and we have to plan the projects accordingly, considering the river behavior. Because if we take previous years satellite data and other things, then it will be very useful to plan cost effectively the protective measures and safety of inhabitants, etc. So this is from my part.
Okay, thank you, Govardhan. But if there are any question towards the author? If not, I have a small comment.
Sure.
Actually, what analysis he has presented is a very useful analysis from two perspectives, because this sinuosity, once we are finalizing the axis of a dam, barrage or some structure, then this study is very important so that the structure is not outflanked based on the prior study data. And secondly, it is very important to plan our anti-erosion works, etc., for the emergency action plan, because we know in advance that this will be the meandering behavior of the river on the left bank or on the right bank. So we are geared up in advance in a certain way. So if there are no questions, thank you very much, Govardhan, for a nice presentation.
Okay, thank you, sir. Thank you, sir.
Next announce ko to bula lo.
Next is design flood review of Gandhi Sagar Dam using multi-storm analysis. I hope Ms. Payal, and who is coming? Yes, please.
Good afternoon, Chairperson, Co-Chairperson, ladies and gentlemen. I am Payal Goyal, Deputy Director, Central Water Commission. And today I'll present the paper on design flood review of Gandhi Sagar Dam using multi-storm analysis. So firstly, I'll give a brief about Gandhi Sagar Dam. It's located on Chambal River in Madhya Pradesh. It's a masonry gravity dam of 62 meter high. And the gross storage is very high. It's 7.3 BCM. It was completed in 1960. It provides both power component and irrigation component. Irrigation component is from Kota Barrage. So the FRL of this dam is 1,312 feet, and the top of the dam is at 1,324 feet. So you can see there is a significant 12 feet gap between the FRL and top of the dam. So this provides a storage of about 2.5 BCM of water if any flood impinges. The spillway is OG type, and there are 9 sluices in the dam. So in 1960, the design flood for which it was designed is 21,237 cubics. The combined spillway and the sluice discharging capacity is 13,000. So this design flood of 21,000 has been exceeded a number of times in the past. In 2019, as we all know, there was severe flood in Gandhi Sagar Dam. There was severe rainfall. And due to this rainfall, the water level in the reservoir reached 1,318 feet, 18.87 feet. And it remained over there for about 7 hours. So it created a concern, and that's why a need was felt to do the design flood review of this project. So if we see the event of September 2019, we got the data of rain gauge stations of 4 hourly data and daily data of the rain gauge stations in and around the catchment, as you can see on the red dots in the map. And we made ISO height of the rainfall using ArcGIS. So the catchment represented a rainfall for 13th, 14th, and 15th of September were 51 mm, 83 mm, and 92 mm. Then we prepared a synthetic unit hydrograph for the subbasins, and using the observed hourly distribution coefficient, we made a model in HEC-HMS and tried to simulate the flood hydrograph. Then we carried out reservoir routing to simulate the observed results of 401.99 meter that the level had reached. We tried to simulate that using elevation area capacity curve and reservoir routing. So from that, we could estimate that the flood peak was about 33,000 to 35,000 cubic, which is quite significant as the spillway capacity is around 13,000 cubic only. So these are the reservoir routing results plot. On the top, the storage variation is shown, and on the bottom, the inflow hydrograph, how it impinged and how it was routed. We carried out the design flood review. As per the guidelines for fixing spillway capacity, IS 11223, which came in 1985, after this dam was commissioned, this dam qualifies for probable maximum flood since the height of the dam is more than 30 meters and the storage is more than 60 MCM. So the catchment area is 22,000, and we had to divide the catchment into smaller units to make the unit hydrograph. So it was divided into 13 sub-catchments. In ArcGIS, we determined the catchment area, longest flow path, centroidal longest flow path, and equivalent stream slope of the catchment. So these are the input to make synthetic unit hydrograph using Central Water Commission's flood estimation reports. For Chambal Basin, we made the unit hydrographs. So these are the unit hydrographs that were prepared. Now, the most important part. This design storm selection in any design flood estimation is the critical most. So in this, we analyzed around 4 storms. Firstly, the storm of 26 to 28 July 1927, which was centered at Dakor, and the peak depth was about 1289 mm. This storm was taken in the design flood review of 1994. That is why we considered this storm. Then 18 to 20 August 1974, 3-day storm of Tarana, and the peak depth of 525 mm was taken. This was the most critical storm for catchment area greater than 20,000 square kilometer in PMP Atlas of Ganga Basin. Chambal is a tributary of Yamuna, which is a tributary of Ganga. So in Ganga Basin, PMP Atlas, this storm is considered the critical. Another storm that is considered critical in this PMP Atlas is 5 to 7 September 1932 storm, which was centered at Agar, and the peak depth was 522 mm. Also, we considered the storm of 13 to 15 September 2019 in Gandhi Sagar catchment. So we did some calculations with different time distribution coefficients, different loss rate combination, and then the results are given in the next slide. So this is the HEC HMS model, which is set up to get the combined response of all the catchments and the channel routing that the flood undergoes when it flows through the river. Like if this small catchment, for which we have made unit hydrograph, if we see this small catchment, we have made unit hydrograph for this. We have rainfall depth for this. We will get a hydrograph at the end of the catchment from this point, this catchment, which will be routed through the river and it will contribute further. So this, likewise, the whole catchment has been modeled in HEC HMS, and the channel routing parameters have been decided based on Muskingum routing parameters, K and X. And the number of subreaches has been decided based on the condition in Muskingum routing that delta T should be greater than 2kx. So these are the results that we got. So if we see the 3-day Dakor storm and loss rate of model, which is given in the flood estimation report, the estimated peak is about 50,000 cubic. And the total volume of flood hydrograph under the flood hydrograph is 10.84 BCM, which is a huge volume. And if we see the volume of hydrograph above the spillway capacity, it is 5.99 meters, 5.99 BCM. These floods were also reservoir routed through the Gandhi Sagar Dam, and the levels reached are given in the table. So this is the Tarana storm. The estimated peak was about 41,850, and the volume of this was 7.3 BCM. Similarly, these calculations were carried out using the moisture maximization factor, barrier adjustment factor, location adjustment factor. After taking all these things, we have done these calculations. So this is the plot of PMF that we have received. So these are the key findings that we got on the PMF, peak and hydrograph. So if we consider the 2019 flood, the peak was about 34,000, and the total volume of hydrograph was 4.99 or 5 BCM. And the Dakor storm, which was giving a peak of 50,000, this storm has not been considered in the PMP Atlas of Ganga. And if we transpose it towards the western edge of the Gandhi Sagar catchment, this gives a volume of 10.84 BCM, and this volume is around 2.17 times the volumes that was actually received. So that is very high. So that's why we considered this Tarana storm, which was giving a volume of around 1.47 times the volume that was already received. And this seems to be a reasonable estimate of PMF. So that is why this storm was selected for PMF, and this is the flood hydrograph that has been recommended. This peak lies between the average envelope curve and the upper envelope curve. So in conclusion, I would like to say that in large catchments, there are multiple storms that have to be considered for analysis. And for dams which have significant storage, not only the flood peak, but the volume of flood hydrograph also plays a governing factor while deciding the PMF. And in order to analyze the impact of PMF, we need to do the reservoir routing also to understand the phenomena completely. Thank you very much for your patience.
Thank you, Bayal. I have one question.
Yes, sir.
Since you had this one observed event on 13th, 15th September 2019, and you estimated some HACRAS parameters also, so did you try to validate those parameters?
Yes, sir.
While using, and did you find any variation? And what was the model efficiency for that?
Sir, since we have to simulate, we have to make some modifications to get the observed reservoir level that had reached. So we took the previous events also, how much rainfall had occurred and how much the water level had reached. We had taken 2-3 cases, and that has been given in the flood estimation report. And we then arrived at this that, okay, if the reservoir level was this and the model is giving the same value, that is how it was estimated.
Wonderful. Did you estimate the model efficiency also for that event? No.
We took several cases.
Okay.
Historical events were taken.
Okay. Thank you. Actually, Gandhi Sagar Dam is the first dam on the series of reservoirs on Chambal Basin. I think some raised hand is there. Yes, you can ask some question. So,
yep. First, let the audience ask any question. I'll be there.
Definitely, the study is a very nice study, but I like to raise some issues.
Yes, sir.
Whether the design flood consideration at the project implementation stage was wrong, first. Second, whether the siltation of the reservoir is a factor, the storage capacity reduced. For that, design flood has been exceeded so many times. And third, in future, as the sedimentation is a very natural phenomena and it will reduce the capacity of any reservoir. So in future, how this design flood will be altered and will be managed. Okay, thank you.
Thank you. So firstly, since as I have told that IS 11223 for fixing the spillway capacity, it came in 1985, and this dam was commissioned in 1960. So that time the design storm considered, design flood that was considered must have been different. So that must have been according to the prevailing conditions. So we cannot say that it was wrong. According to the new conditions, if now the standards have improved or it recommends increased flood, then we have to design it accordingly. And secondly, PMF, the calculation of PMF does not necessarily depend on the reservoir sedimentation. That will show how the reservoir will perform. But PMF calculation is different. Yes, storage is, yes.
Definitely siltation will affect the storage very much.
Yes, sir.
It is inbuilt. You know, when you are doing the routing, then you need the storage.
Yes, sir.
So storage
that is required.
Now the storage is reduced storage.
Yes, but considering the hydrology aspect, there are two factors: basin response function and the design storm. In that, the storage is not coming into it, but definitely in reservoir routing, it will come and it will play its role. So that needs to be accommodated.
Just let me answer to your question. This, in fact, is the very basis. So we have dams about 100 years old, 75 years old, and they were designed at that point of time with the available data and with the available standards at that time. One of the mandates now is to review the design. It is not wrong, whether it is conforming to the present day standards. Now you have much more data, you have much more advanced techniques, which was not there in 1963. If by the present standards, the design flood is reviewed and if a PMF is revised, we have to take care of that, and for that, if required, we will have to have additional spillway capacity, or maybe we will have to manage the reservoir, we may have to keep the levels slightly lower regarding this thing. And so this PMF calculation has nothing to do with the reservoir sedimentation, it is the amount of flood. How will you pass the flood? That is another question. That is not a part of our study, but it is a relevant question. Thank you. Thank you, Payal.
Thank you so much, sir.
Now next presentation is rehabilitation and replacement of 136 numbers of sluice gates and their hosting equipments of Krishna Raj Sagar Dam, a case study to be presented by Mr. Aditya Mishra.
Yes, sir. Yes. Good afternoon to all. I am Aditya Mishra, Deputy Director, Gates Design, Central Water Commission. I am going to present my paper on the topic rehabilitation and replacement of 136 numbers of sluice gates and their hoisting equipments of the KRS Dam, which is 100-year-old, and the lesson learned. In this project, we have rehabilitated the 136 numbers of gates at elevation 103, 106 and 114 feet from the reservoir bed level, and successfully achieve the flood discharge capacity and operational flexibility of the gates. Before coming to the project, take a brief look of the salient features of the KRS Dam. The KRS Dam is a 100-year-old dam located in the river Kaveri. The dam is located at the 16-kilometer northwest from the Mysore district, from the Mysore city in the Mandya district of Karnataka state, and it was completed in the year 1931. The length of the dam is 2.62 kilometers, and it's a gravity dam. It's a gravity machinery dam using Surki mortar as binding material. The FRL of the dam is 124.8 feet from the reservoir bed level. The details of the sluice gate under proposed rehabilitations are: we have taken the rehabilitation of 136 numbers of gate at the elevation 103, 106 and 114. These gates are mostly fixed fixed roller type vertical lift gate, which are operated by the gantry crane, common gantry crane of 16-ton capacity. Except the 114 gate, which are the automatic gate, we'll discuss in the later slides. The size of the gates are 10 feet cross 8 feet. 106 gate is having size 8 feet cross 12 feet, and the 114 level sluice gates are having size 10 feet cross 10 feet. And their numbers are 48, 40, and 48 respectively. Before taking up the proposed rehabilitation, we have assessed the initial condition of these gates, and we have found that there were heavy leakage through the sluice gates. We can see in the pictures. The gates and the embedded parts are heavily damaged. There were corrosions and the pittings in the gates and the embedded parts. The gates are facing the issues like non-closure of the gate, and there were many other operation difficulties due to damaged components. Because of all these factors, there were loss of flood discharging capacity and increased chances of the gate failure. Because the chances of gate failures are because due to the non-operation of the gate and the damaged gate components. Ultimately, these factors will result into the poor management of impounded water. Hence, as a part of the ongoing drip project under Government of India, this old age KRS dam was considered for the rehabilitation to improve the structural safety, flood discharging capacity, and operational flexibility, and hence the overall better management of the impounding water. For the above task, an MOU between the WRD Karnataka and CWC was signed to provide the design consultancy for the above work. The status of these sluice gates before the rehabilitation works are like out of 40 gates of 106 feet sluice gates, 9 number of gates are out of order. 48 out of 48 103 level gates, 23 gates are out of order, and almost all the 48 gates of 114 level gates are inoperative due to faulty automatic arrangement. So after assessing the initial conditions of the sluice gates, we have planned the proposed rehabilitation works, in which we decided to replace all the 136 numbers of gate. We decided to provide the individual rope drum hoist to each gates, and we decided to rehabilitate the embedded parts. Under the rehabilitation of the embedded parts, the sill beam was replaced, the new side guide were provided, and the wheel track refurbishments were carried out, and the additional seal seat for the sealing arrangement were provided. We will see in detail in our further slides. In this rehabilitation measures, under the rehabilitation of the embedded parts of 103 and 106 level sluice gates, we have seen that in the existing arrangement, the sill beam having 8-inch width and 10 mm thickness is embedded in the concrete for providing the uneven surface and the even sitting surface to the gate. We have decided to replace the and in the inspection we have found that most of the sill beam were either missing or damaged. This will create the non-closure difficulty for the above gates, which ultimately increase the leakage through the gates. So we have decided to replace the existing sill beam with a new ISMB 200 x 100 sill beam with a 80 mm width and 10 mm thick stainless steel seal seat to the sill beam. The present sill beam is erected by making the blockout of 250 mm cross 250 mm, and then using the anchor bolts, this sill beam is fixed to the bottom of the gate. Further, there were no provision of the side guides in the gate grooves, hence the gate sway during the operation under the loading condition. So the additional side guides were provided by using the through anchor bolts in the common pair. To achieve this, 25 mm through holes were drilled in the common pairs, and then the 16 mm anchor bolts were erected using the using the template, and then the space between the hole and the bolts were filled with the grout, the non-shrinkable grouting material. Also, the wheel track is refurbished by using the 10 mm, the 12 mm thick stainless steel wheel track. Initially, we proposed to weld the stainless steel plate to the cast iron track base, but the welding of the cast iron is difficult due to the higher carbon content, which leads to the cracking, the cracking difficulties. So after many attempts, the desired quality of the welding is not achieved. So we have replaced the welding proposal with the screwing proposal, in which the wheel, the plate is screwed to the track with the countersunk stainless steel screws. Also, these gates, the sealing arrangement is provided with the metal to metal sealing by staunching arrangement, in which the two brass surfaces come in contact when the gate is closed. Okay, sir. Okay, sir. So, due to time constraint, just I would like to show you the erected photo of the site. These are the removal of the old 106 gate and the new gates. These are the removal of 103 and erection of the 103 gates. These are some of the modifications we did in the 114 level sluice gate embedded parts. These are some of the photos. And the key achievements of the project is we have successfully replaced the 136 numbers of sluice gates and their hoisting arrangement at elevations 103, 106 and 114. All the gates were successfully erected except the combined trestle. Within the budget and time schedule, the flood discharging capacity is restored by preventing the leakages. The overall life of the hydromechanical components were increased, and the operational flexibility will also increase. We can see in the photo that before rehabilitation and after rehabilitation how the leakage through the gates were erected. This is 114 level sluice gates, and the lesson learned in these gates are there were no provision of the stop lock in the gate, so the erection of the gate will only be carried out once the water level goes down the sill level. Further, the existing track base is made up of cast iron, and the welding will create the cracks, so it's also a problem. Due to the coronavirus also, the project authorities are forced to extend the project schedule and likely expenditure. And being a heritage structure, it's first most priority to prevent the aesthetics and the originality of this one. At the end, I would like to thank the different agencies who worked toward the successful of the project. Thank you.
Thank you, Aditya, for very informative presentation. Changing 136 gates with their embedded parts and hoisting arrangement is quite a extensive task. And if any questions, you may please ask. Otherwise, we can move to next presentation. Okay. Thank you, Aditya. Thank you. So next presentation is rehabilitation of Garala Earthen Dam by Mr. Chaudhary, R.K. Chaudhary.
Okay?
Thank you, sir, and good afternoon all. I am presenting the success story of rehabilitation of Grada Dam, which is situated in Bundi district in Rajasthan. The dam, Grada Dam length is 4 kilometer, more than 4 kilometer, and the maximum height of the section is 32 meter, and its storage capacity is, gross storage capacity is 42 MCM. The Grada Dam is constructed to meet the increased agriculture production requirement for the providing the irrigation water to a gross command area of 10,492 hectare and drinking water requirement for the Bundi city. Grada Dam was proposed to tap the discharge of 3 Chambal Basin drainage channels, namely Mangli River, Dungri River and Ganeshi River. The construction work of Grada Dam comprises of an earthen embankment, ungated spillway located near its left bank, and 2 sluices for the irrigation purpose. This is the chronology of construction of Grada Dam. You can see that in 1996 DPR was approved and 2003 construction work started, and 2009 construction was completed. But on the completion of the dam in August 2010, due to the heavy rain, the catchment in the catchment area, the water level in the reservoir quickly rose up to elevation 290 meter, which is less than 4 meter, below 4 meter from the FRL, due to which the central portion of the dam across the Dungri River washed away from the closure section. You can see in this picture. And due to flooding, due to breach, at least dozen villages on the downstream side were flooded, and this causes major damages to crops. However, no casualty were reported. Subsequent to the breach, state government ordered an inquiry to ascertain the region and circumstances behind the dam breach. After that, the soil tests were conducted, the result of which indicated the entire soil of the entire soil in the dam of single type, which implies that homogeneous section was constructed instead of joint section. The test results of filter material also show that about 25 to 30% of material is finer than 75 micron, which means that proper filter materials was not used. From the information collected from the official records, it was found out that many changes were done in DPR drawing and actually constructed drawing, which you can see here that the core was completely replaced, and the core was completely replaced, and the cutoff, the grouting holes also is shortened. The cutoff trench also shortened. After that, Central Water Commission, this problem was referred to the Central Water Commission, where the CWC have to advise on the totality of circumstances leading to a breach of dam, status of the dam in other portion, and steps required to ensure the dam safety in future. After the rehabilitation works were taken up, in which you can see that investigation were done in during 2011 to 2015, and 2015 to 17, various design and analysis were done, and construction drawings were issued. In 2017, construction started, and 2022, the rehabilitation work is completed. In the team, CRO team visited the site. There is a brief of a team report. That is, the Grada Dam was subjected to an uncontrolled filling in absence of any arrangement to control the initial reservoir filling. It was not possible to undertake any effective remedial measure in the event of any distress condition. Approval of geologists before covering the foundation and undertaking construction of the earth dam was perhaps not taken. This considered necessary in order to ensure satisfactory treatment of the rock foundation before undertaking dam construction. Subsequent to that, 4 state drawings of earth dam for the Beach portion were issued from CWC. After some test done by CSMRS, and the joint team also visit to the site in October 2015. You can see that there's excessive weed growth on the dam. These are some photographs during that visit. You can see that there's a large depression on the crush of the dam, which is left side of bridge portion. There's a mass movement in downstream slope also. There's a wide crack parallel to the dam axis on the crust. You can see there are deep rain cuts also observed in downstream slopes. There's localized slope fillers also observed there. In the breach portion, 2 wide vertical open parallel joints, which is along the river. Also, you can see that there are several settlement and bulging on the riprap on the upstream side also observed. And you can see that the dam section, bridge section, where you can see that it's clearly homogeneous nature. There was no clear evidence to existence of filter, clay core, and cutoff trench. These are some test result of geotechnical investigation done by the CSMRS, where you can see that the density varies between 15 to 20 kilonewton per meter cube, and the SPT values also varies between 10 and between 10 to 30. The taxal test also done in 2017, where the result of taxal test indicate that effective cohesion varies from 18.81 to 0.25 kg per square centimeter, and the angle of sealing resistance also vary from 25 to 30 degree. So after the test results, there are several challenges we have to cater before going for rehabilitation measures. There could be pockets, layers of low shear strength due to poor construction quality, which might lead to large settlement. There could be uncertainty in soil property, as brief investigation showed high variability in situ parameters. They had to ensure the continuous seepage barrier from FRL to sufficient depth below foundation level. The permittive values of clay core shale material are inconsistent. There were no arrangement to control the rate of reservoir filling. A scarcity or non-availability of suitable filter material also at the project area. The prolonged time gap could result in differential settlement of the interface of breach portion and interface of the existing dam and breach portion. After that, finite element analysis were done on the existing dam section also and for the new dam section. The dam section which is considered for the model was dam section at RD 2520 meter, which is selected for two regions. Firstly, it is located, its location drill hole was done from top of the dam to the foundation level, so the entire height of the dam were covered. Secondly, lowest bulk density were observed at that section. These material properties were used in FE analysis. This is a model and analysis done on the existing sections. This is on the modified section. On the based on the investigation, testing, and the slope stability analysis and seepage analysis, the load deformation were carried out. It was inferred from result of the above analysis that the dam can be made stable with the rehabilitation of slopes. However, large variation in values of permeability and field density was observed during the field investigation, which created doubt regarding the degree of compaction of the earth material of the existing dam body. To reduce the ingress of water in the dam body, the impervious system of 1 meter thick HDFE geomembrane was provided. You can see that there is 1 mm HDFE geomembrane provided, and which is sandwiched between the geotextiles to ensure the safety of geomembrane. Also, in downstream, we also provide 1 meter filter, sand filter, and geotextile filter with that to arrest the migration of soil particle. This new section is designed for the breach portion. These are the physical properties of geotextile and geomembrane used for the rehabilitation works. After that, rehabilitation work started. You can see the placing soil compaction and placing of geofilter in downstream side. Also, this is a geocomposite membrane, which is sandwiched between geotextiles, and this is the HDP membrane. Also, at the upstream toe, the grouting were done. During the rehabilitation of breach portion, the cutoff trench in the unbreached portion can be seen the laid against. During the excavation in the breach portion, we have seen we have observed that there is cobble layer in the breach below the unbreached section, which is again the whole portion of unbreached portion were removed and new freshly section were relaid there. After that, various monitoring instruments to measure the dam behavior were also installed in the breach portion. You can see the rehabilitation completed in 2020, and reservoirs were filled in July this year. There is a lesson learned with this rehabilitation works. The most common cause of the earth dam failure are piping in the dam body of foundation and overtopping. The quality control issue are the major causes for piping related failures. A proper planning on the dam site selections, project layout, design and construction is essential for safety of dam. Geological investigation and laboratory testing should be considered an essential part of design. After that, the filter on the downstream slope of COT is highly desirable, especially for the COTs which are formed by excavating very permeable strata and can trigger particle migration and piping. This study show that in the absence of downstream drainage filter, downstream slope of the existing dam is becoming a seeping phase. The existing dam section is modified by providing downstream 1.5 thick horizontal chimney filter, by which providing geosynthetic material on both upstream and downstream slope. The geosynthetic material would offer protection against piping during critical first filling of the reservoir and during the first few operating years when post-construction settlement could be expected. Thank you.
Okay, just stay. Is there any question from the audience? Any questions? No, then we have lessons to learn, not only proper design and the quality control during the construction also plays a very important role, which was sadly not undertaken in this case, and that's why major rehabilitation works had to be taken up. Another thing which was missed was this, as the Dam Safety Act also provides for inspection before the initial filling, that too also was, I think, not done, and this led to this thing. So now we have proposed the rehabilitation. The rehabilitation works have been completed, and now the reservoir has been filled. We hope that it will be okay. So if there is no other question, I think there is an announcement. Thank you very much. I think, yeah, you may have to.
Check. Okay, thank you so much, Chairman Sir and Co-Chairman Sir, for conducting this session so nicely. Now we would proceed for the lucky draw. Yeah, so I would like to call Mrs. Kalpana. I hope we have received all the cards. Yes? No? There are some. Sir? I guess there are some guests.
This lucky draw is on behalf of Team Viewer. So now I have a list of, and I close my eyes and I...
Please kindly drop. I request the hostess to kindly collect their cards, please.
Just a moment. Some people want to
still
yeah.
If someone
still,
wants to give,
yeah, we have some.
Give.
So, is this on, sir?
Yeah. No, you can use this one.
We have one hostess here also. Kindly.
My name is
cards,
Rajesh Sanvatsarkar. I look after the government business for Team Viewer. Team Viewer is the global sponsor for Manchester United Football Club as well. We also are the global partners for F1 circuit for Mercedes, and with India very recently we are also partnering with Mumbai Indians. So today we have come up with a lucky draw for Mumbai Indians t-shirt and a signed bat. Sir, aap hi denge. And this is a signed bat by all the Mumbai Indian cricketers. It's a very, very valuable one. And I'm sure you will become our customers. Next time I will ask you to sit with Hamilton.
So just one. Yeah. Anyone else
shall we proceed?
wants to give?
Any business cards? Anybody interested in business cards, please?
Even if you don't have business
I request
cards,
all the
write on a piece of
dignitaries
paper.
who haven't submitted their business cards, kindly submit to our hostesses. Anyone else? Yeah. Please collect from this side as well.
I'm okay with anything. It's just a formality.
From this side. They're at the back also.
In
Side.
case you have
There at the back also. Back.
out of stock of the business card, you can just write your name and this thing in a piece of paper.
Okay,
also.
she is
That also
coming,
will
sir.
do.
Please be quick. Please collect some cards from here, this side also. I request the other hostesses also kindly.
Hurry up. Lucky draw is going to.
Okay, we need to do this quickly.
छोटे में लिख के दे दीजिए. You can write your name if you wish.
Sir, पूरी list बना के आए हैं, I guess.
No, I think they are collecting the cards. Who? Oh, please, we will be talking to the again, sir. I have already requested Sanjay sir. We मिलेंगे ना, उनको बिठाएंगे ना उनके बाद sir.
Okay, I also like to inform you that after this lucky draw, we still will have 2 more papers in this session.
And we will continue.
And then after this session is over, we will continue with the 9th and then we'll continue. Of course, the chairman and co-chair will change and the 9th session will take just immediately after this session ends, and then we can have a tea break at the end of the day. So please stay back. After the lucky draw, we will have 2 more presentations in session 8.
One minute.
It's a sarcasm.
I request please submit all the entries.
बस दे दीजिए, रख दीजिए.
So now we are closing it.
Yes. Last, the lady.
Okay, are we done? Anyone else who is left?
Please.
One more. At the back.
ले आओ जल्दी से दे दो. बस इसके बाद नहीं.
Okay.
So here we go.
Okay, one is left. Kindly collect from there also. Only one is
what
left.
Chairman sir is going to do is take out a draw for the Mumbai Indians signed bat. Sir, you want to know, sir?
No, he has to leave.
Lucky person.
So lucky person is Mr. E. Venkateshwarlu, Deputy Director, Central Water Commission.
I request you, sir, E. Venkateshwar, please kindly come and collect your lucky draw winner gift. Many congratulations, sir. All right, thank you so much, sir. Now I request our co-chairman, sir, Mr. Anil Jain, to kindly take out the second lucky winner.
Yeah, this one.
We have
Mumbai Indians T-shirt.
Yes.
Official T-shirt.
Let's see who is the next lucky winner.
Oops.
Kindly reveal the name, sir.
Shetty. S-E-W-R-D.
Bala Sahib Shetty.
Maharashtra. S-E-W-R-D.
From Maharashtra we have Mr. Shetty.
Please come.
A huge round of applause. Many congratulations, sir.
Thank you, sir.
Thank you so much, sir. Thank you, team viewer.
Let us continue with the session.
Yeah. All right. And proceeding to the session now. Okay, we have 2 more presentations.
Yeah.
All right. Hand it over to you, sir. Thank you.
The next presentation is experience of flexible geomembrane and drip, to be presented by Mr. Subramaniam or Jagdishan. Okay.
Good afternoon all. First, thanks to Team Viewer for bringing this audience active. I only wish there could have been a participation prize as well. So, I'm Jagdishan Subramanian from Karpi, India. The topic of my today's presentation is experience of flexible impermeable geomembrane in dams with reference to drip projects. So, a quick background of Karpi. We have successfully rehabilitated more than 350 large structures that includes large dams, reservoirs, canals, tunnels, traffic tunnels, and subways. What is geomembrane? Geomembranes are thin, flexible materials with a very low permeability. And when a geomembrane is coupled with a geotextile, it is called as a geocomposite. This concept is a very simple drawing just to show that how a geomembrane acts as a barrier between the dam body and the water. You can see on the image the red line, which is a geomembrane, and behind the geomembrane it's a drainage layer. So this is one system which has the inbuilt drainage layer to convey the water behind the membrane and take it to the downstream side and ensure the body of the dam is not getting saturated. Coming to the functional elements, there are several elements that goes behind a geomembrane sealing system. One is anti-puncture layer, which is called as a geotextile and which also acts like a drainage layer. Next is the drainage element, which is a geonet material. And the very important material is the anchorage elements. So we use a stainless steel material, and the design of the stainless steel varies from structure to structure. And finally, the geocomposite material comes. So the entire system put together is called as the geomembrane sealing system. These geomembranes have been used in rehabilitations and new construction, and we are going to construct large dams in India in future, and we have already signed a project recently. And this material has been used in the rehabilitation for almost more than 70 years, and Karpi has been doing this for almost 55 to 60 years now. I'll be focusing on one of the case studies in India. We have successfully rehabilitated 3 large dams. Starting from 2004 onwards, the first dam was in Kadambari. It's a stone masonry dam of height 67 meter. The next is Servala Dam, which is the first dam to be rehabilitated under drip. And the recent one is Upper Bhavani Dam, which was completed in the year 2021. I'll go into the case, detailed explanation of how this geomembrane has been applied in Upper Bhavani Dam. So as I said, this is the second dam to be rehabilitated under drip in phase 1 between 2019 and 21. And major portion of the work was done during the COVID times. So it was a very challenging time, and it's a very important dam, so we had to continue the job in spite of COVID. It's a 80-meter high stone masonry dam and 425 meter long. The dam is located between the border of Tamil Nadu and Kerala in Ooty, which is very near to Coimbatore. As I said earlier, this dam is the first source of water for a series of powerhouses on its downstream side. You can see in the image, the yellow circle one is the first dam, and the water is conveyed through tunnels to several powerhouses on its downstream side. In 1965, when it was constructed, it was Asia's first cascaded hydroelectric scheme, constructed in the year 1965. And this is how the dam looked like before geomembrane rehabilitation. You can see the water exiting the gallery. The downstream side was completely leakage and it was not measured. Even the gallery leakage could not be measured because the water was almost flowing close to 2 feet high and there was no instrumentation to measure the leakage. And in 2005 itself, it was declared as a distress dam, but for several reasons, it could not be taken up on a large-scale repair works. The client did a lot of repair activities, which included pointing, gunneting, shotcreting, all attempts that was available in 1990s and 2000s, but unfortunately, none could give them a permanent solution. In 2019, before we took up the job, we measured, it was around 8,200 liters per minute at 9 meter below the FRL level. And from the data that was provided by the client, we estimated the leakage should be around 15,000 liters per minute when the dam is at FRL level. And after this, in 2019, Karpi was awarded the work. The scope involved a lot of preparatory works. One is earth excavation, repointing works, drilling and grouting, coffer dam construction, dewatering, and geomembrane installation, and optical fiber monitoring system. The first most important element is, in geomembrane system, we need to install the geomembrane from the top of the dam till the toe end of the dam. In Upper Bhavani Dam, almost 15 to 16 meters of excavation had to be done on both the flanks. Only then I could reach the toe of the masonry dam. So here you can see some images. In some places we had to use multiple machineries to ensure that the excavated material is properly removed. And then after the membranes are laid, it is again packed. And then here the dam could not be lowered below the sill level of the sluice gate. And there are at least 12 meters that has to be dewatered, for which a huge coffer dam had to be constructed. A coffer dam of close to 25 meter, 24 meter had to be constructed, and the water had to be pumped out. So we had to use high power pumps to ensure the water is discharged. And coming to the surface preparation, there are a lot of loose mortars. This dam, the last year when it was dewatered was almost 25 years ago. And the condition of the masonry joint was not known to anybody. So when we dewatered it, we found the mortar was in very poor condition, and just with hand can scratch it, the entire stone was coming out. Such was the condition of the dam. So it was required to do a lot of pointing works had to be carried out before we do the geomembrane works. And coming to the fixation element, the first element is, we call it as a vertical tensioning profile. It's a two-component system. It is having a lower profile and then the upper profile. First, the lower profile is fixed. We design the anchors in such a way that based on several factors that includes wind velocity, water head, and we design for 5.7 meters center to center. First, a lower profile is fixed on the upstream face of the dam from the top till the bottom. And in between these two tensioning profiles, we install the anti-puncture geotextile. A 2000 GSM thick geotextile material was installed. This is mainly because this was a stone masonry dam, there was a lot of protrusions. So to ensure that the membrane is not damaged, we have to give a cushion layer. Then the geocomposite is unrolled from the top. You can see on the image on the left, the technicians are unrolling the geocomposite. It comes in the form of a 2-meter roll, and the length of the roll is according to the design of that particular stretch. If suppose in a dam has 80 meter, that roll is manufactured exclusively for the 80 meter. So the roll on the image you can see on the right, the roll is going down till the toe end of the dam. Okay, sir. And multiple rolls of geocomposites are rolled one after the other, and there is an hot air welding between these two geocomposites. And once these geocomposites are unrolled, there is an upper profile, which is a second component, which is used to tighten the geomembrane, and a proper torque is provided to ensure there are no wrinkles formed. And we don't leave any stainless steel exposed. You can see the upper profile is also covered with geomembrane. So from the outside, it just looks like a uniform geomembrane with some protrusions. And we also install a very important element, which is an optical fiber system. Behind the membrane, we install optical fiber all along the periphery of the dam in multiple circuits. This is mainly to ensure, to identify what is the leakage behind the membrane, and it is easy to identify and go repair in future. And finally, the fixation of the bottom perimeter seal. This is the key element which is going to terminate your geocomposites at the peripheries. It is a stainless steel material of 304 grade, and we have resins and a lot of gasket that goes behind it to make sure that it is watertight. And this is the drainage element. You can see water conveyed behind the membrane is conveyed into the gallery through these drain pipes. And we have very stringent quality controls, and you can see the image on the right is the client. The client is made to enter into the platform and he does the quality check. And this is the result after the installation of geomembrane. You can see the image on the left. You can see the gallery. I have a small few seconds of, this is how the gallery was leaking. And you can see how it is now. This is the leakage now. You can see the visible difference. So a graphical representation to show how the leakage has behaved before geomembrane. From almost 9,000 liters, it has come down to 55. And now in the last few weeks, it has reached the FRL level, and it is around 77 liters per minute from 15,000 liters per minute. So this is the, I'll just show you, this is another example of the drip project in Servala Dam. Here, the problem was more on the left flank and the spillway section, and even the problem was addressed here. The leakage from around 5,000 liters per minute has brought down to less than 30 liters per minute. And this is how the dam looked like. And after installation, you can see it's completely dry. And this dam has already faced 5 floods, and there is no problem with the installation. And this, I think most of you would be aware of it. This is the first dam. And it was almost now. You can see this is how the dam looks like with 36,000 liters per minute before rehabilitation, and after rehabilitation it is less than 100 liters per minute. So this is the image of the Kadambare Dam, which is 17 years after the installation, and still the leakage is around 100. To conclude on, in all the 3 cases, you can see this is how the results have been. Almost 99% water leakage has been stopped. And the durability of the system is well addressed by the first example of Kadambare Dam, which is 17 years, and still the leakage is around 100 liters, which is almost 99%. And the durability is continuing, and we are confident it is going to continue for another 2 decades as well. So finally, we don't sell any products, we only sell solutions. This is what we'd like to conclude. Thank you.
Thank you for very informative presentation. This is one of the method of waterproofing, and choice has to be made considering various factors. Any questions to Mr. Jagdishan on this issue?
SD Bharti, I'm from academics. I have a couple of questions. One is what I understand from your presentation is that the entire storage has to be diverted by constructing a coffer dam. Is that correct?
No, not the entire one. The water level below the sluice gate, because up to the sill level of the sluice gate, water can be discharged through the gates. Below that, only it needs a coffer dam to divert that water.
That means you are able to do the membrane fixing under dry conditions, only not underwater.
No, we can do underwater. We had a session in the morning, because this is a system which has been successfully done in underwater.
Another thing is that what is under the fluctuating conditions of temperature, salinity in water, what is the typical life that you give?
Talking about the life?
Yeah.
We have first reference project which was done 46 years ago. So, and it has been recently visited, and it's still performing to the full satisfaction of the owner. So we give a warranty of 10 years and a life of minimum 60 years in dry condition. 60. And in underwater it is 100.
Okay, 60 under dry condition.
60 in dry condition.
Why would you have a membrane when your conditions are dry?
No. In dry condition, in the sense, if the membrane is going to be exposed to the sun, we give a life of that system that I have installed for 60 years. Because we have done accelerated aging test, which is survived beyond 60 years, up to 60 years.
Okay. One last question.
Yeah.
I understand that you recommend that this is the best technology available, and what percentage of your components are imported and how much of it is indigenous?
Sir, when we started the job in India in 2003, it was 100% except for the local assistance. And now we are almost at 90% is localized, and only 10% of the material and the installation is from abroad. So which means in my costing, 90% is going to be Indian cost, 10% is going to be European component.
Okay. And which one you consider, to stop or prevent or minimize the leakage through the body of the dam, which one you consider is a comparable or competing technology vis-a-vis the geomembrane? Or you don't find anyone competing?
When you talk about the durability that we give,
all considerations together.
No, I will not find a alternate material that can give us a durability that we give.
Somewhat close?
I'm not sure, but I've not seen a material or a composition that gives the similar durability.
Admittedly, you are saying it's a kind of monopoly item.
No, it's not monopoly. It's been abroad. Many companies are doing this. In India, Carpi is doing it. There are many foreign companies who are doing it, but they still have not come to India.
What I am saying is not Carpi's monopoly. What I am saying is that geomembrane is an application, is a technology to prevent leakage of water from the body of the dam.
Correct.
Is one method.
Yes, exactly.
What is another comparable method which serves the purpose? I mean, do you have any idea about that?
Naturally, this conventional methods like pointing is there, grouting is there, gunneting is there. These are all regular conventional methods. But when you compare vis-a-vis on the performance of these materials versus geomembrane, obviously, with my experience or with our experience of 60 years we are in the industry, we have seen that this has got the highest durability. People who have installed geomembrane has never come back to us for any more repair works.
Sir, एक आखिरी सवाल पूछ लूं और आप मुझे बताइए, how do you find that this is a fit candidate for geomembrane, or because obviously it's a very costly proposition, but nothing is costlier than water. So how do you, suppose some case comes to you, how do you figure out this is a fit case for geomembrane or not yet good enough for geomembrane? While doing cost analysis, you can go for other alternatives. Do you have some step-by-step procedure of going through that?
I'll tell you. You can ask us, we have done only 3 dams in India, which means
I'm asking you only. They won't reply.
No, I'm saying, we can see, you have seen in my presentation, there are only 3 dams that we have done in India, which means we are very, very judicious in selecting the project. It's not that whichever dam comes to us for inquiry. I'm
not alleging.
No, sir, I'm just trying to say. We don't go for geomembrane for anything. But the basis is, the first element that we do is, we take the history of the dam repairs that has been done. We try to understand what all the elements that has already been repaired, what all methods has been tried. If we find that all the conventional methods have been tried and the durability, because we need to have a lot of data.
Your company also does the conventional methods.
It's, if in the tender, it requires as a prerequisite to do. Suppose in this case, we do it.
उसकी बात नहीं कर रहे. I mean, you just say geomembrane or you say not good for geomembrane, go for these. We also provide those solutions.
No. Other than geomembrane, we don't do anything as a waterproofing element. If it's annexed to the geomembrane, yes, because of the tender demands that this is a prerequisite, so we have to take it as a single tender.
Thank you very much.
Thank you, sir.
Actually, this geomembrane is an effective technique for preventing leakage. But leakage is a result of many factors. If it is only through joints, then it will be effective. If there is, yes, sir, I will come back to you. Yeah, if the body has become porous, if there is other things, there are other solutions as well. So we can go. Just very quickly, yes, sir, you can have a question.
Excuse me. Hello, sir.
Yeah, please.
This is Sivakumar Reddy, Superintendent Engineer, WRD AP. How about cost-wise comparison with reference to conventional methods? Because there is one dam in Anantapur district, Pennavulam Balancing Reservoir. We got a quotation, dam cost was about 10 crores. Now your solution, I think it is around 50 crores for providing geomembrane on the upstream face of it. So comparing with the cost of the project, the remedy is 5 folds more than the cost. How do you justify the economy of the...
Sir, if you talk about any repair activity that we do or any repair activity that's been done, we have to talk about the overall life cycle costing for the entire repair activities for the entire duration. Say, for example, we give a life of 50 years. So, over a period of 5 years, we have to extrapolate and see the cost that is going to be incurred for geomembrane. Once I do the job now in 2022, till 2072, I can assure you that the leakage is going to be intact. But in the period of this 50 years, if you see the conventional methods, how frequently we have to do, we can break even less than 10 years. Within 10 years, your cost of the conventional and the geomembrane is going to be the same. Because my membrane does not require any maintenance. It's zero maintenance material, so which means up to 50 years it's going to be the same. Whereas conventional methods, there is some period beyond which you have to keep repeating the same activities. So that way, if you see, it has got a high durability and life.
So suppose in the first instance, some conventional methods have been carried out and still we find that some leakage is still there. is it again, say, a justiciable case for going for the geomembrane?
Yes, if you have exhausted the options of any conventional methods and you feel still it does not reach the efficiency of what we are expecting it, then it is ideally suitable to go for geomembrane.
Suppose if you compare with natural dam or concrete dam, say, is it better even in the case of concrete dam also to go with?
Yes, we have done it in concrete dams, we have done it in stone masonry dams, all types of dams we have done.
Information is available outside also. You can continue this discussion there on also. Mr. Lima, please carry on.
Thank you very much for giving me the floor. No, I just want to speak about the French experience, because we have a lot of masonry dam in France, and we tried many solutions. And from maybe 20 years, generally the selected solution is geomembrane. And not only Carpi geomembrane, as I mentioned. There are other ways, and some of them are designed directly by the designer, so it's not completely blocked on Carpi. And really, we had a very good experience and very good return of experience on geomembrane on masonry dams. I just want to mention, because I know you have a lot also. Thank you.
Yeah, this decision is to be taken very carefully, and we have to examine on case-by-case basis, and it has to be done in detail after detailed deliberations, whether the conventional methods have failed or whether the leakage is extensive. So it's not a general recommendation, but it is based on case-to-case study. We will take a decision. Thank you, Mr. Jagdish.
Thank you.
And if anyone in the audience has a question, you can contact later on also, till the evening.
Our last presentation is reintegration of the spillway shutters of Krishnagiri Dam, Tamil Nadu, India, to be presented by Dr. R. Rani.
Okay. Thanks, sir. Good afternoon to everybody. I am Dr. Rani, Joint Chief Engineer, working in the TNWRD. I am going to discuss about the reintegration of spillway shutters. Due to the failure of the spillway shutters, we have reintegrated it, and what is the lessons learned from this case. That is the thing I am going to discuss. First one, we are discussing for the past 3 days, the dams are most important structures, and the dams are considered as a life-saver structures. So the failure of the dam and its appurtenance would lead to the catastrophic collateral damage, not only to the public but also to the entire economy. So we are here, I am going to discuss about the failure and reintegration of the spillway shutter in the Krishnagiri Dam. Next, the Krishnagiri Dam is constructed across the river Pennayar in Krishnagiri district in the period of 1955 to 57. It is the masonry cum earthen dam with 8 numbers of vertical spillway shutters and 3 numbers of the lift gates in the river. The catchment area is about 5,366 square kilometer, and the total height is about 9,012 acres. The dam is nearby Bangalore in Karnataka. It can be easily accessed from the Jolarpet. Okay. The main hydraulic particulars are the full reservoir level is about 483.11 meter, and the maximum water level is also about 484.63 meter. So top of the bund level is about 487.38 meters, so somewhat higher than the full reservoir level. So the free body is available. Then the earthen dam is about, top of the bund is about 487.38 meter. The length of bund is 713 meters. It has spillway gates are 8 numbers, and which are size is about 40 by 20. Then maximum flood discharging capacity is about 1,45,738 cusecs. Maximum flood discharging capacity at MWL is about 3,968 cusecs. First, we have done the rehabilitation work under the drip pond itself, just smaller works like just reconstruction of parapet walls and then the flood protection wall, etc. And repairs to the rock toe drain, approach road, staff quarters and facilities, providing some small basic facilities like road works, all these things were being carried out under drip pond. And pointing of masonry dams and drainage holes, all these things have been carried out. In the hydromechanical work, we have done the repairs to spillway shutters and reverse sluice shutters, emergency shutters and gantry crane arrangements. We have not carried out the work completely replacement of the shutters, just we have done the replacement of the portion of the shutter where it is corroded, where it was corroded. And the work has been completed during the year 2017 itself. But in the same year, during September 2017, due to the heavy rainfall in the upper catchment area of the river Pannayar, that is about the Krishnagiri Dam remains at that time the Krishnagiri Dam remains in FRL condition. For the past 1.5 months in the last 10 years experience. So in the downstream dams also full of water is at FRL conditions. But the dam officials started to release the water, but they can release the water to a certain extent only because already the lower down dams are full of FRL conditions. At the same time, to worsen the situation, the Krishnagiri Dam catchment also received heavy rain due to the Ogi storm that everybody knows. In the afternoon of the 29th November 2017, the spillway shutter number 1 got buckled. So the field engineers heard the loud bang and noticed the leakage in the spillway shutter 1 with damages occurring on the lower left bottom edge of the shutters. Due to this hydrostatic pressure, the gate number 1 shutter heaved towards the downstream side and lifted approximately 1 meter from the sill beam. So fortunately, we have conducted the stakeholders meeting in the month of August 2017. So it will be very helpful for us to invoke the EAP procedure and to reduce the damages occurred. Similarly, we have the field engineers done the temporary stop block gate arrangements and take necessary steps to store the water up to 3.6 meter above the crust as a temporary measure. As the spillway gates are about more than 60 years, the state government decided to replace the damaged shutters and the gate was replaced successfully and the structural integrity of the dam also restored. This is the situation what we have faced. Now the analysis what we have taken is can be explained. This is the picture showing how the gate heaved, gate number 1 of the spillway shutter. This is the view of the picture that replaced spillway gate number 1 of this Krishnagiri Dam. Exploration of this catastrophic event. First, we have after this event occurred, we are think of the following works has been carried out. The following test. The first one is water quality test. That is carried out by the King Institute and then CSIR, Sekri Karakudi, and then soil mechanics, that is SM&R division, which is functioning under our department. Then the structural adequacy, we have already replaced the shutter, number 1 shutter, which is heaved. So the structural adequacy of the newly erected shutter and the hoisting capacity of the shutter has been carried out by the IIT Madras. Then King Institute also carried out the water is water quality. After the water quality test, they showed, their results shows that the reservoir water is white and hazy in physical appearance. Really, if you go and see, the water will be bad smell will come. The water is slightly hard and it is satisfactory but it says that it is satisfactorily chemical quality for drinking and other domestic purposes. However, the bacteriological quality is not satisfactorily. And if you see through the microscopic examination reveals that numerous zoo and algal forms The long layer saturation index indicates that the water is corrosive in nature. This is the findings of the King's Institute. Then the central CSIR report shows that the preliminary steel analysis including corrosion rates are all analyzed and reported that corrosion rate and shutter rate near the replaced shutter, that is the end of the shutter, for number 1 shutter is nearly 2.5 times more than the shutter in the middle of the reservoir. So bacterial growth also observed there. Hence they are recommended to identify the appropriate steel coating. Then the SM division, which is under our DNWRD, they told that the pH value of the Krishnagiri Dam is about 8.5 and high alkaline in nature. It is about 250 milligram per liter, resulting in the scale forming water. The high chlorides and sulfates will increase the rate of corrosion. These are the findings of our tests carried out by various departments and various institutes. This is the picture showing the corroded portion of the gate number 1, which was failed. We can see the zooplankton and everything there. Then after finding the results, the discussions were carried out by IIT and CPMU and TNWRD. They concluded the following. Then the project needs to initiate immediate interim action for an urgent replacement of the failed gate on top priority. Then replacement of balance 7 gates in consultation with IIT Madras. Then the provisional proposal for providing nickel and chrome metallizing as proposed by the IIT Madras, and it is to be done at top priority. Immediately, after getting the findings, immediately the damaged shutter gate number 1 was replaced by the newly fabricated shutter with guidance of IIT Madras designs, by using the IIT Madras designs. Then the structural adequacy of the gate number 1 was, after installation, the adequacy of the gate number 1 was ascertained by the IIT Madras, that is structural department. Then they have suggested for zinc and aluminum alloy metal coating, followed by the polyurethane. Then scientists of IGCAR, Kalpakam, they identify the key findings of the microbiological corrosion. So they have asked to go for the Krishnagiri Dam spillway setters on analysis of dam water. They have tested the analysis of dam water. After that, and the biofilms and corrosion products, everything they have analyzed, and they have given suggestions for the various paintings. Then the higher density microbes in the reservoir appears to have accelerated the corrosion. That may be the reason for the corrosion of these shutters. And considering the alarming thickness of the reduction in thickness has been identified, this is because of the microbiologically influenced corrosion. It is suggested to replace all the existing shutters with the new ones having suitable anti-fouling coatings. Then the result discussions. The already installed shutters and their hoisting arrangements has been checked. Integrity of that arrangements has been checked by our IIT Madras. They have informed that this arrangement is good and it can be worked for further period of 20 years. Finally, the team of CWC, comprising of experts, visited the dam and provided suitable recommendation for replacement of the 7 shutters. Based on the above recommendations, we got a government sanction and we have replaced all the 7 shutters, and we have robust ensuring the structural integrity of the Krishnagiri Dam. So, under the DRIP programs, we have replaced, that is shutter gates 2 to 8 started. We started to replace that gates from November 2019 and we end by August 2020. But we have faced a number of difficulties in installation of these shutters. During the period, the water level has to be kept 2 feet below the crest level throughout the replacement duration. It was really challenging to keep the water throughout at that level without affecting the downstream side stakeholders' essential requirements. Moreover, the water quality is a nascent word, and the employees cannot work there, and they cannot stand for nearly at least more than 6 hours, they cannot stand. We also go and stand means we cannot stand at least for 10 minutes. It's so pungent water is coming now also. This is because of the dam which is in the upstream. All the pollutions from the city pollutions, city wastes are entering in the dam. So because of that, all these are coming, all these problems are arising. Then pungent odor and that odor suffocated the employees, and work cannot be resumed more than 6 hours at a stretch. So it took a long phase to replace the shutter, but it is not possible to keep the water level at the lower level without affecting the downstream side, the stakeholders, that is the farmers. Then the fabrication also done in a piecemeal, not suddenly they have not done. Because they have to piecemeally done, and each component has to be fabricated and transported to the dam very carefully, and installation also carried out very carefully, because another catastrophe may not to be happened. So the almost care was taken to weld the individual components over the dam structure, and so they have done very carefully. By the end of the June, the water level in the river began to deplete. At that time, we have to deplete, the monsoon will not happen, so every water will go down, water level will go down. At that time, the decayed fish and other marine life started to
Madam,
spread.
please conclude. Please try to conclude in 2 minutes.
What's
Please conclude in 2 minutes.
Okay, sir. The works found it very hard to stand, and the dam structures, even after provide respective PPE kits has been given to the workers, and they have worked on. Conclusion. After accounting all the challenges, the replacement of age-old shutters with a new one has been completed with the present design standards. As a DRIP project felicitates the dam safety, the detailed investigation and expertise suggestions are obtained nationwide. The reintegration of gates were done without altering the designed hoisting mechanism, and with structural competence of the dam, the long-lasting pioneer was achieved at sustainable dam safety. Thank you. Thank you.
Is there any question from the audience? If no, then we come to an end of this technical session number 8. And here we had 6 presentations. 2 presentations were regarding hydrology. So one was regarding the review of design hydrology and the RIP of Gandhi Sagar Dam. Another was on the study of sinuosity in Barak River. 2 were on the gate replacement, and 1 was on the geomembrane, which Karpi made a presentation, and the last one was on the Garada Dam rehabilitation works. So most of these works were done as a part of DRIP phase 1, and we have learned many lessons also, and we want to carry forward the good examples of DRIP phase 1, and DRIP phase 2 is on a much larger scale. In DRIP phase 1, we rehabilitated only 223 dams. Here the target is much larger. The fund also is much larger. We want to make use of the lessons learned, and we want to improve and continue with the dam rehabilitation of the important ones. And I think if there's no more question, then I conclude this session. I thank all the presenters who have made the presentation, and I thank the audience for sitting patiently. Thank you very much.
Okay, thank you so much, sir. The chairman, sir, Shri Vijay Saran, and also I would like to say thanks to our co-chairman, sir, Mr. Anil Jain, for conducting this session so nicely. Now we would proceed further, and now I request our chairman, sir, Shri Vijay Saran, to kindly present the memento to our participants. Mr. G. Prasad, Mr. Govardhan Prasad, Ms. Payal Goyal, Mr. Aditya Mishra, Mr. Govardhan Prasad, Mrs. Payal Goyal, Mr. R.K. Chaudhary, Mr. Aditya Mishra, Mr. Jagdishan Subramaniam, all right, thank you so much, sir. Now I request our co-chairman, sir, Mr. Anil Jain, to kindly proceed for the presenting the memento to our next participant. We have Dr. R. Rani. Also, we have some poster presentations, the presentators as well. And we have Dr. Manish K. Nema. Mr. Vishnu V.V., Research Scholar, IIT Roorkee. Mr. Madhukant Goyal. Mr. Akash Jaiswal. Mr. Pankaj Mani. Mr. Akash Jaiswal, Research Scholar, IIT Roorkee. Then we have Mr. Pankaj Mani, the scientist, NIH. Also we have Mr. Ankur Sharma, Deputy Manager, NHPC. One more, sir. Yeah, we have Mr. Ankur Sharma, Deputy Manager from NHPC. We have two poster presentators as well. We are going to give the memento in the next session. All right? Okay. Thank you so much, sir. Now we would proceed further for the next technical session. Thank you, sir. Now we have the next technical session, for which we have operation, maintenance and emergency management, for which I would like to call our chairman, sir, Professor S.T. Bharti, MNIT. I would like to call our chairman, sir, Professor S.T. Bharti, MNIT, on the dais, please. All right. May I now request our chairman, sir, to kindly do the honor and conduct the proceedings. The floor is hand over to you, sir. Thank you. I request everyone to kindly maintain their seats. We have a tea break after this session. So I request for now, please maintain your seats, everyone. Thank you.
Good afternoon, everyone. I welcome you all in the last session of this wonderful conference. We have 5 presentations scheduled for this last session, and there is one which could not have taken place in the previous session, that we'll have to take that also in this session. So first I invite the first presenter, repair and rehabilitation of spillway using steel liner case study by V. Rao, Musharraf, Ali Khan, Rajesh Kumar and Shankar Kumar. Who is going to present? Yeah, please do come, sir. And okay, your name, sir, introduce yourself first and then we can start. And as a matter of procedure, we are giving 8 minutes to each presenter, and that's 2 minutes of our question, answer and discussion. Okay? Please try to stick to the timeline.
Respected Chairman, sir, dam professionals, ladies and gentlemen, very good afternoon to all of you. Myself, Shankar Kumar, Senior Manager Civil, Design and Engineering Division, NSPC Limited. The topic of presentation is repair and rehabilitation of spillway glasses using a steel liner, case studies of Dhauli-Ganga and Tista Stage 5 Dam. Along with me, Rao, Musharraf, Ali Khan and Rajesh Kumar is the author of this paper. This is content of my presentation. This is divided in 8 parts. Introduction. The low-level orifice spillway are provided in the dam for sediment management and maintaining live storage of the reservoir. Damages are observed in spillway glasses due to large size sediment particles, boulder rolling, and stone. In this presentation, our focus is on restoration and protection of low-level orifice spillway of existing dam. Causes of damage. Abrasion damage is gradual wearing of top surface of the spillway glasses. This type of damages occurs in crest type spillway structure. Like this is photograph of Salal Dam. Cavitation damage results into pitting of the surface, and which gradually increase to such type of failure, such type of damages. The impact load is major contributor of dam damage. It is observed in the boulder. It is observed that boulder of size 2 to 2.5 meter are passing during reservoir flushing operation and during flood disposal. Water jet is also a contributor of damage. The impinging water from radial gates at the time of opening and during some leakage or crack, this type of concrete cutting is happening on spillway glasses top surface. Once abrasion, cavitation, impact damage, and water jet substantially alter the profile of spillway glasses, this type of flood, this is picture of Dhauli-Ganga spillway, this type of flood further accelerates the problem and the damage is accelerated. The third one is the damage categorization. Based on the water head on the spillway crest, annual sediment load, size, hardness of sediment particle, stone and boulder size, these are the major factors. And based on that, severity of erosion is characterized in 3 groups: mild, moderate and severe. In mild category, water head generally comes to 0 to 15 meter, annual sediment load is 0 to 30 mcm, no boulder rolling, only silt and sediment are passing. Standard concrete of M25, M35 is sufficient for repair material. In moderate category, water head over crest is 10 to 30 meter, annual sediment load is 0 to 30 mcm, HPC and cementitious mortar is considered as adequate for repair material. In third category, which we will discuss here, is severe category. In this case, water head over crest is 10 to 60 meter and annual sediment load is 1 to 40 mcm. Boulder rollings are very frequent along with silt sediment and gravels. In this case, part of the spillway, particularly the upper spillway, near radial gate area are protected by steel liner, lower glacis are protected by HPC, and spillway piers are protected with steel liner and cementitious mortar. This is a damage profile of Dholganga Dam spillway during a major flood in 2013. This is very extensive damage at this spillway. The setting of a spillway is like this. Dam type is CFRD, head over the crest is 38 meter, average annual sedimentation load is 3 MCM, boulder passing is there, design flood is 3210 meter cube per second. This comes in the severe category. The another one is Tista stage 5 dam. This also comes in the severe category as per the damage categorization. In this case also, head over the crest is 39 meter, annual average sediment load is 10 MCM, average velocity is very high, boulder rolling prevails there, and design flood is 9,500. These are the damage profile picture of Tista stage 5 dam. Most of the time, this initial portion is damage is started from the near radial gate, and this further proceed towards the downward side and lead to the progressive erosion. Over the period of time, it has been experienced that efficacy of high performance concrete and ready mix concrete are not satisfactory for this type of spillway. For the repair frequency is about 1 to 2 years only. To tackle this problem, 32 mm thick steel liner plate has been installed at spillway glacis on experimental basis in February 2017. The spillway area has been identified. This was the first step, so that the plate size of 3 meter and 6 meter was installed near radial gate and welded to the radial gate sill beam. And we wish to see that how it performing during flood. This is the observation and photographs reported by Dam Safety Inspection Committee in October 2018. Sir, I would like to share that in NSPC we do have pre and post monsoon dam safety inspection for each of our hydropower projects. It is reported by our committee that steel liner is performing well by comparing the damage profile in spillway number 1 and 2 after 2 monsoon season. As per site condition, steel liner has been installed by 3 methods: torque controlled countersunk anchor, that is called mechanical anchor, epoxy grouted anchor, that is chemical anchor, and by conventional method, where stiffness plate are provided behind that steel liner. Or fourth one is a combination of these 3. This is the case study of Dholganga Dam Spillway 1. These are the steps and procedure that has been followed for installation of steel liner at Dholganga Dam Spillway. Yes. These are the steps. These are the photographs taken during April 2022, and it is found that the performance is very much satisfactory. After that, the second case study is the Tista stage 5 dam. The steel liner on spillway number 1, 4, and 5 has been installed by combination of mechanical and chemical anchors similar to Dholganga project. And then spillway number 2 and 3, due to high damage near radial gate area, steel liner has been installed by conventional method. These are the methodology for conventional method. These are the picture of spillway number 1, 2, 3, 4, and 5 during December 2021. So now the conclusion and recommendation. These are our conclusion and recommendation based on performance of steel liner on spillway glacis of Dholganga and Tista stage 5. HPC and RMC has limitation as a wearing surface in the upper reaches of the orifice spillway. It has been evolved that provision of steel liner from radial gate sill beam to 10 to 15 meter area is very much effective. The progressive erosion also reduced because the initiation of damage is not, we check the initiation of damage, and that progressive damage is also reduced compared to the previous case. This is a cost-effective solution. Performance of steel liner is satisfactory and encouraging. It is recommended, then our recommendation is, it is recommended to provide a steel liner in the upper reaches of low-level spillways of existing dam as well as new dams being constructed. These are our references for this presentation. Thank you very much for kind attention.
Thank you, Mr. Shankar, for honoring the time to raise some pertinent questions. Yes. No questions from far end to near end? Is anybody, any volunteer there running with the PA system? Yes. Thank you, ma'am. Yeah, there is a question I can cite.
Sir, myself, Shiv Prasad from Nathpa Dam of SJVN Limited. I would like to know that how you have decided that the steel liners to be provided up to 10 to 15 meter downstream of radial gate.
Yeah.
After that, what type of concrete you have provided?
Yes, yes.
Up to the tip portion of the glacis portion.
Ji. Yeah, this is a very good question, in fact. Actually, we have started from the 3 by 6 meters starting from that.
No, you have to address him only.
And after that, we have provided for 15 meter in Dholi Ganga. And again, parallel activity is going on Tista 5, where we have provided 10 meter, up to 10 meter. And both are performing more or less same. So we evolved that up to 10 to 15 meter from radial gate is adequate. It is always good to provide whole part of the, but that is not economical. We have to, economy also has to be taken care of. At what part? So the downstream part we have protected with HPC. And upstream part, that near radial gate reaches, we have provided with steel liner. And R4 material also used for vertical face of that. Cementitious material R4 category is also used in spillway piers.
Is it okay? Does that address your query, sir? Okay. Any other question?
Yes, sir. Actually, in Nathpa Dam, we are facing the same problem, sir.
So for that, you can contact him in person.
That's right.
Okay. Okay. Any other question, or anybody who is facing the similar problem of low-level spillway giving some problems? No? Nobody? Yeah, one more, please.
Yes, sir. Good evening, sir. I am Nishith Agnihotri. I am from CSMRS New Delhi. For the new constructions, we are observing that for the overflow sections, they are providing steel rails instead of the liners.
Sir,
in few of the dams,
yes.
This is my observation.
Yeah.
So, how suitable it is with respect to the liners?
Yeah, very. We are also having this rail on Ranjit 4 project. But that is...
He wants you to give a comparison of two
methodologies. No, steel line is better than rail, I think. And then crest spillway is okay. But for orifice type of spillway, condition is totally different. For crest spillways, the major contributor of damage is rolling boulders and large size particle. In crest spillway, we don't have generally that type of situation. So in that case, even HPC is good. In Salal Dam, we are having HPC. That erosion is mild and it's not alarming. So,
and with respect to HPC, I had observed that few of the dam owners are nowadays using the stone pitching with the help of epoxies.
Yeah, stone pitching is basically give rough surface. Actually, we want a smooth surface on the spillway glacis. That's the main thing. Stone pitches, HPC is M60, M65, M80 grade HPC is as good as that stone. It's a very good one. But
they didn't find it suitable. After that, they implemented this stone pitching that I'm talking about.
No. You should take the answer of the presenter. You just cannot get into the dialogue mode. See, initially you raised the question because we have a time limitation. Initially,
2 questions.
Please, but for 2 questions, gentlemen, you go and sit with him and address those questions.
Sure, sir. Sure.
Okay. Thank you very much, Mr. Shankar. Now we have our next presenter. Rectification in the operational system of known functioning stop logs on an inclined track by Mr. Ghanshyam Patel, Satish Kamboj, Director, and Sanjay Kumar Sibbal. Who is the presenter, sir? Satish Kamboj Sahib is the presenter. From which organization you are, sir? You are from which organization?
CWC.
Central Water Commission. All right.
Respected Chairman.
Yeah,
dear
please honor the
audience.
time, Kamboj Saab. 8 minutes and 2 minutes for discussion.
Yeah, definitely I will try. Good afternoon to all of you. This is the last session, but I think this is the most important. Operation maintenance and emergency management is the most important part of the dam project. Today, myself, Satish Kamboj, Director CWC, I will be discussing about rectification in operation system of non-functioning of stop lock, which were installed on inclined track. This was the case of Sardar Sarovar project, in which the project authorities were struggling with the non-functioning of the stop lock because of some design fault maybe, and they were looking for various solutions, and at last we gave them some modification in the operating system, and the problem was solved. That was they were looking for since 14 years. This is the Sardar Sarovar Dam is located on the river Narmada. Narmada river is 1312 kilometers. It is starting originating from Amarkantak in Madhya Pradesh. Project is located in Gujarat. The Sardar Sarovar project is the largest in terms of concrete volume and the third largest concrete dam in India. Length of the dam is 1210 meters. There are two powerhouses. Main riverbed powerhouse is 1200 megawatt, and the another is canal powerhouse, 250 megawatt. There is a very large canal network for this project. This is a multi-purpose project, and it is located in Vadodara district and Ekta Nagar, and it's very good for the tourists also. Our foreign visitors can go there and visit. Riverbed powerhouse has 6 penstock service gates operated by hydraulic hoist. Stop locks are provided for the maintenance of these service gates at the bell mouth. These stop locks has 6 units. Size is 6.2 meter by 2.25 meter, and weight of each stop lock unit is 15 ton. And these are provided on the inclined track. Generally, we provide the gate and stop lock on the vertical, but in this particular case, these are provided on the inclined face of the dam. And these are being operated by 100-ton gantry crane, as you can see from the picture. So it's a general layout. Trouble in the operation of stop lock was reported in 2008. So the project authorities were looking for some solution. Testing. After the problem was started from the day of installation. They were not able to raise or lower the stop locks. They tried many times, but it was stuck up in between. The lower unit, bottommost unit was lowered, then they tried to raise the lifting beam without the stop lock, and it stuck up. Then somehow they were able to bring it back with the help of divers and all this. You can see the pictures of how the pulley system was damaged, rope was damaged, and guide shoe were also damaged. So what they tried to crack this guiding shoes also. But the problem exaggerated. Instead of solving the problem, it was increased. So they tried this again for testing in 2018. Maybe they did not try it in between. But as the service gates were getting older and older, they thought that maintenance is required at this point of time. So working of this stop lock is very important. Then the experts, private experts suggested them to provide single piece bulkhead in place of stop lock units. These, the size is 6.3 by 13.5 meter, and weight was estimated 19 ton each gate, and one gate for in each base. There were 6 bays. And individual rope drum hoist is to be was planned. and capacity was more than 100 ton. So they referred this case to CWC to scrutinize the design and drawings. Then we saw in detail and what is the advantage and disadvantage of installing this, how much cost is involved. So then we found out the system will be simplified because there will not be any lifting beam, engaging and disengaging problem, and time saving in operation also. So in that way it is good. But additional steel work was estimated 834 ton, huge steel if you see from the gate perspective. And dismantling and assembling new concrete, old concrete. So because hoist was to be planned on the cantilever. So providing the hoist structure on the cantilever, we have to provide the counterweight. So dismantling the old concrete and providing new concrete was a big challenge. Other challenges were also seen, the bonding of new and old concrete. There was space limitation also to accommodate the new concrete, because you can see in the picture, so here there is operation chamber for service gate. So we cannot accommodate dismantle concrete here and provide the counterweight. Another problem was these gates were to be stored below FRL. So maintenance and inspection of these gates were again challenging. So for maintenance or replacement of seal or etc., we have to remove the rope drum hoist first and then bring the gate out, and then it's a cumbersome work, although it is to be required in once in 10 years maybe, but it's a cumbersome. And limited capacity for the upstream wall. If you, again, if you want to provide this anchorage system, so this capacity may not be sufficient. Then we try to find the other solution which may be simple and easy to implement. So then we saw went into the further details, what is the problem, why these were stuck up. So we tried to modify the existing system so that what are the modifications. Then we found out that this is the lifting beam you can see. And lifting beam is used for the other people who may not be aware about this. Lifting beam is used to lower and lift the stop log units. This will engage with the stop log unit, and once the stop log unit rests at the required level, it will automatically disengage from the unit, and it will come back, and another next unit will be lowered again. So the bottom pulley block, which is the part of gantry crane, connected with this lifting beam, is combined CG was going above this top wheel. Yes, sir. I have only 2 3. So when this lifting beam was lowered with the stop log unit, the CG was well within the rollers, but when it was lowered alone, the CG of this combined system was above this, and it was getting tilted. Because of tilt, this pulley system was interfering with the lintel beam and the top sill seat. So this was the main reason we were able to point out. Then we try this. You can see from the picture also. Actual picture was taken. There is a gap in the bottom wheel here. We suggested 3 solutions. So you can provide the additional roller above the CG point, or you can alter the connection between the lifting beam and the bottom pulley block so that the CG is within the rollers, or you can redesign the whole system. So, last slide, sir. ठीक है सर, चाय का टाइम कम कर लेंगे सर थोड़ा सा. ठीक है, ठीक. So then we, सर इतनी देर में तो मैं खत्म भी कर देता. Sir, we provide this additional roller here, and this is the red color. This is the additional structure we provided, and this, by providing this roller above the CG point, the tilting was avoided, and there was no interference with the top lintel beam and the lifting pulley. So it worked very well. So you can see from this color, this is the lifting beam, pink color, and this is the bottom pulley block, blue color, and the red color is the additional structure. The weight was of additional structure was 2.7 ton total against the 837 ton that was proposed, and plus the additional concreting work that was also huge. So these are the pictures. You can see the modifications with the gantry crane, lifting beam. This video was taken at that time of lowering and raising testing. So conclusion, we can see, because sizing part of the component we are always worried about, but working minor details which sometimes forgot. That is the maybe the main reason due to which the working of the project or malfunctioning or non-working of the equipment is there. So if sometimes one equipment is designed by some designer, other part may be designed by the other designer. So interconnection, overlapping may be overlooked. So that we should careful about, so that its working is very good. So thank you very much.
Thank you. Thank you, Kambo Saab. Yeah. Questions from the audience? See, that is the difficulty when a presenter has, done some work so passionately. He doesn't want to, skip his story. He wants to, passionately engage with the audience. But I'm not seeing some intricate questions from amongst the audience. Anybody who is facing similar problems can raise one or two pertinent questions. No questions? Okay. What was the location, by the way, sir? For this repair work that you have carried out?
This is the Sardar Sarovar project, sir.
Sardar Sarovar project.
Yeah, power.
Yes, you mentioned in the beginning.
Yes.
Thank you very much. Thank you, Kambo Saab. Thank you very much. So we have the next presenter, dam break analysis, dam break fluid simulation sensitivity analysis by Mr. Anil Kumar Lohani, S.K. Jain and R.K. Jaiswal. And there is no mention about their organization, perhaps in the presentation itself it will come. Who is the presenter, sir?
Myself.
No, but myself must have name also.
I am telling you. I am A.K. Lohani. And you might be knowing me because we were in touch last 2 years back.
But let everyone should also know you, no?
So, because you said that we don't know, so I am Dr. A.K. Lohani.
I know you, but let everyone know.
Yeah. I am Dr. A.K. Lohani, scientist in National Institute of Hydrology. So I have mentioned here that we are from, all three authors are from the National Institute of Hydrology. So in this presentation, I will be talking about the dam break flood simulation. The sensitivity analysis is basically an important part for the dam break analysis. I will be talking about those things. So when we talk about the dam break simulation,
Quiet please, and for the audience.
There are a number of parameters which we have to see. We have to carry out the sensitivity analysis of those parameters. Like when we talk about the dam break analysis, first thing is that once the dam breaks, so what is the breach width, then the breach slope. These are some of the important parameters. Then the time of breach is very important thing. Then after that, once the flood basically routes in the channel, so the Manning's roughness coefficient is one of the important things. So I will be talking about all those things, how they play an important role during the dam break flood modeling. So here basically we have tried this sensitivity analysis for the two dam break studies. One is the Rangi Dam and the another in the lower Mannar Dam. So these are the two dams are there. I'll just talk about the dam break simulation. So first of all, once we carry out the dam break simulation studies, so here just if we are going for the 1D dam break simulation studies, so we have to just solve the two equations. One is the continuity equation and then second one is the momentum equations. So one is the mass conservation and another one is the momentum conservation. So these are the equations. So there are various methods for solving these equations, these continuity and momentum equation. Like if we are using the, these are the scientific equations, if we are using the HEC models or Mike models or NWS dam break models, so different simulation solution techniques are available over there. So once we have to solve these techniques, these equations, so for that basically the basic input in the model is the various hydraulic variables we have to give in the model. Then another important thing is the channel. the whole channel we have to just incorporate in the model. So the cross section is a very, very important part of the modeling system. So normally what happens in most of the modeling, we don't have the appropriate cross sections, and we have to go for the survey to survey out these cross sections. Then another important thing, once the dam breaks takes place, the water basically spills from the river itself to the floodplain areas. So we have to have proper topography of those floodplain areas also. So these are some of the input we do require for the modeling purpose. And then discretization of the whole channels we require those things. As I mentioned, that the cross section we need those things. So now once we solve these equations, so there are two important things. We have to see what is the space and time. These are the two things we have to take care once modeling or stabilizing the models. So these things we have to take. These are some of the independent variables, and the dependent variables are the discharge and the water level. These are the two dependent variables, and the independent variables are the x and t. Now, as I mentioned, that there are various solution techniques are available. So we solve these equations. I am not going in detail about those solution techniques. Now here, once we carried out these studies, flood simulation studies, dam break flood simulation studies. So this is for the Rangit Dam we have carried out. So this is the, you can just see here the discharge and the change. At just near to the dam site, there is very huge discharge. Then the flood wave attenuates to the downstream side. So how the attenuation takes place, this I have shown in this figure. Then again, you can see the highest water level from the dam side to the downstream side. That again comes down. Now, again, this is the highest water level due to dam break flood at the different sections I have showed here. Again, if you see the variation of the discharge for the different n values. Now, as I mentioned, that the Manning's roughness is a very important thing. And getting the correct values for the Manning roughness is a challenging task in the river, from the river. Okay. Now, here just we have tried to see what is the effect of the Manning's N on the discharge values in the river. So in this figure, if you can just see, in the uppermost portion, the variation is very high. And the downstream side, it just comes down. Because in the Rangit Dam, this slope is very high. So that effect is not, you cannot see much effect specifically, but there is effect is there. Then that means the rate of change in the discharge is high in the upper side, means the near to the dam side, and then the rate of discharge is just decreasing in the downstream side. So this is the one effect. So basically, if your site is much away from the dam site, or a city or a industrial area is far away from the dam site, so the Manning's N effect is not much over there. So, but if your area where your area of interest is much closer to the flood dam site, you have to take care of, about the N values. You have to just see, you have to have a more accurate N values over there. So similarly, you can see the effect of the different breach width. So in the case of the breach width also, if we increase the breach width, obviously the flood is going to increase, means the discharge is going to be increased. But here also you can just see on the downstream side, the effect of the breach width is minimizing, means the rate of change is again very high in the upstream side, and it just goes down in the downstream side. So these are some of the important parts we have to see. Then the variation of the water level at different breach width. So if the breach width is changing, the same thing we can see in the upstream side. It's very effective on the upstream side, then the less effect on the downstream side. Similarly, we have carried out the study for the lower Mane Dam. Here, the topography is different. One is the upstream, the Rangit Dam was the uphill areas where the slope was very steep. Here in this case, lower Mane Dam, the channel slope was not that much. So in this case, you can just see the attenuation of the flood waves. So this is the attenuation from the dam side to the downstream side. This is the attenuation of flood hydrograph. Then you can see the maximum stage downstream of the dam and time of occurrence. I've just shown you for the dam. Then maximum stage and maximum flow attained by the dam break flood flows. So how much is the maximum stage and the maximum flow attained by the dam break flood flow at different changes we have shown. So now again here you can see that the effect of the breach width on the maximum flow. So the effect of the breach width is very high, just close to the dam side here. But if you go away from the dam side, the effect is not very much, means the that dy by dx, or you can say that dq by dh is less, or the slope is less of the graph. Then here again, you can just see the effect of the time of breach. Time of breach plays very important role. If the time of breach is less, that means the very high flood you are getting over there. But the time of breach, once you increase, that means the flow you are reducing. That means, again, just at the dam site or the near to the dam site, if the time of breach is very less, you will be getting a very high flood over there. Okay, if the time of breach is less, so these are some of the parameters. Normally, once we carry out the dam break flood analysis, we have to assume these parameters because we don't have the exact values once we are preparing the EAP emergency action plan. So these are the very, very sensitive parameters. We have to take care of all those things. Again, the effect of the Manning sand coefficient on the maximum discharge, because I mentioned that in these areas where the slope is not too high or the slope is not too steep in the river. So in these cases, you can just see in the downstream side or in the upstream side there is a much more effect, but the downstream side, the variation is not that much over there. So if I conclude over here that these parameters, whatever the parameter we do require for the dam break analysis, we have to take care of over those things. And if our project site or our site of interest is very close to the dam site, we have to take care about all these parameters very carefully. And if the site is far away, these parameters like the Manning sand coefficient and other coefficient does not have much effect on the project site if the site is far, far away from those sites. But we have to see all those things. And another part, if we are having a coupled model like the 1D and 2D. So in 1D and 2D coupled model we are using, then in those cases the Manning sand coefficient plays a very, very important role for the floodplain areas. So these are some of the findings we have got. Thank you very much.
Thank you. Thank you, Lohani Saab, for honoring the time. And he just finished well in time. So we have some 1.5 minutes for questions from the audience. If any one of them are actually awake, till the time actually flood flows in. See, dam break analysis is an important aspect of dam safety assessment, particularly when you want to do the so-called consequence-based risk management or disaster management and all those things. Anyone who is working on dam break analysis, either in the academia, research institution or practice? None? Yeah. I have a small, kind of query. Did you write your own computer code or you use some platform to simulate?
We have used the established software, which are very well used softwares like the HEC model we have used the Mike model and the NWS model. So we have not.
Those are the standard simulation platforms. Did you mention any of them there?
Yeah, I mentioned.
You mentioned that? Yeah. Okay, I'll go through. Thank you very much. Thank you, Lohani Saab. Thank you very much.
Yeah.
Yeah, please, please. Somebody has woken up.
Sir, I find that most of the analysis are being carried out by the standard softwares. I think why not we are developing from the basic equations, hydrological equations, and we are developing our own codes, and we are then thereafter why not we are applying the data, those basic codes?
Yes, sir. It's a good question. Actually, you just see for the dam break flood analysis, we have to solve the sand variance equations. So these are the two equations. Okay. If we already have the solution, so we have to write the more or less similar kinds of code over there to solve these sand variance equations. Okay. So one can write its own code.
Not only the equations and other factors are also there inside any software. We have not. I have not written. We have not written. So we do not know what actually is, how it is playing.
Sir, can you identify yourself? Can you identify yourself? I mean, which organization you are from?
Sir, myself Dipankar Chaudhary from DBC Chief Engineer Dam Safety.
Yeah, sir, ये perennial सवाल है. I mean, it's a perennial question. Whether you use a standard, tested, verified, validated software platform, or you write your own computer program.
Because I am.
No, I am not taking side. I am saying both has got plus and minus. For keeping that politically divided line, that let's not, kind of embarrass the presenter.
Sir, just 1 minute, I'll tell you. Under National Hydrology Project, National Institute of Hydrology and IIT Roorkee has jointly developed a model for the rainfall runoff modeling. Okay, but our normal practice is that our academics and other
लोहानी
places
साहब,
we use.
ये टी ब्रेक के लिए रखिए, ये डिस्कशन मैं आज से नहीं 25 साल से सुनते आ रहा हूँ कि कोड लिखें कि सॉफ्टवेयर यूज करें. हाँ, ये अच्छा डिस्कशन है टी टाइम के लिए, लेकिन इसको अभी सेशन एक्सटेंड नहीं कर सकते हम.
Right. Okay. We'll discuss this.
ठीक है.
Thank you.
Thank you very much, लोहानी साहब. Thank you very much. Thank you, sir. We have our next presenter, Kodam Hydropower Station Flip Bucket Issue and Remedial Measures by Rakesh Rathi, Jagat Singh Yadav, Surender Garg, and Sanji Bharti. See, there is a dual difficulty. There is a dim light here, and the size is also less. I mean, the font size, so that's why I'm struggling to read that.
Thank you, sir.
Yeah. Sir, who is presenter?
Sir, my name is Rakesh Rathi.
Rathi साहब.
Deputy General Manager from NTPC.
नहीं, डेजिग्नेशन की जरूरत नहीं है.
Yes, sir.
बस नाम बता दीजिए.
Okay, sir.
राठी साहब, संजय, राकेश राठी साहब.
Yes, sir.
Thank you, sir. Sir, you will honor the time, 8 minutes, and then some interesting, good discussion for 2 minutes.
Sure, sir.
Okay? Thank you very much. Can I start?
Good afternoon, Chairman, sir. Good afternoon, ladies and gentlemen. We are from NTPC, and we are having our coal dam hydro power station at Bilaspur, Himachal Pradesh. That is a... So, we have, in my presentation, this is the content overview, issue. We are dealing with monitoring, investigations, remedial measure, design criteria, implementation of remedial measures, then monitoring the behavior and the conclusion. Coal Dam Hydro Power Station is an earth and rockfill dam 167 meter high with 6 radial gates and a spillway length of 460 meters. The station was commissioned in July 2015, and since then, spillage of water during monsoon season is a regular activity. At the end of the spillway, we have the flip bucket for energy dissipation. The presentation deals with that. So during the 2016 monsoon, a widening of the dilation joint between the spillway and flip bucket was observed. There is a dilation joint between the spillway and the flip bucket. After the monsoon of 2016, there was a widening which was under allowable limits. But in the monsoon of 2019, the widening crosses the allowable limit. And it was analyzed that there is a movement in the flip bucket on all axes, that is X, Y, Z, in all directions. You can see the joint, the dilation joint. So we have measured the continuous measure, the winding of the joint, firstly by manual Vinchan, and then with the help of real-time monitoring online Vinchan. You can see in the picture, there are online 2 numbers, Vinchan, online, real-time. So we have plotted the graph of the widening of the joint. You can see near, there is a sharp increase in the graph, which led to the widening. We have to take care of this widening. So investigations were carried out by GPR. GPR was done from the National Institute of Rock Mechanics for the entire area by 10 by 10 meter grid. The boreholes were also taken, including the WPT, and the cores were taken triple tube barrel method using. So the cores were sent for the testing for the parameters of the rock. Also 2D slope stability analysis of the central slope was done in-house. The remedial measures was suggested were the cable anchors which to be installed from the front face of the flip bucket going into the rock beneath the spillway. But there is a catch. we cannot go directly. There are the factors which are governing our design and the length of the cable anchors. The first one was the geology. As the rock was not competent in the range of 30 to 40 meters, we have gone for 60-meter deep anchors. The end anchorage of the cable anchors were given in black carbonaceous slate, which was on the upstream side of the basic dike. So because of the poor condition of the rock, poor geology, we have to go deeper up to 60 meters. The spillway discharge was taken as a 3,000 cubic, which correspond to the 2,700 ton, the horizontal component of that dynamic force. And there was a site constraint also, as there is a limited front face of the flip bucket from which we can drill the rock anchors. And so we have the limited area. The number of anchors are also a constraint. So based on the design criteria, site constraint, and geological investigation, 60-meter long, 150 mm dia, 100-ton guaranteed ultimate tensile strength, 70 number single corrosion protection anchors were installed with a spacing of 2.14 meters staggered. These cable anchors were installed by making a steel platform. Because of the plunge pool, cladding was a slope of 1:1.23. So for this, we have used 2-number Casa Grande drilling machine, which are able to drill through the massive 4-layer 36 mm dia reinforced concrete of the flip bucket. So the rock anchors were tested. The test anchors were tested for double, subjected to double cycle of the load, but all the test anchors were tested for single layer, and the lock-off load was 60% first and then reduced to 30% for the maximum anchors. All cable anchors were tested. Now we have to monitor the load, the cable anchors, and to know the efficacy of the cable anchors, and also to monitor the behavior of flip bucket. We have also installed 4-number load cells to monitor the behavior. The digital unit was installed, giving us the real-time data even during the spillway of operation. The graphs were plotted, and you can see from the graphs, even during the spillway operation, the cable anchors has done their job well, and there is no further movement in the flip bucket. From this, we conclude that there is an appreciable restriction in the flip bucket movement after the installation of cable anchors, even during monsoon operation in July and August 2022. So this case study, our purpose of representation, this case study is to know the industry that if they are having analogous problem right now or may face during future, so it will be helpful for them. Thank you, sir.
Questions? No question? Nobody is having any flip bucket issues. All the buckets are straight. So we can't help it, because I don't understand this matter, so I can't raise a question.
Thank you, sir. Thank you.
So you'll have to go like this, and you'll have to catch hold of somebody during the tea break so that somebody asks some relevant question.
Sure, sir.
Sure.
Thank you.
Shall we close without questions? Thank you. Thank you very much. So we have another presentation which is actually a spillover from the previous session. I am calling Rehabilitation of Konar Dam under case study. Rehabilitation of Konar Dam, a case study by Shri Dipankar Chaudhary and Saroj Kumar Shah. This is last but one, okay? So that you can understand that we are almost at the end.
Respected
May I
sir.
know who is the presenter, sir?
Saroj Kumar sir.
Saroj Kumar.
sir from DVC.
Yeah, yeah. All right.
Respected Chairman sir.
And your co-author is also in the audience.
Yes sir.
You can remember. Chali, shuru kariye.
My topic is rehabilitation of Konar Dam under drip a case study. Problems, rehabilitation under drip, conclusion. Major problem, partial functioning of the existing hydromechanical equipment, cracks in the dam body in galleries, leakage through penstock, reprep, dislocation at upstream phase.
Konar Dam.
Konar Dam was built up in the year 1955. After the construction, just after construction, 7 to 8 years, cracks in the inspection gallery are reported first in 1962 and 63. Cracks are dominant in inspection gallery with respect to operating and drainage gallery. Mostly horizontal and continuous cracks. At downstream phase, cracks widths are more in number and wider in. Cracks are more profound in central blocks of the dam, mainly in 13 and 14 number of blocks. Depth of the cracks are considerable amount, 0.9 meter to 3.8 meter. After 1962 and 63, the first investigation was carried out by DBC in 1968, and suggested remedial measure was also applied. And after that, so many investigation was carried out, and suggested remedial measure are also applied, but not fruitful result was achieved. After that, in 2009, it was observed that the cracks in the inspection gallery was stabilized. Some photographs, the cracks. Outer dam body of the abutment, cracks.
Photographs का कुछ referencing नहीं है तो पता लगाना मुश्किल है किस direction से लिए गए हैं. Unless somebody lives in the gallery.
Downstream face of the inspection gallery.
ठीक है.
Downstream face of the inspection gallery.
Yeah, now it makes sense.
Drainage gallery. In 2014, DVC participated in DRIP Phase 1 project, and major rehabilitation works was carried out in DRIP Phase 1 project, like repairing of racks, restoring of hydromechanical equipment like crest and under-sluice gates, stop logs, gantry crane, crest gate, inspection walkway, partial upstream reprep and downstream slope protection work, automatic gate operation, procurement of diesel generator set. It is taken in DRIP Phase 1 project with the involvement of rupees 20 crore, and which was completed in the year 2020. Balance work like dam instrumentation mainly, and remaining upstream reprep and downstream slope protection work will be considered in the DRIP Phase 2 and Phase 3 project with estimated cost of 24 crore approx. Methodology of repairing of cracks. A step-by-step procedure was repairing of cracks was carried out with concrete and penetron admixture, which was not discussed here. And some photographs before and after rehabilitation. Before rehabilitation, the cracks groove cut along the crack in the gallery, and after rehabilitation, gallery after grouting. Leakage through control structure before rehabilitation, and after rehabilitation, leakage stopped in the control structure. Poor condition of dam top road, and after rehabilitation, repaired dam top road. Distressed gantry crane and renovated gantry crane. Some issues related to dam safety, which will discuss my senior chief engineer dam safety.
Oh, it's a joint presentation. Please,
okay.
Sir. सर आधा ही टाइम छोड़े हैं उन्होंने आपके लिए.
I will take 2 minutes.
Oh,
would you like to allow me?
Please, please. You will take 4 minutes.
Thanks. Thank you very much. Respected Chairman Sir and other dignitaries, I want to highlight some issues regarding the DRIP. Definitely we have enhanced the structural life of the dams, not only in DVC, but in other dams in India through DRIP. But fact is this, that the siltation rate, due to heavy siltation, the dams are filling very fast than the designed siltation rate or designed life. Say for an example, in DVC, our dams were constructed within the period 1950 to 1960, all the 4 dams. I am giving some statistics. Already more than 50% of the dead storage zone has been filled up. The conservation zones has been filled up about 30 to 35%. Even in last 10 to 15 years, we are observing that the flush storage zone, even it is depleting very fast due to siltation. Second statistics is this, that the filling rate in the dead storage zone has been reduced remarkably, and the rate of siltation has been increased in the conservation zone, where from we will supply the water throughout the year. Practically, the reservoir life is the operational life, that the reliable supply will definitely be hampered by the year of 2050, 40s, it will be started. And it has a very good studies we have carried out over this issue. So, I suggest that the only sustainable solution is to take up the watershed treatment, catchment area treatment. And for that, if we can arrange money like this sort of projects through funding by the World Bank or by the national levels, our dams will survive for a long time, because the construction of the new dams, reservoirs is not the solution. Second point is this, we are in a position to collect a lot of data. We are getting the data in the interval of 1 hour interval. If we want, we can collect the data even in minutes, even in seconds, through real-time data acquisition system. But we are having no standardization. We are having no policy. What will be the frequency of collection of data? That should be sought out. And what will do with this huge data? What is its usefulness, how it will be used, or how it will be processed? All these directives are required very much. Yes, we have started, the Dam Safety Act has come in the last year, but definitely there are also some provisions. But besides, some more provisions are required to include how the reservoir inflow will be estimated. We usually use the mass balance equation, all of us we know. But in India, in different river basins, different practices are followed regarding consideration of the losses, which should be standardized. Then the reservoir siltation studies or survey, capacity survey, to take up the capacity surveys in the definite interval. So, and lastly, the climate change studies, it should be made the compulsory for all the river basins. Unless we are doing all these things, we will not be able to reach our goal. This we feel. Thank you, Chairman Sahab.
Thank you.
And lastly, I request, if Chairman Sahab likes, because the recommendation passes from this sort of seminars, this sort of platforms, to include my suggestive measures in the, so that it reaches to the ministry, and the next course of action can be made accordingly. And definitely, DVC will be the first. If the money is granted for the watershed treatment, then we'll take this help.
Okay,
thank you.
Stay on, sir. Yeah, he raised quite a good number of, 3-4 of sensitive issues and questions. So, of course, this house has no mandate to resolve on that. So I would say that if anybody has further comments to add on the issues raised by Dipankar Chaudhary Sahab. He raised, one important thing is that there is no standardization of data acquisition. right from frequency to spatial extent. Another one is that unless you control the catchment for the flow of the silt in the body of the dam, I mean, you cannot go on controlling the collected sand unless you control the getting into that impoundment itself. So those are the issues which I could understand. If there are any audience question from far end to this side, we will take that. Yeah. We'll take one question only because he's already answered most of the things.
So, whatever he has pointed out, there valid, valid questions faced by the field officers. I am Sanjay Belsare from Chief Engineer, Government of Maharashtra.
Right, sir.
So basically, siltation, it has been only discussed, but nothing has come out
in terms of solutions.
So in Maharashtra, we are thinking of desilting of dam. So that is one thought going on from last 3 years. But somehow we are not come out.
But he raises that desilting is one thing, but how do you prevent the silt coming?
Yes, that is the solution where we should concentrate upon, because that has been left out. We just
forestation.
No.
I mean,
watershed, catchment area treatment, afforestation, these are the plans which was discussed at the time of construction, but never been attended. So this is the thing which has to be dealt as a dam sustainable management. So this is
right. Thank you.
And what I wanted to share with you, that where we are struggling and we are not getting answer also, but if audience have work on that, we would like to know about the desilting of dam. So that is a very, not to you, but if somebody is working.
I think these kind of questions indicate that we have come to the conclusion or the concluding session of the conference. When in any conference, some issues which are perpetual, unsolvable for either social, political reasons, that is the closing, but we cannot be ignorant about this issue that unless you kind of handle the issue in totality, the watershed area, all problems will get concentrated at the dam site level. Thank you, sir.
Yes, sir, just I want to mention that the desiltation is not the solution. Desiltation can be carried out in the small reservoirs or dams. I have a lot of studies in this issue. I have seen that. But the reservoirs like Maithon, Panchet, where the capacity is more than 1,000 million cubic meter, desiltation is not the solution. Yes, desiltation can be done to take up some individual measures. Like if siltation is getting more near the intake point of the reservoirs, then we can desilt and we can make the channel. If water is not coming to the reservoirs at the head end, there is some problems due to siltation, then we can clear it.
Yeah.
But not as a whole. Thank you.
Thank you. So, thank you very much, Deepankar Chaudhary Sahab. Now we have actually the last presentation, which has come from Midas Softwares, and the title is something different, but I am reading it like this: Seismic Analysis of Concrete, Gravity and CFRD Dam using 3D Finite Element on Midas platform. I am correcting your title. May I know who is the presenter?
I'm Harsha, sir.
Harsha.
Yeah.
Thank you. Harsha, you have 8 minutes or maybe 7 minutes.
Sure.
Because I want to give you more time for questioning.
Definitely.
So that the entire house gets warmed up with the questions and discussion.
Sure, sir. I will try to finish it.
Finish in 7 minutes.
Yeah.
Thank you.
Hello, everyone. Good evening. This is Harsha from Midas IT. I'm a senior geotechnical engineer working in Midas since 2018. We are very happy that we are a part of this conference, and thanks for the organizers for allowing us, and thanks for the chair to provide me an opportunity to discuss about the 3D seismic finite element analysis of a concrete.
Call it seismic analysis of concrete, gravity and CFRD dam using 3D finite element.
Sure, sir. Sorry for that. Yeah.
There's nothing seismic 3D about seismic. Seismic is anyway 3D.
Correct.
What is 3D is your element.
Yes, sir, I will come to that in the presentation, yeah.
Yeah.
So this is a topic, so as Chairman has corrected me, it's the finite element analysis, it's a method, and we are doing a seismic analysis for a 3D model of a concrete gravity dam and a CFRD dams in a detailed way. So my contents for today's presentation will be as follows. So at first, we will try to remind about the type of stability assessment of the dam generally we do. We'll just do, it's a very brief way. And then we'll see what are the required analysis for the dam design. And then we'll move on to the seismic analysis, so and what our software would provide. So that's the major part of today's presentation. Then we'll move on to the time history analysis of a concrete gravity dam, as well as the time history analysis of a CFRD dam. And then we'll move to the conclusion. So
This is a non-linear analysis.
it's a non-linear analysis.
It's non-linear.
Correct.
Okay.
Yeah. So moving on, the first thing is the stability assessment. So in order to design a dam, there are a lot of different kinds of stability assessments to determine the dam behavior. So there are many methods like the physical methods like scale down physical testing, there are like limit equilibrium methods, there are other analytical methods, and there are some empirical equations and some numerical methods as well. So widely used among them are the physical testing, and wherein we scale down our model, and then we are trying to get the actual site condition. We'll try to simulate them in the scale down model, and we'll get the results like the displacements in all the 3 directions, and we'll try to get the stresses where and all the pressure cells are placed. So the biggest limitation of this approach is it's difficult to keep the site-related conditions like complex geology situations and at times the real earthquake scenarios to be simulated at the physical test. But more or less, it's very widely popular testing procedure. And then we have a limit equilibrium method. As the name itself suggests, it's like limiting the equilibrium. Like we have many assumptions being considered in different methods for analyzing the slope and so on. And then we have the numerical analysis. So there are many kinds of numerical analysis. We have the finite element analysis. We have finite volume or finite difference method. And then we have a discrete element method, and we have a boundary element method. So each type of method is having its own advantages and disadvantages. So based on the requirements of the client, we can choose the proper one. And coming to the important thing, so the numerical analysis could replace or could be a possible alternative for the traditional analysis, because it provides you with a lot of results. That's the first thing. And then it provides you with the results without compromising on the equilibrium situations as well as these real site situations. And there are some assumptions, of course, but we'll try to discuss them here. So at first, we are focusing more on a finite element method. So we may get, I will be talking about the type of results to give a complete idea about the software. So you may get the failure surface and the corresponding factor safety of a catchment area or a reservoir, or or else you can find the failure surface and factor safety of a dam as well. And then you may find the theoretical surfaces, you can find the flow lines, you will find the state of the material, like whether it is yielding or not, whether it is still in the elastic zone or not. And then you can find the the stresses, the principal stresses, basically the compression and tension. And then you can find the displacements and so on. So, and in addition, you can find the crack propagation in your dam as well. And moreover, you can even find the dynamic results like how the amplification of the wave is happening as it moves from focal point to the real site over there. So that's to give you a good idea. But again, we have many new challenges. Like nowadays, the soil structure interaction is having, it's taken into more important by most of the consultants and the researchers around the world, and there is a very good reason behind that. I will try to discuss that now. So the first thing is soil structure interaction is nothing but the interaction of the stiffness and the deformation between the soil or a rock over there, basically the foundation, and the structure. Then, coming to the seismic soil structure interaction, suppose let's say this is my focal point. Let's say I'm just so the P wave.
Yeah, you should focus more on the features that your software gives, other than giving the theoretical background of it. I mean, that is in your interest.
Yeah, sorry, sir.
Because time is 8 minutes. If you
sorry,
keep
sir.
on explaining SSI,
Yeah,
then your
please,
time
please
is
continue.
gone.
Okay, thanks for that. So now, like in order to move into the next things, so I would like to give more details about the seismic here.
Yes.
So the first thing is, like let's say your like a seismic wave is traveling from the focal point and reaching your structure. So consider this like in a dam over there. And as the wave is passing from the, like let's say from the bottom to the top, you will find the amplification of the wave happening over there. That means the acceleration or the displacement is going to rise a lot. So that's the main thing. We need to actually take that into picture for the design. And then there are some unexpected events like not only the consideration of the slope of the reservoir area, but also the catchment area is important based on the recent events. So these are new challenges. So we are going to discuss more on this, the seismic soil structure interaction now. And before that, I would like to show you what are the different types of analysis a typical finite element software can do. So you can do a stress analysis in order to determine the stability of the structure for a static loads. You can do steady-state seepage analysis to determine the flow paths, equipotential lines, the phreatic surface, and so on. And you can do the drawdown approach, and you can do the gradual increase in the water level by doing the transient seepage. And you can go for the slope stability analysis, both 2D as well as 3D. And then you can go for the more advanced analysis, like coupling your stress with the seepage results, like the fully coupled or semi-coupled analysis. And for a dynamic scenario, it is needed to go for dynamic analysis. And there are many kinds of dynamic-related analysis. I will come to that now. And moreover, you can also go for the heat of hydration analysis or the crab propagation analysis or thermal stresses analysis. And the last two analysis generally cannot be simulated in a traditional finite element tool, which are dam breach analysis or a particle flow or soil erosion analysis. For that, you need to go for the Lagrangian method or maybe the distinct element method. That's the other scenario. So now we are focusing on the dynamic analysis now. Suppose like we have a dam and we used to do a pseudostatic approach. So it's a very conservative approach. It's more like a stress analysis rather than the seismic analysis.
You skip that. ये theoretical part skip कर दीजिए, software की usability पे आ जाइए.
Software के बारे में कुछ बोल
क्योंकि
नहीं रहा
8
हूँ.
मिनट हो चुके हैं.
Sorry. So 3 more minutes, please.
Yeah. 8 means 2 more minutes.
Sorry for the, yeah. So we have a pseudostatic method, so wherein we are considering the, it's like more like a stress analysis. And then we have a response spectrum analysis, wherein we are actually considering the design spectrum of that particular zone, and we are doing that analysis. But here, there are many limitations at that position, like considering the effect of the model participation becomes a very tough task when you are dealing with the foundation as well, because model participation factor actually affects your the response spectrum results a lot. And then that's the reason it's important to go for the time history analysis. So wherein you're actually simulating your the real time history, acceleration time history, and then as the move, as the analysis proceed and as the wave moves from bottom to top, your deformation behavior can be considered. And moreover, you can do the eigenvalue analysis, frequency analysis to determine the different failure modes. You can do 1D ground response analysis and 2D equivalent linear analysis in order to calibrate your model, which is calibrate your seismic model. So these are the different analysis, and the Midas software does all the analysis. But my thing is not about the Midas software. Just to provide an understanding about the seismic analysis, I've come to this presentation. So now the first thing is we'll just have a 2 more minutes discussion, and then we'll go for the question and answer session.
No, please continue. Yeah. You have 1 more minute.
Yes, thanks for that. So time history analysis of a concrete gravity dam and CFRD. So in this is a very simple model which I have done. We have a concrete gravity dam over there. It's a simple elastic material given to the top. And then we have the foundation of a rock. We have given a hook-bound material. So yeah, so this is how the results could look like. It's an exaggerated view. So the thing is, we are not actually doing the response spectrum, or we are not doing the pseudostatic here, but the variation of your time history. That means you are having a loading over there.
Mr. Harsha.
Yes, sorry.
Time up. You are showing results of response spectrum analysis, whereas you are showing the ground motion at the bottom.
No. This is a time history analysis result. So 2 more minutes, please.
No, 1 minute.
Sure. So, so the thing is, the important thing in the acceleration time history is you are having a reloading and you're having unloading, you have reloading, and so the frequency varies a lot. And because of that frequency variation, the behavior and the lateral displacement variation could be like which is not similar to what you find in the response spectrum or the pseudostatic method. So hence it is important. And then we have done for a concrete, like a phased rockfill dam as well. So here, this is the cross section. Here, it's a complete rockfill, wherein the choosing the material for the rockfill is a very important thing here, because you are having like positive side movement and then negative side movement, and so on in different cycles. So the material or constitutive model which can accommodate your loading and reloading behavior is considering that behavior is a very important thing. And then whenever your model, so this is a rockfill dam, it may take a huge stress over there, and it may reach to the plastic zone, and then it may try to move to the hardening zone as well. So consideration of plastic hardening behavior is also important. So for that, we have used the hardening soil model.
Harsha, please wind up. 30 seconds.
So that's the idea. So as you can see, this is the green one is the input wave, and then output wave is your red one. So the amplification is very high because we have used the concrete as the result on the top of your dam, which is the concrete over there. And then, so this is the arch dam. So you can see very huge complex geology over there. And because of this huge complex geology, we cannot go for the traditional approaches. So in such cases, it's better to go for a numerical model. And since this is an arch dam, you can find a huge stress concentrations at the abutments. This is the principal stresses, and this is the maximum shear stress. And this is the behavior when the load or when the time history was applied along the length of the dam, because since this is an arch dam, you can see like a huge movement in that area, but it's an exaggerated view again. So in a conclusion, what I would like to say is, like I have talked about different analysis, like different advanced analysis as well. But the thing is, in order to, like for an existing structure or for an, sorry, sir, just conclude.
Discussion, where is the discussion, man? What you see, it is for your interest.
Please read it. It's very simple over there. Yeah, yes.
No. See, it is for your interest. If you tell them what is SSI, how do you, analyze the dam, what are the different methods, it doesn't really help your cause even. See,
actually,
you are here. Listen. You are here to promote Midas. And if you tell which a professor is supposed to teach in the class, then actually you are doing disservice to your company.
It was done yesterday, so we tried to kind
They're all professionals. They are not the students.
Yeah.
Let's open this house for discussion. See, I must understand. Yeah, I know Martin would definitely have a question. And yeah, Professor Martin, you should raise some relevant questions so that everyone wakes up.
Yes. Okay, we have seen this program Midas. I would just like to mention maybe 2 or 3 points. About 6 weeks ago, the U.S. Committee on Dams has published a report on inelastic analysis of embankment dams, and we have listed the software, but we have not listed your software, but we have not listed Midas. So I'm wondering what kind of material models Midas provides, which you think are better than those of your competitors like FLAC 3D and so on.
Yes, sir. There is a very long list of material models that...
No. Model you have to only 2-3 models. Damage, plasticity and blah, blah. You have to only name the models.
So the thing is, we have a huge list of material models ranging from...
Non-linear material behavior, not linear.
Yes, sir. I'm trying to come to that position, please. So we have the hardening soil model, we have the hyperbolic models, we have the concrete smear crack model, total strain model, and we have for the liquefaction scenarios, we have modified UBC sand. In order to consider the hysteresis damping, we have hardened rain, which we have hardening soil with small strain stiffness. We have
but you didn't mention any of them in your presentation. You should have been mentioning those in your presentation other than, teaching the conventional seismic analysis of concrete or CFRD dam.
Yes, it is also with the concrete, because the concrete models you have explained can be done by, let me say, ANSYS. It can be done by Abacus or Adina and so on.
Yes,
so there is nothing new on that. So, but I thought your program, Midas, I think I've been in 2 projects where we use this MIDAS, but we had some problems to trust these results. One in Colombia and one in Iran with very high seismicity. So therefore I was wondering what is the difference compared to the other software, and especially because this USSD committee is a very big one which has issued this nonlinear analysis report just in the end of August, and they do not refer to MIDAS.
Actually,
therefore I'm wondering why MIDAS should be used.
To complement, to add to the point which Martin has raised, is that there is a ICOL 2019 nonlinear analysis report, benchmark report. In that they have given the Pine Flat Dam to some 20-25 users, and the results from the prevalent software applications from ANSYS, LS Dyna, Abacus, or maybe 2-3. Some 7, popular softwares were used, and the results were compared by a committee of ICOL. That how do they, the results from different platforms compare? And they gave the benchmark problem of Pine Flat Dam with the eccentric mass shaker results of maybe 72, 73. So, see, the credibility to a software comes when it is compared to some benchmark problem. And I don't really know whether MIDAS was there or not in that list of softwares.
Yes, sir, thanks for the comments.
So this is a suggestion for you, the MIDAS people. You may be right, you may be very promising, but to add credibility to your software, you should participate into such benchmark problems where results are compared across the platforms. That is one thing. Another thing I noticed in your model that you did not model, at least show the water as a, part of the dam.
Yes, sir.
The model that you have shown is dam and rock foundation. It doesn't show the water as a,
got it. So
as
the
a domain.
representation was not done, yeah.
So I don't know whether you you missed in the drawing only, the picture only, or you didn't model it.
Yeah, it was missed in the picture, but we modeled it.
But you modeled it.
Yes, yes.
How people will trust that? All right. Thank you very much. Thank you, Mr.
Sure,
Yeah,
so we will take into the
sorry.
consideration
Any other
your
audience
suggestions,
question? Sir? Anybody who is using the numerical simulation studies for concrete dams, maybe gravity, maybe any other type, arch or buttress, or the embankments? There must be a lot of researcher or practitioner using different simulation platforms. None? Or they have already boarded the flight or train? Okay, thank you very much. Thank you, Mr.
Thank you, sir. Thanks for the...
Yeah, please. So big round of applause for everyone who waited till the last word of the conference. We have a wonderful conference. And in this session, we have 5 + 1, 5 in the regular and 1 as a spillover presentations, ranging from repair, rehabilitation to flip bucket, and then finally the simulation using MIDAS. All of them were very good, and they have made their presentation very well. I thank all the presenters. Thank you very much. Thank you extremely, my highly, appreciated thanks to all the audience. It is not a very common scenario that in a conference of 3 days, which is not even vacation days, that you have these many audience on a last day. I have seen some 15, 20 conferences myself. Last day, you don't find these many audience. So thank you. The big round of applause for the remaining audience.
All right, thank you so much, sir, for conducting this session so amazingly. And now, for the vote of thanks, I would like to call our organizer. Yeah, before the vote of thanks, also, I would like to have our chairman, sir, to kindly do the honor for the memento, presenting the memento to our participant. And first, we have Mr. Saroj Kumar Shah.
सर आ जाएगी
We have Dr. Manish K. Nema. Sorry, we have Mr. Shankar Kumar. Then we have Mr. Satish Kamboj. Mr. Anil Kumar Lohani. Please use the mic, sir. Mr. Rakesh Rathi. Then we have Mr. Harsha. And also, I would like to request our chairman, sir, to kindly do the honor for the poster presentations as well. We have Mr. Rolo Dinesh from Research Scholar at NIT Andhra Pradesh. Then we have Mr. Rajendra Singh Gujar, Research Assistant CWPRS Pune. All right, thank you so much, Chairman, sir.
Mr.
Yes, sir.
No, one spillover. आइए सर, कोई नहीं।
Yes, sir. Thank you so much, Chairman, sir. Now, for the vote of thanks, I would like to request our organizer, and I hand over the floor to you. Thank you.
So thank you, Chairman. We are at the end of the conference, and good evening, ladies and gentlemen. On behalf of INCODE, DRIP, CWC, and CBIP, it is our honor to propose vote of thanks to our dignitaries, chairman and co-chairman, all the sponsors, exhibitors, authors, delegates, without whose contribution, cooperation, it would not have been possible to organize this conference in the historic city of Jaipur. At the outset, we are thankful to our Honorable Minister for Jal Shakti, Government of India, Shri Gajendra Singh Shekhawat ji, to spare his valuable time and be with us and address the august gathering of dam and hydropower professionals who have assembled here to deliberate on the different aspects of dam safety management. We are thankful to Sri Pankaj Kumar, Secretary to Government of India, Ministry of Jal Shakti, Department of Water Resources, River Development and Ganga Rejuvenation, to participate in the opening ceremony as guest of honor and address the gathering, besides chaired the plenary session. We are also thankful to Dr. R.K. Gupta, Chairman Central Water Commission, Sri J. Chandrasekhar Iyer, Member Design and Research, Central Water Commission, and Chairman of the Technical Committee, and other officers of CWC for their guidance, help, and support time to time in organization of this conference. We are also thankful to our guest, Mr. Michel Lino, President, International Commission on Large Dam, Mr. Michel De Vivo, Secretary General, Mr. Enric Sifas, Vice President ICORD, Shri D.K. Sharma, Vice President ICORD and Chairman of the Organizing Committee,
Dr. Wieland Martin, Chairman of the High Court Committee on Seismic Aspect of Dam Design, for their valuable presence and also making the presentation during the conference. Thanks are also due to Sri Anand Kumar, Principal Secretary, Water Resources Department, Government of Rajasthan, for his benign presence and address the gathering in the opening ceremony. We are also thankful to President in Cold, Sri R.K. Bishnoi, CMD THDC India Limited, and Sri A.K. Dinkar, Secretary General in Cold, for their guidance and support for organization of this conference. Thanks are also due to the chairman, co-chairman of the different sessions, speakers for their presentations and sharing their experiences with the participants. Our special thanks to all the sponsors, platinum sponsors, NHPC, Satluj Jal Vidyut Nigam Limited, Karpi, silver sponsor, Babcos, BBMB, Team Viewers, bronze sponsor, Pinnacle Geosystem, Midas, Ayasha, Normet, NTPC, DVC. Our supporters are SMEC, THDC India Limited, NIPCO, Campbell Scientific India Private Limited. Our special thanks are also due to the exhibitor who have displayed their products, expertise, and services to the dam industry. We are extremely thankful to the management of the Birla Auditorium for providing the space for organizing this conference in Jaipur. Last but not the least, I must thank my colleague, Ms. Kalpana, without whose support and untiring, sincere, and dedicated efforts since last 2 months have resulted to put up this great show. So let us have a huge round of applause.
I'd like to have a huge round of applause, please, for Ms. Kalpana.
Wish you all the safe journey back to your place, and we see you all in our next event. Thank you all.
Thank you so much, Sunil sir. And now I would like to thank everyone for being the part of this conference, and your presence made this conference a huge success, a mega success for us all. And now you can all proceed for the tea. This tea will be served at the same menu. Thank you everyone. This is Anchor Priyal signing off.